Welcome everyone to Edureka YouTube channel. My name is Saurabh and today I'll be taking you through this entire session on DevOps full course. So we have designed this crash course in such a way that it starts from the basic topics and also covers the advanced ones. So we'll be covering all the stages and tools involved in DevOps. So this is how the modules are structured. We'll start by understanding what is the meaning of DevOps, what was the methodology before DevOps, right? So all those questions will be answered in the first module. Then we are going to talk about what is Git, how it works, and what is the meaning of version control and how we can achieve that with the help of Git. That session will be taken by Miss Reshma. Post that, I'll be teaching you how you can create really cool digital pipelines with the help of Jenkins, Maven, and Git and GitHub. After that, I'll be talking about the most famous software containerization platform, which is Docker. And post that, Vardhan will be teaching you how you can use Kubernetes for orchestrating Docker container clusters. After that, we are going to talk about configuration management using Ansible and Puppet. Now, both of these tools are really famous in the market. Ansible is pretty trending, whereas Puppet is very mature. It is there in the market since 2005. Finally, I'll be teaching you how you can perform continuous monitoring with the help of NagOS. So let's start this session, guys. We'll begin by understanding what is DevOps. So this is what we'll be discussing today. We'll begin by understanding why we need DevOps. Everything exists for a reason, so we'll try to figure out that reason. We are going to see what are the various limitations of the traditional software delivery methodologies and how DevOps overcomes all of those limitations. Then we are going to focus on what exactly is the DevOps methodology and what are the various stages and tools involved in DevOps. And then finally, in the hands-on part, I'll tell you how you can create a Docker image, how you can build it, test it, and even push it onto Docker Hub in an automated fashion using Jenkins. So I hope you all are clear with the agenda. So let's move forward, guys, and we'll see why we need DevOps. So guys, let's start with the waterfall model. Now, before DevOps, organizations were using this particular software development methodology. It was first documented in the year 1970 by Royce and was the first public documented lifecycle model. The waterfall model describes a development method that is linear and sequential. Waterfall development has distinct goals for each phase of development. Now you must be thinking, why the name waterfall model? Because it's pretty similar to a waterfall. Now what happens in a waterfall, once the water has flowed over the edge of the cliff, it cannot turn back. The same is the case for waterfall development strategy as well. An application will go to the next stage only when the previous stage is complete. So let us focus on what are the various stages involved in waterfall methodology. So notice the diagram that is there in front of your screen. If you notice, it's almost like a waterfall, or you can even visualize it as a ladder as well. So first, what happens, the client gives requirements for an application. So you gather that requirement and you try to analyze it. Then what happens, you design the application, how the application is going to look like. Then you start writing the code for the application and you build it. When I say build it, it involves multiple things: compiling your application, unit testing, then even it involves packaging as well. After that, it is deployed onto the test servers for testing and then deployed onto the prod servers for release. And once the application is live, it is monitored. Now, I know this model looks perfect, and trust me, guys, it was at that time. But think about it. What will happen if we use it now? Fine, let me give you a few disadvantages of this model. So here are a few disadvantages. So first one is, once the application is in the testing stage, it is very difficult to go back and change something that was not well thought out in the concept stage. Now, what I mean by that, suppose you have written the code for the entire application, but in testing, there is some bug in that particular application. Now, in order to remove that bug, you need to go through the entire source code of the application, which used to take a lot of time, right? So that is one very big limitation of waterfall model. Apart from that, no working software is produced until late during the life cycle. We saw that when we are discussing about various stages of waterfall model. There are high amount of risk and uncertainty, which means that once your product is live, it is there in the market. Then if there is any bug or any downtime, then you have to go through the entire source code of the application again. You have to go through that entire process of waterfall model that we just saw in order to produce a working software again, right? So that's how it used to take a lot of time. There's a lot of risk and uncertainty. And imagine if you have upgraded some software stack in your production environment and that led to the failure of your application. Now, to go back to the previous stable version used to also take a lot of time. Now, it is not a good model for complex and object-oriented projects, and it is not suitable for the projects where requirements are at a moderate to high risk of changing. So what I mean by that, suppose your client has given you a requirement for a web application today. Now, you have taken your own sweet time and you are in a condition to release the application, say, after 1 year. Now, after 1 year, the market has changed. The client does not want a web application. He's looking for a mobile application now. So this type of model is not suitable where requirements are at a moderate to high risk of changing. So there's a question popped on my screen. It is from Jessica. She's asking, so all the iteration in the waterfall model goes through all the stages? Well, there are no iteration as such, Jessica. First of all, it is not agile methodology or DevOps, it is waterfall model, right? There are no iterations. Once the stage is complete, then only it'll be going to the next stage. So there are no iterations as such. If you're talking about the application when it is live, and then there is some bug or there is some downtime, then at that time, based on the kind of bug which is there in the application, suppose there might be a bug because of some flawed version of a software stack installed in your production environment, probably some upgraded version. Because of that, your application is not working properly. So you need to roll back to the previous stable version of the software stack in your production environment. So that can be one bug. Apart from that, there might be bugs related to the code in which you have to check the entire source code of the application again. Now, if you look at it, to roll back and incorporate the feedback that you have got is used to take a lot of time, right? So I hope this answers your question. All right, she's fine with the answer. Any other questions, any other doubts you have, guys, you can just go ahead and ask me. Fine. So there are no questions right now. So I hope we have understood what was the traditional waterfall model. What are the various limitations of this waterfall model? Now we are going to focus on the next methodology that is called the agile methodology. Now, agile methodology is a practice that promotes continuous iteration of development and testing throughout the software development lifecycle of the project. So the development and the testing of an application used to happen continuously with the agile methodology. So what I mean by that, if you focus on the diagram that is there in front of your screen, so here we get the feedback from the testing that we have done in the previous iteration. We design the application again, then we develop it, then again we test it, then we discover a few things that we can incorporate in the application. We again design it, develop it, and there are multiple iterations involved in development and testing of a particular application. So in agile methodology, each project is broken up into several iterations, and all iterations should be of the same time duration. And generally, it is between 2 to 8 weeks. And at the end of each iteration, a working product should be delivered. So this is what agile methodology in a nutshell is. Now let me go ahead and compare this with the waterfall model. Now, if you notice in the diagram that is there in front of your screen, so waterfall model is pretty linear and it's pretty straight, as you can see it from the diagram, that we analyze the requirements, we plan it, design it, build it, test it, and then finally we deploy it onto the prod servers for release. But when I talk about the agile methodology, over here, the design, build, and testing part is happening continuously. We are writing the code, we are building the application, we are testing it continuously. And there are several iterations involved in this particular stage. And once the final testing is done, it is then deployed onto the prod servers for release, right? So agile methodology basically breaks down the entire software delivery lifecycle into small sprints or iterations that we call it, due to which the development and the testing part of the software delivery lifecycle used to happen continuously. Let's move forward and we are going to focus on what are the various limitations of agile methodology. The first and the biggest limitation of agile methodology is that the dev part of the team was pretty agile, right? The development and testing used to happen continuously. But when I talk about deployment, then that was not continuous. There was still a lot of conflicts happening between the dev and the ops side of the company. The dev team wants agility, whereas the ops team wants stability. And there's a very common conflict that happens, and a lot of you can actually relate to it, that the code works fine in the developer's laptop, but when it reaches to production, there is some bug in the application, or it does not work in the production at all. So this is because of some inconsistency in the computing environment that has caused that, and due to which the operations team and the dev team used to fight a lot. There were a lot of conflicts, guys, at that time happening. So agile methodology made the dev part of the company pretty agile, but when I talk about the ops side of the company, they needed some solution in order to solve the problem that I've just discussed, right? So I hope you are able to understand what kind of a problem I'm focusing on. If you go back to the previous diagram as well, so over here, if you notice, only the design, build, and test, or you can say development, building, and testing part is continuous, right? The deployment is still linear. You need to deploy it manually onto the various prod servers. That's what was happening in the agile methodology, right? So the error that I was talking about, due to which our application is not working fine. I mean, once your application is live and due to some software stack in the production environment, it doesn't work properly. Now to go back and change something in the production environment used to take a lot of time. For example, you have upgraded some particular software stack, and because of that, your application is not at all working. It fails to work. Now, to go back, the previous stable version of the software stack, the operations team was taking a lot of time because they have to go through the long scripts that they have written on in order to provision the infrastructure. So let me just give you a quick recap of the things that we have discussed till now. We have discussed quite a lot of history. We started with the waterfall model. The traditional waterfall model, we understood what are its various stages and what are the limitations of this waterfall model. Then we went ahead and understood what exactly is agile methodology and how is it different from the waterfall model and what are the various limitations of the agile methodology. So this is what we have discussed till now. Now we are going to look at the solution to all the problems that we have just discussed. And the solution is none other than DevOps. DevOps is basically a software development strategy which bridges the gap between the dev side and the ops side of the company. So DevOps is basically a term for a group of concepts that, while not all new, have catalyzed into a movement and are rapidly spreading throughout the technical community. Like any new and popular term, people may have confused and sometimes contradictory impressions of what it is. So let me tell you guys, DevOps is not a technology, it is a methodology. So basically, DevOps is a practice dedicated to the study of building, evolving, and operating rapidly changing systems at scale. Now, let me put this in simpler terms. So, DevOps is the practice of operations and development engineers participating together in the entire software lifecycle from design through the development process to production support. And you can also say that DevOps is also characterized by operations staff making use many of the same techniques as developers for their system work. I'll explain you that how is this definition relevant because all we are saying here is DevOps is characterized by operations staff making use many of the same techniques as developers for their systems work. So when I will explain you infrastructure as code, you'll understand why I'm using this particular definition, right? So as you know that DevOps is a software development strategy which bridges the gap between the dev part and the ops side of the company and helps us to deliver good quality software in time. And how this happens? This happens because of various stages and tools involved in DevOps. So here is a diagram which is nothing but an infinite loop because everything happens continuously in DevOps, guys. Everything starting from coding, testing, deployment, monitoring, everything is happening continuously. And these are the various tools which are involved in the DevOps methodology, right? So not only the knowledge of these tools are important for a DevOps engineer, but also how to use these tools. How can I architect my software delivery lifecycle such that I get the maximum output, right? So it doesn't mean that, if I have a good knowledge of Jenkins or Git or Docker, then I become a DevOps engineer. No, that is not true. You should know how to use them. You should know where to use them to get the maximum output. So I hope you have got my point, what I'm trying to say here. In the next slide, I'll be discussing about various stages that are involved in DevOps. Fine, so let's move forward, guys, and we are going to focus on various stages involved in DevOps. So these are the various stages involved in DevOps. Let me just take you through all of these stages one by one. So starting from version control. So I'll be discussing all of these stages one by one as well, but let me just give you an entire picture of these stages in one slide first. So version control is basically maintaining different versions of the code. What I mean by that, suppose there are multiple developers writing a code for a particular application. So how will I know that which developer has made which commit at what time and which commit is actually causing the error? And how will I revert back to the previous commit? So I hope you're getting my point. My point here is how will I manage that source code? Suppose developer A has made a commit and that commit is causing some error. Now, how will I know that developer A has made that commit and at what time he made that commit and where in the code was that editing happened, right? So all of these questions can be answered once you use version control tools like Git, Subversion, etc., etc. We are going to focus on Git in our course. So then we have continuous integration. So continuous integration is basically building your application continuously. What I mean by that, suppose any developer made a change in the source code, a continuous integration server should be able to pull that code and prepare a build. Now, when I say build, people have this misconception of, only compiling the source code. It is not true, guys. It includes everything, starting from compiling your source code, validating your source code, code review, unit testing, integration testing, etc., etc., and even packaging your application as well. Then comes continuous delivery. Now, the same continuous integration tool that we are using, suppose Jenkins. Now, what Jenkins will do once the application is built, it will be deployed onto the test servers for testing to perform, user acceptance tests or end user testing that you call it. There will be using tools like Selenium, right, for performing automation testing. And once that is done, it'll be then deployed onto the prod servers for release, right? That is called continuous deployment. And here we'll be using configuration management and containerization tools. So this is basically to provision your infrastructure, to provision your prod environment. And let me tell you guys, continuous deployment is something which is not a good practice, because before releasing your product in the market, there might be multiple checks that you want to do before that, right? There might be multiple other testings that you want to do. So you don't want this to be automated, right? That's why continuous deployment is something which is not preferred. After continuous delivery, we can go ahead and manually use configuration management tools like Puppet, Chef, Ansible, and SaltStack, or we can even use Docker for a similar purpose, and then we can go ahead and deploy it onto the prod service for release. And once the application is live, it is continuously monitored by tools like nagios or Splunk, which will provide the relevant feedback to the concerned teams, right? So these are various stages involved in DevOps, right? So now let me just go back to clear if there are doubts. So this is how various stages are scheduled, various jobs are scheduled. So we have Jenkins here, we have a continuous integration server. So what Jenkins will do, the moment any developer makes a change in the source code, it will take that code and then it will trigger a build using tools like Maven or Ant or Gradle. Once that is done, it will deploy it onto the test servers for testing, for end user testing using tools like Selenium, JUnit, etc. Then what happens, it will automatically take that tested application and deploy it onto the prod servers for release, right? And then it is continuously monitored by tools like nagios, Splunk, ELK, etc., etc. So Jenkins is basically heart of DevOps lifecycle. It gives you a nice 360-degree view of your entire software delivery lifecycle. So with that UI, you can go ahead and have a look how your application is doing currently, right? Where in which stage it is in right now, testing is done or not. All those things you can go ahead and see in the Jenkins dashboard, right? So there might be multiple jobs running in the Jenkins dashboard that you can see, and it gives you a very good picture of the entire software delivery lifecycle, guys. Don't worry, I'm going to discuss all of these stages in detail when we move forward. So we are going to discuss each of these stages one by one, starting from source code management, or even called as version control. Now, what happens in source code management? There are two types of source code management approaches. One is called centralized version control, and another one is called the distributed version control. So source code management. Now imagine there are multiple developers writing a code for an application. If there is some bug introduced, how will we know which commit has caused that error, and how will I revert back to the previous version of the code? In order to solve these issues, source code management tools were introduced. And there are two types of source code management tools. One is called centralized version control and another is distributed version control. So let's discuss the centralized version control first. So centralized version control system uses a central server to store all the files and enables team collaboration. It works in a single repository to which users can directly access a central server. So this is what happens here, guys. So every developer has a working copy, the working directory. So the moment they want to make any change in the source code, they can go ahead and make a commit in the shared repository, right? And they can even update their working copy by, pulling the code that is there in the repository as well. So the repository in the diagram that you're noticing indicates a central server that could be local or remote, which is directly connected to each of the programmer's workstation, as you can see. Now, every programmer can extract or update their workstation with the data present in the repository, or can even make changes to the data or commit it in the repository. Every operation is performed directly on the central server or the central repository. Even though it seems pretty convenient to maintain a single repository, but it has a lot of drawbacks. But before I tell you the drawbacks, let me tell you what advantage we have here. So first of all, if anyone makes a commit in the repository, there will be a commit ID associated to it, and there will always be a commit message. So you know which person has made that commit and at what time, and where in the code basically, right? So you can always revert back. But let me now discuss few disadvantages. First of all, it is not locally available, meaning you always need to be connected to a network to perform any action. It is always not available locally, right? So you need to be connected with some sort of network basically. Since everything is centralized, in case of the central server getting crashed or corrupted, it will result in losing the entire data of the project, right? So that's a very serious issue, guys. And that is one of the reasons why industries don't prefer centralized version control system. Let's talk about the distributed version control system now. Now, these systems do not necessarily rely on a central server to store all the versions of the project file. So in distributed version control system, every contributor has a local copy or clone of the main repository. As you can see, I'm highlighting with my cursor right now. That is, everyone maintains a local repository of their own, which contains all the files and metadata present in the main repository. As you can see then the diagram as well, every programmer maintains a local repository on its own, which is actually the copy or clone of the central repository on their hard drive. They can commit and update their local repository without any interference. They can update their local repositories with new data coming from the central server by an operation called pull, and affect changes to the main repository by an operation called push, right? Operation called push from the local repository. Now, you must be thinking what advantage we get here. What are the advantages of distributed version control over the centralized version control? Now, basically, the act of cloning an entire repository gives you that advantage. Let me tell you how. Now, all operations apart from push and pull are very fast because the tool only needs to access the hard drive, not a remote server. Hence, you do not always need an internet connection. Committing new change sets can be done locally without manipulating the data on the main repository. Once you have a group of change sets ready, you can push them all at once. So what you can do is you can actually commit to your local repository, which is there in your local hard drive. You can commit the changes that you want in the source code. You can, once review it, and then once you have quite a lot of change sets ready, you can go ahead and push it onto the central server as well. If the central server gets crashed at any point of time, the lost data can be easily recovered from any one of the contributors' local repository. This is one very big advantage. Apart from that, since every contributor has a full copy of the project repository, they can share changes with one another if they want to get some feedback before affecting the changes in the main repository as well. So these are the various ways in which distributed version control system is actually better than the centralized version control system. So we saw the two types of source code management systems, and I hope you have understood it. We are going to discuss one source code management tool called Git, which is very popular in the market right now. Almost all of the companies actually use Git. For now, I'll move forward and we're going to focus on a source code management tool, a distributed version control tool that is called as Git. Now, before I move forward, guys, let me make this thing clear. So when I say version control or source code management, it's one and the same thing. Let's talk about Git now. Now, Git is a distributed version control tool that supports distributed non-linear workflows by providing data assurance for developing quality software, right? So it's a pretty tough definition to follow, but it'll be easier for you to understand with the diagram that is there in front of your screen. So for example, I am a developer and this is my working directory, right? Now what I want to do is I want to make some changes to my local repository because it is a distributed version control system. I have my local repository as well. So what I'll do, I'll perform a git add operation. Now because of git add, whatever was there in my working directory will be present in the staging area. Now you can visualize the staging area as something which is between the working directory and your local repository, right? And once you have done git add, you can go ahead and perform git commit to make changes to your local repository. And once that is done, you can go ahead and push your changes to the remote repository as well. After that, you can even perform git pull to add whatever's there in your remote repository to your local repository and perform git checkout to add everything which was there in your local repository to your working directory as well. All right, so let me just repeat it once more for you guys. So I have a working directory here. Now, in order to add that to my local repository, I need to first perform git add that will add it to my staging area. Staging area is nothing but an area between the working directory and the local repository. After git add, I can go ahead and execute git commit, which will add the changes to my local repository. Once that is done, I can perform git push to push the changes that I made in my local repository to the remote repository. And in order to pull the changes which are there in the remote repository to the local repository, you can perform git pull and finally git checkout that will be added to your working directory as well. And git merge is also a pretty similar command. Now, before we move forward, guys, let me just show you a few basic commands of Git. So I've already installed Git in my CentOS virtual machine. So let me just quickly open my CentOS virtual machine to show you a few basic operations that you can perform with Git. CentOS virtual machine, and I've told you that I've already installed Git. Now, in order to check the version of Git, you can just type in here git hyphen version, and you can see that I have 2.7.2 here. Let me go ahead and clear my terminal. So now let me first make a directory and let me call this as edureka hyphen repository. And I'll move into this edureka repository. So first thing that I need to do is initialize this repository as an empty Git repository. So for that, all I have to type here is git init, and it will go ahead and initialize this empty directory as a local Git repository. So it has been initialized now. As you can see, initialize empty Git repository in home edureka hyphen report.git. All right then. So over here, I'm just going to create a file, a Python file. So let me just name that as edureka.py. And I'm going to make some changes in this particular file. So I'll use gedit for that. I'm just going to write in here a normal print statement. Welcome to edureka. Close the parenthesis, save it, close it. Let me clear my terminal. Now, if I hit an ls command, so I can see that edureka.py file is here. Now, if you can recall from the slides, I was telling you in order to add a particular file or a directory into the local Git repository, first I need to add it to my staging area. And how will I do that? By using the git add command. So all I have to type here is git add and the name of my file, which is edureka.py. And here we go. So it is done now. Now, if I type in here git status, it will give me the files which I need to commit. So this particular command gives me the status. Status as in it will tell me what all files I need to commit to the local repository. So it says one new file has been created, that is edureka.py in the stage, and it is present in the staging area. And I need to commit this particular file. So all I have to type here is git commit -m and the message that I want. So I'll just type in here first commit, and here we go. So it is successfully done now. So I've added a particular file to my local Git repository. So now what I'm going to show you is basically how to deal with the remote repositories. So I have a remote Git repository present on GitHub. So I've created a GitHub account. So the first thing that you need to do is create a GitHub account, and then you can go ahead and create a new repository there. And then I'll tell you how to add that particular repository to your local Git repository. Let me just go to my browser once. Let me just zoom it a bit, and yeah. So this is my GitHub account, guys. And what I'm going to do is I'm first going to go to this repositories tab, and I'm going to add one new repository. So I'll click on new. I'm going to give a name to this repository. So whatever name that you want to give, you just go ahead and do that. Let me just write here git tutorial DevOps, whatever name that you feel like. Just go ahead and write that. I'm going to keep it public. If you want any description, you can go ahead and give that. And I can also initialize it with a README. Create repository, and that's all you have to do in order to create a remote GitHub repository. Now over here, you can see that there's only one readme.md file. So what I'm going to do, I'm just going to copy this particular SSH link, and I'm going to perform git remote add origin, and the link that I've just copied, I'll paste it here, and here we go. So this has basically added my remote repository to my local repository. Now what I can do is I can go ahead and pull whatever is there in my remote repository to my local Git repository. For that, all I have to type here is git pull origin master, and here we go. So it is done now. As you can see that I've pulled all the changes. So let me clear my terminal and hit an ls command. So you'll find readme.md present here, right? Now what I'm going to show you is basically how to push this edureka.py file onto my remote repository. So for that, all I have to type here is git push origin master, and here we go. So it is done now. Let me just go ahead and refresh this particular repository, and you'll find edureka.py file here. Let me just go ahead and reload this. So you can see edureka.py file where I've written welcome to Edureka. So it's that easy, guys. Let me clear my terminal now. So I've covered few basics of Git. So let's move forward with this DevOps tutorial, and we are going to focus on the next stage, which is called continuous integration. So we have seen few basic commands of Git. We saw how to initialize an empty directory into a Git repository, how we can, add a file to the staging area, and how we can go ahead and commit it in the local repository. After that, we saw how we can push the changes in the local repository to the remote repository. My repository was on GitHub. I told you how to connect with that remote repository, and then how even you can pull the changes from the remote repository, right? So all of these things we have discussed in detail. Now let's move forward, guys, and we are going to focus on the next stage, which is called continuous integration. So continuous integration is basically a development practice in which the developers are required to commit changes to the source code in a shared repository several times a day, or you can say more frequently. And every commit made in the repository is then built. This allows the teams to detect the problems early. So let us just understand this with the help of the diagram that is there in front of your screen. So here we have multiple developers which are writing code for a particular application, and all of them are committing code to a shared repository, which can be a Git repository or a Subversion repository. From there, the Jenkins server, which is nothing but a continuous integration tool, will pull that code the moment any developer commits a change in the source code. The moment any developer commits a change in the source code, Jenkins server will pull that, it will prepare a build. Now, as I have told you earlier as well, build does not only mean compiling the source code. It includes compiling, but apart from that, there are other things as well. For example, code review, unit testing, integration testing, packaging your application into an executable file. It can be a WAR file or it can be a jar file. So it happens in a continuous manner. The moment any developer commits a change in the source code, Jenkins server will pull that, prepare a build. right? So this is called as continuous integration. So Jenkins has various tools in order to perform this. So it has various tools for development, testing, and deployment technologies. It has well over 2,500 plugins. So you need to install that plugin and you can just go ahead and trigger whatever job you want with the help of Jenkins. It is originally written in Java, right? And let's move forward and we are going to focus on continuous delivery now. So continuous delivery is nothing but taking continuous integration to the next step. So what are we doing in a continuous manner or in an automated fashion? We are taking this build application onto the test server for end user testing or unit or user acceptance test, right? So that is basically what is continuous delivery. So let us just summarize continuous delivery again. Moment any developers makes a change in the source code, Jenkins will pull that code, prepare a build. Once build is successful, it will take the build application and Jenkins will deploy it onto the test server for end user testing or user acceptance test. So this is basically what continuous delivery is. This happens in a continuous fashion. So what advantage we get here? Basically, if there's a build failure, then we know which commit has caused that error and we don't need to go through the entire source code of the application. Similarly, for testing, even if any bug appears in testing as well, we know which commit has caused that error and we can just go ahead and have a look at that particular commit instead of checking out the entire source code of the application. So basically this system allows the teams to detect problems early, right? As you can see it from the diagram as well. Now, if you want to learn more about Jenkins, I'll leave a link in the chat box. You can go ahead and refer that. And people who are watching it on YouTube can find that link in the description box below. Now we're going to talk about continuous deployment. So continuous deployment is basically taking the application, the build application that you have tested and deploying that onto the prod servers for release in an automated fashion. So once the application is tested, it will automatically be deployed onto the prod servers for release. Now, this is something not a good practice, as I've told you earlier as well, because there might be certain checks that you need to do in order to release your software in the market, or you might want to market your product before that. So there are a lot of things that you want to do before deploying your application. So it's not advisable or a good practice to, actually automatically deploying your application onto the prod servers for release. So this is basically continuous integration, delivery, and deployment. Any questions you have, guys, you can ask me. All right, so Jagrati wants me to repeat it once more. Sure, Jagrati, I'll do that. Let's start with continuous integration. So continuous integration is basically committing the changes in the source code more frequently, and every commit will then be built using a Jenkins server, right? Or any continuous integration server. So this Jenkins, what it'll do, it'll trigger a build the moment any developer commits a change in the source code. And build includes your compiling, code review, unit testing, integration testing, packaging, and everything. So I hope you're clear with what is continuous integration. It is basically continuously building your application. The moment any developer commits a change in the source code, Jenkins will pull that code and prepare a build. Let's move forward. And now I'm going to explain you continuous delivery. Now in continuous delivery, the package that we have created here, the var or the jar file or the executable file, Jenkins will take that package and it will deploy it onto the test server for end user testing. So this kind of testing is called the end user testing or user acceptance test, where you need to deploy your application onto a server, which can be a replica of your production server, and you perform end user testing, or you call it user acceptance test. For example, in my application, if I want to check all the functions, right, functional testing, if I want to perform functional testing of my application, I'll first go ahead and check whether my search engine is working. Then I'll check whether people are able to log in or not. So all those functions of a website when I check, or an application when I check, is basically after deploying it onto a server, right? So that sort of testing is basically what is your functional testing, or what I'm trying to refer here. Next up, we are going to continuously deploy our application onto the prod servers for release. So once the application is tested, it will be then deployed onto the prod servers for release. And I've told you earlier as well, it is not a good practice to deploy your application continuously or in an automated fashion. So guys, we have discussed a lot about Jenkins. How about I show you how Jenkins UI looks like and how you can download plugins and all those things. So I've already installed Jenkins in my CentOS virtual machine. So let me just quickly open my CentOS virtual machine. So guys, this is my CentOS virtual machine again, and over here I've configured my Jenkins on localhost port 8080 slash Jenkins, and here we go. Just need to provide the username and password that you have given when you were installing Jenkins. So this is how Jenkins looks like, guys. Over here, there are multiple options. You can just go and play around with it. Let me just take you through a few basic options that are there. So when you click on new item, you'll be directed to a page which will ask you to give a name to your project. So give whatever name that you want to give. Then choose the kind of project that you want, right? And then you can go ahead and provide the required specifications, required configurations for your project. Now, when I was talking about plugins, let me tell you how you can actually install plugins. So you need to go to Manage Jenkins, and here's a tab that you'll find Manage Plugins. So in this tab, you can find all the updates that are there for the plugins that you have already installed. In the available section, you'll find all the available plugins that Jenkins support. So you can just go ahead and search for the plugin that you want to install, just check it, and then you can go ahead and install it. Similarly, the plugins that are installed will be found in the install tab, and then you can go ahead and check out the advanced tab as well. So this is something different. Let's not just focus on this for now. Let me go back to the dashboard. And this is basically one project that I've executed, which is called Edureka Pipeline. And this blue color symbolizes that it was successful. The blue color ball means it was successful. That's how it works, guys. So I was just giving you a tour to the Jenkins dashboard. We'll actually execute the practical as well. So we'll come back to it later. But for now, let me open my slides and we'll proceed with the next stage in the DevOps lifecycle. So now let's talk about configuration management. So what exactly is configuration management? So now let me talk about few issues with the deployment of a particular application or provisioning of the servers. So basically what happens, I have built my application, but when I deploy it onto the test servers or onto the prod servers, there are some dependency issues because of which my application is not working fine. For example, in my developer's laptop, there might be some software stack which was upgraded, but in my prod and in the test environment, they're still using the outdated version of that software stack, because of which the application is not working fine. This is just one example. Apart from that, what happens when your application is live and it goes down because of some reason? And that reason can be you have upgraded a software stack. Now, how will you go back to the previous stable version of that software stack? So there are a lot of issues with the admin side of the company, the ops side of the company, which were removed with the help of configuration management tools. So, before admins used to write these long scripts in order to provision the infrastructure, whether it's the test environment or the prod environment or the dev environment. So they used to write those long scripts, right, which was prone to error. Plus, it used to take a lot of time. And apart from that, the admin who has written that script, no one else can actually recognize what's the problem with it if you have to debug it. So there are a lot of problems that were there with the admin side or the ops side of the company, which were removed by the help of configuration management tools. And one very important concept that you guys should understand is called infrastructure as code, which means that writing code for your infrastructure. That's what it means. Suppose if I want to install LAMP stack on all of these three environments, whether it's dev, test, or prod, I'll write the code for installing LAMP stack in one central location, and I can go ahead and deploy it onto dev, test, and prod. So I have the record of the system state present in my one central location. Even if I upgrade it to the next version, I still have the record of the previous stable version of the software stack, right? So I don't have to manually go ahead and write scripts and deploy it onto the nodes. This is that easy, guys. So now let me just focus on few challenges that configuration management helps us to overcome. First of all, it can help us to figure out which components to change when requirements change. It also helps us in redoing an implementation because the requirements have changed since the last implementation. And very important point, guys, that it helps us to revert to a previous version of the component if you have replaced with a new but the flawed version. Now, let me tell you the importance of configuration management through a use case. Now, the best example I know is of New York Stock Exchange. A software glitch prevented the NYSE from trading stocks for almost 90 minutes. This led to millions of dollars of loss. A new software installation caused the problem. That software was installed on 8 of its 20 trading terminals, and the system was tested out the night before. However, in the morning, it failed to operate on the 8 terminals. So there was a need to switch back to the old software. Now, you might think that this was a failure of NYSE's configuration management process, but in reality, it was a success. As a result of proper configuration management, NYSE recovered from that situation in 90 minutes, which was pretty fast. Had the problem continued longer, the consequences would have been more severe, guys. So I hope you have understood its importance. Now let's focus on various tools available for configuration management. So we have multiple tools like Puppet, Chef, Ansible, and SaltStack. I'm going to focus on Puppet for now. So Puppet is a configuration management tool that is used for deploying, configuring, and managing servers. So let's see what are the various functions of Puppet. So first of all, you can define distinct configurations for each and every host and continuously check and confirm whether the required configuration is in place and is not altered on the host. So what I mean by that, you can actually define distinct configurations. For example, in my one particular node, I need this software stack. In another node, I need this software stack. So I can, define distinct configurations for different nodes and continuously check and confirm whether the required configuration is in place and is not altered. And if it is altered, Puppet will revert back to the required configurations. This is one function of Puppet. It can also help in dynamic scaling up and scaling down of machines. So what will happen if in your company, there's a big billion day sale, right? And you're expecting a lot of traffic. So at that time, in order to provision more servers, probably today your task is to provision 10 servers and tomorrow you might have to provision say 100 VMs. right? So how will you do that? You cannot go ahead and do that manually by writing scripts. You need tools like Puppet that can help you in dynamic scaling up and scaling down of machines. It provides control over all of your configured machines, so a centralized change gets propagated to all automatically. So it follows a master slave architecture in which the slaves will poll the central server for changes made in the configuration. So we have multiple nodes there which are connected to the master. So they will poll, they will check continuously, is there any change in the configuration happened in the master? The moment any change happen, it will pull that configuration and deploy it onto that particular node. I hope you're getting my point. So this is called pull configuration. In push configuration, the master will actually push the configurations onto the nodes, which happens in Ansible and SaltStack, but does not happen in Puppet and Chef. So these two tools follow pull configuration, and Ansible and SaltStack follows push configuration, in which these configurations are pushed onto the nodes. And here in Chef and Puppet, the nodes will pull that configurations. They keep on checking the master at regular intervals. And if there is any change in the configuration, it will pull it. Now, let me explain you the architecture that is there in front of your screen. So that is basically a typical Puppet architecture in which what happens, you can see that there's a master slave architecture. Here is our Puppet master and here is our Puppet slave. Now, the functions which are performed in this architecture, first the Puppet agent sends the fact to the Puppet master. So this Puppet slave will first send the facts to the Puppet master. Facts, what are facts? Basically, they are key value data pairs. It represents some aspects of slave state, such as its IP address, uptime, operating system, or whether it's a virtual machine, right? So that's what basically facts are. And the Puppet master uses a fact to compile a catalog that defines how the slaves should be configured. Now, what is a catalog? It is a document that describes the desired state for each resource that Puppet master manages on a slave. Then what happens? The Puppet slave reports back to the master, indicating that configuration is complete and which is also visible in the Puppet dashboard. So that's how it works, guys. So let's move forward and talk about containerization now. So what exactly is containerization? So I believe all of you have heard about virtual machines. So what are containers? Containers are nothing but the lightweight alternatives to virtual machines. So let me just explain that to you. So we have Docker containers that will contain the binaries and libraries required for a particular application. And that's when we call it, we have containerized a particular application, right? So let us focus on the diagram that is there in front of your screen. So here we have host operating system, on top of which we have Docker engine. We have a no guest operating system here, guys. It uses the host operating system. And we are learning two containers. Container one will have application one and its binaries and libraries. The container two will have application two and its binaries and libraries. So all I need in order to run my application is this particular container or this particular container, because all the dependencies are already present in that particular container. So what is basically a container? It contains my application. The dependencies of my application, the binaries, libraries required for that application is there in my container. Nowadays, if you must have noticed that when you want to install some software, you'll actually get ready to use Docker containers, right? That is the reason, because it's pretty lightweight when you compare it with virtual machines, right? So let me discuss a use case how you can actually use Docker in the industry. So suppose you have some complex requirements for your application. It can be a microservice, it can be a monolithic application, anything. So let's just take microservice. So suppose you have complex requirements for your microservice, so you have written the Docker file for that. With the help of this Docker file, I can create a Docker image. So Docker image is nothing but, a template. You can think of it as a template for your Docker container, right? And with the help of Docker image, you can create as many Docker containers as you want. Let me repeat it once more. So we have written the complex requirements for a microservice application in an easy to write Docker file. From there, we have created a Docker image, and with the help of Docker image, we can build as many containers as we want. Now that Docker image, I can upload that onto Docker Hub, which is nothing but a Git repository of Docker images. You can have public repositories, you can have private repositories there. And from Docker Hub, any team, be it staging or production, can pull that particular image and prepare as many containers as they want. So what advantage we get here? Whatever was there in my developer's laptop, right? The microservice application, the guy who has written that, and the requirements for that microservice application. So that guy is basically a developer, and because he's only developing the application. So whatever is there in my developer's laptop, I have replicated in my staging as well as in my production. So there's a consistent computing environment throughout my software delivery lifecycle. I hope you're getting my point. So guys, let me just quickly brief you again about what exactly are Docker containers. So just visualize container as actually a box in which your application is present with all its dependencies, except the box is infinitely replicable. Whatever happens in the box stays in the box unless you explicitly take something out or put something in. And when it breaks, you will just throw it away and get a new one. So containers usually make your application easy to run on different computers. Ideally, the same image should be used to run containers in every environment stage from development to production. So that's what basically Docker containers are. So guys, this is my CentOS virtual machine here again, and I've already installed Docker. So the first thing is I need to start Docker. For that, I'll type systemctl start Docker. Give the password, and it has started successfully. So now what I'm going to do, there are few images which are already there in Docker Hub, which are public images. You can pull it at any time you want. All right, so you can go ahead and run that image as many times as you want. You can create as many containers as you want. So basically, when I execute the command of pulling an image from Docker Hub, it will try to first find it locally, whether it's present or not. And if it is present, then it's well and good. Otherwise, we'll go ahead and pull it from the Docker Hub. So right, so before I move forward, let me just show you how Docker Hub looks like. If you have not created an account on Docker Hub, you need to go and do that, because for executing a use case, you have to do it. It's free of cost. So this is how Docker Hub looks like, guys. And this is my repository that you can notice here, right? I can go ahead and search for images here as well. So for example, if I want to search for Hadoop images, which I believe one of you asked, so you can find that we have Hadoop images present here as well, right? So these are nothing but few images that are there on Docker Hub. So I believe now I can go back to my terminal and execute few basic Docker commands. So the first thing that I'm going to execute is called Docker images, which will give the list of all the images that I have in my local system. So I have quite a lot of images, you can see, right? This is the size and all those things when it was created, the image, this is called the image ID, right? So I have all of these things displayed on my console. Let me just clear my terminal. Now what I'm going to do, I'm going to pull an image, right? So all I have to type here is Docker pull. For example, if I want to pull an Ubuntu image, I'll just type in here Docker pull Ubuntu, and here we go. So it is using default tag latest. So tag is something that I'll tell you later, but yeah, it will provide the default tag latest all the time. So it is pulling from the Docker Hub right now because it couldn't find it locally. So download is complete. It is currently extracting it. Now, if I want to run a container, all I have to type here is docker run -it Ubuntu, or you can type the image ID as well. So I am in the Ubuntu container. So I've told you how you can see the various Docker images. I've told you how you can pull an image from Docker Hub and how you can actually go ahead and run a container. And we're going to focus on continuous monitoring now. So continuous monitoring tools resolve any system errors. You know, what kind of system errors? Low memory, unreachable server, etc., etc., before they have any negative impact on your business productivity. Now, what are the reasons to use continuous monitoring tools? Let me tell you that. It detects any network or server problems. It can determine the root cause of any issue. It maintains the security and availability of the services and also monitors and troubleshoots server performance issues. It also allows us to plan for infrastructure upgrades before outdated system cause failures, and it can respond to issues at the first sign of problem. And let me tell you guys, these tools can be used to automatically fix problems when they are detected as well. It also ensures IT infrastructure outages have a minimal effect on your organization's bottom line and can monitor your entire infrastructure and business processes. So what is continuous monitoring? It is all about the ability of an organization to detect, report, respond, contain, and mitigate the attacks that occur on its infrastructure or on the software. So basically, we have to monitor the events on the ongoing basis and determine what level of risk we are experiencing. So if I have to summarize continuous monitoring in one definition, I will say it is the integration of an organization's security tools. So we have different security tools in an organization. The integration of those tools, the aggregation, normalization, and correlation of the data that is produced by the security tools, right? Now what happens? The data that has been produced, the analysis of that data based on the organization's risk goals and threat knowledge and near real-time response to the risk identified is basically what is continuous monitoring. And there's a very good saying, guys, if you can't measure it, you can't manage it. I hope you know what I'm talking about. Now, there are multiple continuous monitoring tools available in the market. We're going to focus on NAGOS. NAGOS is used for continuous monitoring of systems, applications, services, and business processes in the DevOps culture, right? And in the event of failure, NAGOS can alert technical staff of the problem, allowing them to begin remediation process before outages affect business processes, end users, or customers. So with Nagios, you don't have to explain why an unseen infrastructure outage affect your organization's bottom line. So let me tell you how it works. So I'll focus on the diagram that is there in front of your screen. So NagOS runs on a server usually as a daemon or a service. It periodically runs plugins residing on the same server. They contact hosts or servers on your network. So you can see it in the diagram as well. It periodically runs plugins residing on the same server. They contact hosts or servers on your network or on the internet. Hosts or servers which can be locally present or it can be remotely present as well. One can view the status information using the web interface. You can also receive email or SMS notification if something happens. So Nagios daemon behaves like a scheduler that runs certain scripts at certain moments. It stores the results of those scripts and will run other scripts if these results change. Now, what are plugins? So plugins are compiled executables or scripts that can be run from a command line to check the status of a host or service. So Nagios uses the results from the plugins to determine the current status of the host and services on your network. So what happens actually in this diagram? Nagios server is running on a host and plugins interact with local or remote hosts, right? Now these plugins will send the information to the scheduler, which displays that in the GUI. That's what is happening, guys. All right, so we have discussed all the stages. So let me just give you a quick recap of what all things we have discussed. First, we saw what was the methodology before DevOps. We saw the waterfall model, what were its limitations. Then we understood the agile model and the difference between the waterfall and the agile methodology, and what were the limitations of agile methodology. Then we understood how DevOps overcomes all of those limitations and what exactly is DevOps. We saw the various stages and tools involved in DevOps, starting from version control. Then we saw continuous integration, then we saw continuous delivery, then we saw continuous deployment. Basically, we understood the difference between integration, delivery, and deployment. Then we saw what is configuration management and containerization, and finally explained continuous monitoring, right? So in between, I was even switching back to my virtual machine where I have few tools already installed, and I was telling you a few basics about those tools. Now comes the most awaited topic of today's session, which is our use case. So let's see what we are going to implement in today's use case. So this is what we'll be doing. We have Git repository, right? So developers will be committing code to this Git repository, and from there, Jenkins will pull that code and it will first clone that repository. After cloning that repository, it will build a Docker image using a Docker file. So we have that Docker file, we'll use that to build an image. Once that image is built, we are going to test it and then push it onto Docker Hub. As I've told you, what is Docker Hub is nothing but like a Git repository of Docker images. So this is what we'll be doing. Let me just repeat it once more. So developers will be committing changes in the source code. So the moment any developers commits a change in the source code, Jenkins will clone the entire Git repository. It will build a Docker image based on the Docker file that we'll create. And from there, it will push the Docker image onto the Docker Hub. This will happen automatically with a click of a button. So what all tools we'll be using? We'll be using Git, Jenkins, and Docker. So let me just quickly open my virtual machine and I'll show you there. So what our application is all about. So we are basically creating a Docker image of a particular application and then pushing it onto Docker Hub in an automated fashion. And our code is written in the GitHub repository. So what is that application? So it's basically a Hello World server written with Node. So we have main.js. Let me just go ahead and show you on my GitHub repository. Let me just go back. So this is how our application looks like, guys. We have main.js, right? Apart from that, we have package.json for our dependencies. Then we have Jenkins file and Docker file. Jenkins file, I'll explain it to you what we are going to do with it. But before that, let me just explain you a few basics of Docker file and how we can build a Docker image of this particular very basic Node.js application. First thing is writing a Docker file. Now, to be able to build a Docker image with our application, we will need a Docker file. Yeah, right. You can think of it as a blueprint for Docker. It tells Docker what the contents and parameters of our image should be. So Docker images are often based on other images. But before that, let me just go ahead and create a Docker file for you. So let me just first clone this particular repository. So let me go to that particular directory first. It's there in downloads. Let me unzip this first. Unzip DevOps-tutorial. And let me hit an ls command. So here is my application present. So I'll just go to this particular DevOps-tutorial-master and let me just clear my terminal. So let us focus on what all files we have. We have Docker file. Let's not focus on Jenkins file at all for now, right? We have Docker file, we have main.js, package.json, readme.md, and we have test.js. So I have a Docker file with the help of which I'll be creating a Docker image, right? So let me just show you what I've written in this Docker file. Before this, let me tell you that Docker images are often based on other images, right? For this example, we are basing our image on the official Node Docker image. So this line that you're seeing is basically to base our application on the official Node Docker image. This makes our job easy and our Docker file very, very short, guys. So the hectic task of installing Node and its dependencies in the image is already done in our base image. So we'll just need to include our application. Then we have set a label maintainer. I mean, this is optional. If you want to do it, go ahead. If you don't want to do it, it's still fine. There's a health check, which is basically for Docker to be able to tell if the server is actually up or not. And then finally, we are telling Docker which port our server will run on, right? So this is how we have written the Docker file. Let me just go ahead and close this. And now I'm going to create an image using this Docker file. So for that, all I have to type here is sudo docker build /home/edureka downloads DevOps-tutorial, basically the path to my Docker file. And here we go. You need to provide the sudo password. So it has started now. It is creating an image for me, the Docker image, and it is done now. It has successfully built, and this is my image ID. Right, so I can just go ahead and run this as well. So all I have to type here is docker run -it and my image ID, and here we go. So it is listening at port 8000. Let me just stop it for now. So I've told you how you can create an image using Dockerfile. Right now, what I'm going to do, I'm going to use Jenkins in order to clone a Git repository, then build an image, and then perform testing, and finally pushing it onto Docker Hub, my own Docker Hub profile. All right. But before that, what we need to do is we need to tell Jenkins what our stages are and what to do in each one of them. For this purpose, we'll write Jenkins pipeline specification in a Jenkins file. So let me show you how the Jenkins file looks like. I'll just click on it. So this is what I've written in my Jenkins file, right? So it's pretty self-explanatory. First, I've defined my application. I mean, just clone the repository that I have, then build that image. This is the tag that I'm using, edureka1, which is username, and edureka is the repository name, right? So build the image, then test it. So we're just gonna print test passed, and then finally push it onto Docker Hub, right? So this is the URL of Docker Hub, and my credentials are actually saved in Jenkins in Docker Hub credentials. So let me just show you how you can save those credentials. So go to the credentials tab. So here you need to click on system and click on global credentials. Now over here, you can go ahead and click on update, and you need to provide your username, your password, and your Docker Hub credential ID, that whatever you're gonna pass there, right? So let me just type the password again. All right. Now we need to tell Jenkins two things: where to find our code and what credentials to use to publish the Docker image, right? So I've already configured my project. Let me just go ahead and show you what I have written there. So the first thing is the name of my project, right? Which I was showing you when you create a new item over there, there's an option called where you need to give the name of your project, and I've chosen pipeline project. So if I have to show you the pipeline project, you can go to new item, and this is what I've chosen, that's the kind of project. And then I've clicked on build triggers. So basically this will poll my SCM, the source code management repository, after every minute. Whenever there's a change in the source code, it'll pull that and it will repeat the entire process after every minute. Then advanced project options are selected. The pipeline script from SCM here. Either you can write pipeline script directly, or you can click on pipeline script from source code management. That kind of source code management is Git. Then I've provided the link to my repository, and that's all I have done. Now, when I scroll down, there's nothing else. I can just click on apply and save. So I've already built this project once. So let me just go ahead and do it again. All right, so it has started. First, it will clone the repository that I have. You can find all the logs once you click on this blue color ball. And you can find the logs here as well. So once you click here, you'll find it over here as well. And similarly, the logs are present here also. So now we have successfully built our image. We have tested it. Now we are pushing it onto Docker Hub. So we have successfully pushed our image onto Docker Hub as well. Now, if I go back to my profile and I go to my repository here, so you can find the image is already present here. I've actually pushed it multiple times. So this is how you will execute the practical. It was very easy, guys. So let me just give you a quick recap of what all things we have done. First, I told you how you can write a Docker file in order to create a Docker image of a particular application. So we were basing our image on the official Node image of present in the Docker Hub. right, which already contains all the dependencies and it makes our Docker file looks very small. After that, I build an image using that Docker file. Then I explain to you how you can use Jenkins in order to automate the task of cloning a repository, then building a Docker image, testing the Docker image, and then finally uploading that onto the Docker Hub. We did that automatically with the help of Jenkins. I told you where you need to provide the credentials, what are tags, how you can write the Jenkins file. The next part of the use case is different teams, be it staging or production, can actually pull the image that we have uploaded onto Docker Hub and can run as many containers as they want.
Hey everyone, this is Reshma from Edureka, and today's tutorial we're going to learn about Git and GitHub. So without any further ado, let us begin this tutorial by looking at the topics that we'll be learning today. So at first, we'll see what is version control and why do we actually need version control. After that, we'll take a look at the different version control tools. And then we'll see all about GitHub and Git. We'll also take into account a case study of the Dominion Enterprises about how they're using GitHub. After that, we'll take a look at the features of Git. And finally, we're going to use all the Git commands to perform all the Git operations. So this is exactly what we'll be learning today. So we're good to go. So let us begin with the first topic. What is version control? Well, you can think of a version control as the management system that manages the changes that you make in your project till the end. The changes that you make might be some kind of adding some new files, or you're modifying the older files by changing the source code or something. So what the version control system does is that every time you make a change in your project, it creates a snapshot of your entire project and saves it. And these snapshots are actually known as different versions. Now, if you're having trouble with the word snapshot, just consider that snapshot is actually the entire state of your project at a particular time. It means that it will contain what kind of files your project is storing at that time and what kind of changes you have made. So this is what a particular version contains. Now, if you see the example here, let's say that I have been developing my own website. So let's say that in the beginning I just had only one web page, which is called the index.html, and after a few days I have added another web page to it, which is called about.html, and I have made some modifications in the about.html by adding some kind of pictures and some kind of text. So let's see what actually the version control system stores. So you'll see that it has detected that something has been modified and something has been created. For example, it is storing that about.html is created and some kind of photo is created or added into it. And let's say that after a few days, I have changed the entire page layout of the about.html page. So again, my version control system will detect some kind of change and it will say that some about.html has been modified. And you can consider all of these three snapshots as different versions. So when I only had my index.html web page and I did not have anything else, this is my version 1. And after that, when I added another web page, this is going to be a version 2. And after I've changed the page layout of my web page, this is my version 3. So this is how a version control system stores different versions. So I hope that you've all understood what is a version control system and what are versions. So let us move on to the next topic. And now we'll see why do we actually need version control. Because you might be thinking that why should I need a version control? I know what the changes that I have made, and maybe I'm making these changes just because I'm correcting my project or something. But there are a number of things because of why we need version control. And so let us take a look at them one by one. So the first thing that version control system avails us is collaboration. Now imagine that there are 3 developers working on a particular project and everyone is working in isolation, or even if they're working in the same shared folder. So there might be conflicts sometimes when each one of them are trying to modify the same file. Now let's say they are working in isolation, everyone is minding their own business. Now the developer 1 has made some changes XYZ in a particular application, and in the same application the developer 2 has made some kind of other changes ABC, and they are continuing doing that same thing. They're making the same modifications to the same file, but they're doing it differently. So at the end, when you try to collaborate or when you try to merge all of their work together, you'll come up with a lot of conflicts. And you might not know who have done what kind of changes, and this will at the end up in chaos. But with version control system, it provides you with a shared workspace, and it continuously tells you who has made what kind of change or what has been changed. So you'll always get notified if someone has made change in your project. So with version control system, a collaboration is available between all the developers, and you can visualize everyone's work properly. And as a result, your project will always evolve as a whole from the start, and it will save a lot of time for you because there won't be much conflicts, because obviously if the developer A will see that he has already made some changes, he won't go for that, right? Because he can carry out his other work, he can make some other changes without interfering his work. Okay, so we'll move on to the next reason for why we need version control system. And this is one of the most important things because of why we need version control system. I'll tell you why. Now the next reason is because of storing versions. Because saving a version of your project after you have made changes is very essential. And without a version control system, it can actually get confusing because there might be some kind of questions that will arise in your mind when you are trying to save a version. The first question might be, how much would you save? Would you just save the entire project, or would you just save the changes that you made? Now, if you only save the changes, it'll be very hard for you to view the whole project at a time. And if you try to save the entire project at every time, there will be a huge amount of unnecessary and redundant data lying around, because you'll be saving the same thing that has been remaining unchanged again and again, and it will cover up a lot of your space. And after that, the another problem comes that how do you actually name these versions? Now, even if you are a very organized person and you might actually come up with a very comprehensible naming scheme, but as soon as your project starts varying and it comes to variants, there is a pretty good chance that you'll actually lose track of naming them. And finally, the most important question is that how do you know what exactly is different between these versions? Now you'll ask me that, okay, what's the difference between version 1 and version 2? What exactly was changed? You need to remember or document them as well. Now, when you have a version control system, you don't have to worry about any of that. You don't have to worry about how much you need to save, how do you name them, or you don't have to remember that what exactly is different between the versions, because the version control system always acknowledges that there is only one project. So when you're working on your project, there is only one version on your disk, and everything else, all the changes that you've made in the past, are all neatly packed inside the version control system. So let us go ahead and see the next reason. Now, version control system provides me with a backup. Now, the diagram that you see here is actually the layout of a typical distributed version control system. Here you've got your central server where all the project files are located, and apart from that, every one of the developers has a local copy of all the files that is present in the central server inside their local machine. And this is known as the local copies. So what the developers do is that every time they start coding at the start of the day, they actually fetch all the project files from the central server and store it in the local machine. And after they are done working, they actually transfer all the files back into the central server. So at every time, you'll always have a local copy in your local machine. At times of crisis, like maybe let's say that your central server gets crashed and you have lost all your project files, you don't have to worry about that, because all the developers are maintaining a local copy, the same exact copy of all the files that is related to your project that is present in the central server is there in your local machine. And even if, let's say that maybe this developer has not updated his local copy with all the files, if he loses and the central server gets crashed and the developer has not maintained his local copy, is always going to be someone who has already updated it, because obviously there is going to be a huge number of collaborators working on that project. So even a particular developer can communicate with other developers and fetch all the project files from other developers' local copy as well. So it is very reliable when you have a version control system, because you're always going to have a backup of all your files. So the next thing in which version control helps us is to analyze my project, because when you have finished your project, you want to know that how your project has actually evolved, so that you can make an analysis of it and you can know that what could you have done better or what could have been improved in your project. So you need some kind of data to make an analysis, and you want to know that what was exactly changed and when was it changed and how much time did it take. And version control system actually provides you with all the information, because every time you change something, version control system provides you with a proper description of what was changed and when was it changed. You can also see the entire timeline, and you can make your analysis report in a very easy way because you have got all the data present here. So this is how a version control system helps you to analyze your project as well. So let us move ahead. And let us take a look at the version control tools, because in order to incorporate version control system in your project, you have to use a version control tool. So let us take a look at what is available, what kind of tools can I use to incorporate version control system. So here we've got the 4 most popular version control system tools, and they are Git, and this is what we'll be learning in today's tutorial. We'll be learning how to use Git. And apart from Git, you have got other options as well. You've got the Apache Subversion, and this is also popularly known as SVN. SVN and CVS, which is the concurrent version systems, they both are a centralized version control tool. It means that they do not provide all the developers with a local copy. It means that all the contributors or all the collaborators are actually working directly with the central repository only. They don't maintain a local copy. And it's kind of actually becoming obsolete, because everyone prefers a distributed version control system where everyone has a local copy. And Mercurial, on the other hand, is very similar to Git. It is also a distributed version control tool, but we'll be learning all about Git here. That's why Git is highlighted in yellow. So let's move ahead. So this is the interest over time graph, and this graph has been collected from Google Trends, and this actually shows you that how many people have been using what at what time. So the blue line here actually represents Git, the green is SVN, the yellow is Mercurial, and the red is CVS. So you can see that from the start, Git has always been the most popular version control tool as compared to SVN, Mercurial, and CVS, and it has always kind of been a bad day for CVS. But Git has always been popular, so why not use Git, right? So there's nothing to say much about that. Yes, and a lot of my fellow attendees agree with me. We should all use Git, and we're going to learn how to use Git in this tutorial. So let us move ahead and let us all learn about Git and GitHub right now. So the diagram that you see on my left is actually the diagram which represents that what exactly is GitHub and what exactly is Git. Now I've been talking about a distributed version control system, and the right hand side diagram actually shows you the typical layout of a distributed version control system. Here you've got a central server or a central repository. Now I'll be using the word repository a lot from now on. Just so that you don't get confused, I'll just give you a brief overview. I'll also tell you in detail what is a repository, and I'll explain you everything later in this tutorial. But for now, just consider repository as a data space where you store all the project files, any kind of files that is related to your project in there. So don't get confused when I say repository instead of server or anything else. So in a distributed version control system, you've got a central repository and you've got local repositories as well. And every of the developers at first make the changes in their local repository, and after that they push those changes or transfer those changes into the central repository. And also they update their local repositories with all the new files that are pushed into the central repository by an operation called pull. So this is how they fetch data from central repository. And now if you see the diagram again on the left, you'll know that GitHub is going to be my central repository and Git is the tool that is going to allow me to create my local repositories. Now let me exactly tell you what is GitHub. Now people actually get confused between Git and GitHub. They think that it's kind of the same thing. Maybe because of the name they sound very alike, but it is actually very different. Well, Git is a version control tool that will allow you to perform all these kind of operations, to fetch data from the central server and to just push all your local files into the central server. So this is what Git will allow you to do. It is just a version control management tool. Whereas in GitHub, it is a code hosting platform for version control collaboration. So GitHub is just a company that allows you to host your central repository in a remote server. If you want me to explain in easy words, you can consider GitHub as a social network, which is very much similar to Facebook. Like, only the difference is that this is a social network for the developers, where in Facebook you're sharing all your photos and videos or any kind of statuses. What the developers do in GitHub is that they share their code for everyone to see their project, see their code about how they've worked on. So that is GitHub. There are certain advantages of a distributed version control system. Well, the first thing that I've already discussed was that it provides you with a backup. So if at any time your central server crashes, everyone will have a backup of all their files. And the next reason is that it provides you with speed, because a central server is typically located on a remote server and you have to always travel over a network to get access to all the files. So if at sometimes you don't have internet and you want to work on your project, so that will be kind of impossible because you don't have access to all your files. But with a distributed version control system, you don't need internet access always. You just need internet when you want to push or pull from the central server. Apart from that, you can work on your own. Your files are all inside your local machine, so fetching it in your workspace is not a problem. So that are all the advantages that you get with a distributed version control system, and a centralized version control system cannot actually provide you that. So now let us take a look at a GitHub case study of the Dominion Enterprises. So Dominion Enterprises is a leading marketing services and publishing company that works across several industries, and they have got more than 100 offices worldwide. So they have distributed technical team support to develop a range of websites, and they include the most popular websites like forrent.com, boats.com, homes.com. All the Dominion Enterprises websites actually get more than tens of millions unique visitors every month. And each of the website that they work on has a separate development team, and all of them has got a unique needs and unique workflows of their own. And all of them were working independently. And each team has their own goals, their own projects and budgets, but they actually wanted to share their resources, and they wanted everyone to see what each of the teams are actually working on. So basically they wanted transparency. Well, they needed a platform that was flexible enough to support a variety of workflows, and that would provide all the Dominion Enterprises development around the world with a secure place to share code and work together. And for that, they adopted GitHub as the platform. And the reason for choosing GitHub is that all the developers across the Dominion enterprises were already using github.com. So when the time came to adopt a new version control platform, so obviously a GitHub enterprise definitely seemed like a very intuitive choice. And because everyone, all the developers were also familiar with GitHub, so the learning curve was also very small. And so they could start contributing code right away into GitHub. And with GitHub, all the developer teams, all the development teams were provided access to when they can always share their code on what they're working on. So at the end, everyone has got a very secure place to share code and work together. And as Joe Fuller, the CIO of Dominion Enterprises, says that GitHub Enterprise has allowed us to store our company's source code in a central, corporately controlled system. And Dominion Enterprises actually manages more than 45 websites, and it was very important for Dominion Enterprise to choose a platform that made working together possible. And this wasn't just a matter of sharing Dominion Enterprise's open source project on GitHub. They also had to combat the implications of storing private code publicly to make their work more transparent across the company as well. And they were also using Jenkins to facilitate a continuous integration environment. And in order to continuously deliver their software, they have adopted GitHub as a version control platform. So GitHub actually facilitated a lot of things for Dominion enterprises, and for that they were able to incorporate a continuous integration environment with Jenkins, and they were actually sharing their code and making software delivery even more faster. So this is how GitHub helped not only just Dominion enterprises, but I'm sure this might be common to a lot of other companies as well. So let us move forward. So now this is the topic that we were waiting for, and now we'll learn what is Git. So Git is a distributed version control tool, and it supports distributed nonlinear workflow. So Git is the tool that actually facilitates all the distributed version control system benefits, because it will provide you to create a local repository in your local machine, and it will help you to access your remote repository to fetch files from there or push files into that. So Git is the tool that you require to perform all these operations. And I'll be telling you all about how to perform these operations using Git later in this tutorial. For now, just think of Git as the tool that you actually need to do all kind of version control system tasks. So we'll move on and we'll see the different features of Git now. So these are the different features of Git. Is distributed, Git is compatible, Git provides you with a nonlinear workflow, it avails you branching, it's very lightweight, it provides you with speed, it's open source, it's reliable, secure, and economical. So let us take a look at all these features one by one. So the first feature that we're going to look into is it's distributed. Now I've been telling you it's a distributed version control tool. It means that the feature that Git provides you is that it gives you the power of having a local repository. It lets you have a local copy of the entire development history, which is located in the central repository, and it will fetch all the files from the central repository to get your local repository always updated. And I'm calling it distributed because let's say that there might be a number of collaborators or developers, so they might be living in different parts of the world. Someone might be working from the United States, someone might be in India. So the project is actually distributed. Everyone has a local copy, so it is distributed worldwide, you can say. So this is what distributed actually means. So the next feature is that it is compatible. Now let's say that you might not be using Git on the first place, but you have a different version control system already installed, like SVN, like Apache Subversion or CVS. And you want to switch to Git because obviously you're not happy with the centralized version control system and you want a more distributed version control system. So you want to migrate from SVN to Git. But you are worried that you might have to transfer all the files, or the huge amount of files that you have in your SVN repository into a Git repository. Well, if you are afraid of doing that, let me tell you, you don't have to be anymore, because Git is compatible with SVN repositories as well. So you just have to download and install Git in your system, and you can directly access the SVN repository over a network, which is the central repository. So the local repository that you'll have is going to be a Git repository, and if you don't want to change your central repository, then you can do that as well. We can use Git SVN, and you can directly access all the files in your project that is residing in an SVN repository. So you don't have to change that. And it is compatible with existing systems and protocols. Well, there are protocols like SSH and WinRM protocols, so obviously Git uses SSH to connect to the central repository as well. So it is very compatible with all the existing things. So you don't have to, so when you're migrating into Git, when you are starting to use Git, you don't have to actually change a lot of things. So have everyone understood these two features by so far? Okay. The next feature of Git is that it supports non-linear development of software. Now, when you're working with Git, Git actually records the current state of your project by creating a tree graph from the index. A tree that you know is non-linear. Now, when you're working with Git, Git actually records the current state of the project by creating a tree graph from the index. And as you know that a tree is a nonlinear data structure, and it is usually actually in the form of a directed acyclic graph, which is popularly known as the DAG. So this is how actually Git facilitates a nonlinear development of software. And it also includes techniques where you can navigate and visualize all of your work that you're currently doing. And how does it actually facilitate? And when I'm talking about nonlinearity, how does it Git actually facilitates a nonlinear development is actually by branching. Now, branching actually allows you to make a nonlinear software development. And this is the Git feature that actually makes Git stand apart from nearly every other version control management tool, because Git is the only one which has a branching model. So Git allows and Git actually encourages you to have multiple local branches, and all of the branches are actually independent of each other, and the creation and merging and deletion of all these branches actually takes only a few seconds. And there is a thing called the master branch. It means the main branch which starts from the start of your project to the end of your project, and it will always contain the production quality code. It will always contain the entire project. And after that, it is very lightweight. Now, you might be thinking that since we're using local repositories on our local machine and we're fetching all the files that are in the central repository, and if you think that way, you can know that there are like maybe there are hundreds of people pushing their code into the central repository, and I'm updating my local repository with all those files. So the data might be very huge, but actually Git uses a lossless compression technique, and it compresses the data on the client side. So even though it might look like that you've got a lot of files, when it actually comes to storage or storing the data in your local repository, it is all compressed and it doesn't take up a lot of space. Only when you're fetching your data from the local repository into your workspace, it converts it, and then you can work on it, and whenever you push it again, you compress it again and store it in a very minimal space in your disk. And after that, it provides you with a lot of speed. Now, since you have a local repository and you don't have to always travel over a network to fetch files, so it does not take any time to get files into your workspace from your local repository, and if you see that, it is actually 100 times faster than fetching data from a remote repository, because obviously you have to travel over a network to get that data or the files that you want. And Mozilla has actually performed some kind of performance test, and it has found out that Git is actually one order of magnitude faster than other version control tools, which is actually equal to 10 times faster than other version control tools. And the reason for that is because Git is actually written in C, and C is not like other high-level languages. It is very close to machine language, so it reduces all the runtime overheads and it makes all the processing very fast. So Git is very small and Git is very fast. And the next feature is that it is open source. Well, you know that Git was actually created by Linus Torvalds, and he's the famous man who created the Linux kernel, and he actually used Git in the development of the Linux kernel. Now, they were using a version control system called BitKeeper first, but it was not open source. So the owner of BitKeeper has actually made it a paid version, and this actually got Linus Torvalds mad. So what he did is that he created his own version control system tool, and he came up with Git, and he made it open source for everyone so that so the source code is available and you can modify it on your own and you can get it for free. So there is one more good thing about Git. And after that, it is very reliable. Like I've been telling you since the start that you have a backup of all the files in your local repository. So if your central server crashes, you don't have to worry. Your files are all safe in your local repository. And even if it's not in your local repository, it might be in some other developer's local repository. And you can tell him, and whenever you need some data and you lose the data, and after your central server is all repaired, if it was crashed, he can directly push all the data into the central repository, and from there everyone else can always have a backup. So the next thing is that Git is actually very secure. Now Git uses the SHA-1 to name and identify objects. So whenever you actually make change, it actually creates a commit object. And after you have made changes and you have committed to those changes, it is actually very hard to go back and change it without other people knowing it. Because whenever you make a commit, the SHA-1 actually converts it. What is SHA-1? Well, it is a kind of cryptographic algorithm. It is a message digest algorithm that actually converts your commit object into a 40-digit hexadecimal code. Now, SHAI uses techniques and algorithms like MD4 and MD5, and it is actually very secure. It is considered to be very secure because even the National Security Agency of United States of America uses SHAI. So if they're using it, so you might know that it is very secure as well. And if you want to know what's MD5 and message digest, I'm not going to take you through the whole algorithm, whole cryptographic algorithm about how they make that cipher and all. You can Google it and you can learn what is SHAI, but the main concept of it is that after you have made changes, you cannot deny that you have not made changes, because it will store it and everyone can see it. It will create a commit hash for you, so everyone will see it. And this commit hash is also useful when you want to revert back to previous versions. You want to know that which commit exactly caused what problem, and if you want to remove that commit or if you want to remove that version, you can do that because SHAI will give you the hash log of every commit. So we'll move on and see the next feature, which is economical. Now, Git is actually released under the general public's license, and it means that it is for free. You don't have to pay any money to download Git in your system. You can have Git without burning a hole in your pocket. And since all the heavy lifting is done on the client side, because everything you do it on your own entire workspace, and you push it into the local repository first, and after that it's pushed in the central server. So it means that people are only pushing into the central server after when they're sure about their work, and they're not experimenting on the central repository. So your central repository can be very simple enough. You don't have to worry about having a very complex and very powerful hardware, and a lot of money can be saved on that as well. So Git is free, Git is small, so Git provides you with all the cool features that you would actually want. So these were all the Git features. So we'll go ahead to the next topic. Our next, so first we'll see what is a repository. Now, as GitHub says it, it is a directory or storage space where all your projects can live. It can be local to a folder on your computer, like your local repository, or it can be a storage space on GitHub or another online host. It means your central repository. And you can keep your code files, text files, image files, you name it, you can keep it inside a repository, everything that is related to your project. And like I have been chanting since the start of this tutorial, that we have got two kinds of repositories. We've got the central repository and we've got the local repository. And now let us take a look at what these repositories actually are. So on my left hand side you can see all about the central repository, and in the right hand side this is all about my local repository. And the diagram in the middle actually shows you the entire layout. So the local repository will be inside my local machine, and my central repository for now is going to be on GitHub. So my central repository is typically located on a remote server, and like I just told you, it is typically located on GitHub. And my local repository is going to be my local machine and will reside in a .git folder, and it will be inside your project's root, The .git folder is going to be inside your projects root, and it will contain all the templates and all the objects and all the configuration files when you create your local repository. And since you're pushing all the code, your central repository will also have the same .git repository folder inside it. And the sole purpose of having a central repository is so that all the collaborators or all the developers can actually share and exchange data, because someone might be working on a different problem and someone might be needing help in that. So what he can do is that he can push all the code, all the problems that he has solved or something that he has worked on into the central repository, and everyone else can see it and everyone else can pull his code and use it for themselves as well. So this is just meant for sharing data. Whereas in local repository, it is only you can access it and it is only meant for your own. So you can work in your local repository, you can work in isolation, and no one will interfere you. And after you're done, after you're sure that your code is working and you want to show it to everyone, just transfer it or push it into the central repository. Okay, so now we'll be seeing the Git operations and commands. So this is how we'll be using Git. There are various operations and commands that will help us to do all the things that we were just talking about right now. We're talking about pushing changes. So these are all Git operations. So we'll be performing all these operations. We'll be creating repositories with this command. We'll be making changes in the files that are in our repositories with the commands. We'll be also doing parallel nonlinear development that I was just talking about. And we'll also be syncing our repositories so that our central repository and local repository are connected. So I'll show you how to do that one by one. So the first thing that we need to do is create repositories. So we need a central repository and we need a local repository. Now we'll host our central repository on GitHub. So for that you need an account in GitHub and create a repository there. And for your local repository you have to install Git in your system. And if you are working on a completely new project and if you want to start something fresh and very new, you can just use Git init to create a repository. Or if you want to join an ongoing project and if you're new to the project and you just joined, so what you can do is that you can clone the central repository using this command git clone. So let us do that. So let's first create a GitHub account and create repositories on GitHub. So at first you need to go to github.com, and if you don't have an account you can sign up for GitHub in here. You just have to pick a username that has not been already taken. You have to just provide your email address, get a password, and then just click this green button here and your account will be created. It's very easy, you don't have to do much. And after that you just have to verify your email and everything, and after you're done with all sort of thing you can just go sign in. Now I already have an account, so I'm just going to sign in here. So after you're signed in, you'll find this page here. So you'll get two buttons where you can read the guide of how to use GitHub, or you can just start a project right away. Now I'll be telling you all about GitHub, so you don't have to click this button right now. So you can just go ahead and start a project. So now Git tells that for every project you need to maintain a unique repository. It is because it's very healthy and keeps things very clean, because if you are storing just the files related to one project in a repository, you won't get confused later. So when you're creating a new repository, you have to provide with a repository name. Now I'm just going to name it git-github. And you can provide it with a description of this repository, and this is optional. If you don't want to, you can leave it blank, and you can choose whether you want it public or private. Now if you want it to be private, you have to pay some kind of amount. So like this will cost you $7 a month. And so what is the benefit of having a private account is that only you can see it. If you don't want to share your code with anyone and you don't want anyone to see it, you can do that in GitHub as well. But for now I'll just leave it public. I just want it for free, and let everyone see my work, what you have done. So we'll just leave it public for now. And after that, you can initialize this repository with the README. So the README file will contain the description of your file. So this is the first file that is going to be inside the repository when you create the repository. So, and it's a good habit to actually initialize your repository with the README. So I'll just click this option. And this is the option to add git ignore. Now, there might be some kind of files that you don't want when you're making operations like push or pull. You don't want those files to get pushed or pulled, like it might be some kind of log files or anything. So you can add those files in git ignore here. So right now I don't have got any files, so this is just the starting of my project. So I will just ignore this git ignore for now. And then you can actually add some license as well. So you can just go through what this license actually are, but if you want, you can just leave it as none. And after that, just click on this green button here. So just create your repository. And so there it is. So you can see this is the initial commit. You have initialized your repository with the README, and this is your README file. Now, if you want to make changes into the README file, just click on it and click on the edit pencil image or icon kind of that is in here, and you can make changes on the README file. So if you want to write something, let's say just write a description. Let's say this is for tutorial purpose, and that's it, just keeping it simple. And after that, you've made changes. The next thing that you have to do is you have to commit a changes. So you can just go down and click on this commit changes green button here, and it's done. So you have updated readme.md, and this is your commit hash. So you can see that in here. So if you go back to your repository, you can say that something has been updated, and it will show you when was your last commit. So it will even show you the time. So, and for now you're on the branch master here, and this will actually show you all the logs. So since only I'm contributing here, so it is only one contributor, and I've just made 2 commits. The first one was when I initialized it, and right now when I modified it, and right now I've not created any branches, so there is only 1 branch. So now my central repository has been created. So the next thing that I need to do is create a local repository in my local machine. Now I have already installed Git in my system. I'm using a Windows system, so I've installed Git for Windows. So if you want some help with the installation, I have already written a blog on that. I'll leave the link of the blog in the description below. You can refer to that blog and install Git in your system. Now I've already done that, so let's say that I want my project to be in the C drive. So let's say I'm just creating a folder here from my project. So I'll just name it Edureka project. And let's say that this is where I want my local repository to be in. So the first thing that I'll do is right click, and I'll click this option here, git bash here. And this will actually open up a very colorful terminal for you to use, and this is called the git bash emulator. So this is where you'll be typing all your commands, and you'll be doing all your work in the git bash here. So in order to create your local repository, the first thing that you'll do is type in this command, git init, and press enter. So now you can see that it is initialized empty git repository on this path. So let's see, and you can see that a .git of a folder has been created here, and if you see here, you can see that it contains all the configurations and the object details and everything. So your repository is initialized, and this is going to be your local repository. So after we have created our repositories, it is very important to link them, because how would you know which repository to push into, and how will you just pull all the changes or all the files from a remote repository if you don't know if they're not connected properly? So in order to connect them, the first thing that we need to do is that we need to add origin, and we're going to call our remote repository as origin, and we'll be using the command git remote at origin to add so that we can pull files from our GitHub central repository. And in order to fetch files, we can use git pull. And if you want to transfer all your files or push files into GitHub, we'll be using git push. So let me just show you how to do that. So we are back in our local repository, and as you can see now that I have not got any kind of files. And if you go to my central repository, you can see that I've got a README file. So the first thing that I need to do is to add this remote repository as my origin. So for that, I'll clear my screen first. So for that, you need to use this command, git remote add origin, and the link of your central repository. And let me just show you where you can find this link. So when you go back into your repository, you'll find this green button here, which is the clone or download. Just click here, and this is the HTTPS URL that you want. So just copy it on your clipboard, go back to your git bash and paste it, and enter. So your origin has been added successfully because it's not showing any kind of errors. So now what we'll do is that we'll perform a git pull. It means we'll fetch all the files from the central repository into my local repository. So just type in the command git pull origin master. And you can see that they have done some kind of fetching from the master branch into the master branch. And let us see that whether all the files have been fetched or not. Let us go back to our local repository, and there is the README file that was in my central repository, and now it is in my local repository. So this is how you actually update your local repository from the central repository. You perform a git pull, and it will fetch all the files from the central repository in your local machine. So let us move forward and move ahead to the next operation. Now I've told you in order to sync repositories, you also need to use a git push, but since we have not done anything in our local repository now, so I'll perform the git push later on after I show you all the operations, and we'll be doing a lot of things. So at the end, I'll be performing the git push and push all the changes into my central repository, and actually that is how you should do that. It's a good habit and it's a good practice if you're working with GitHub and Git, is that when you start working, the first thing that you need to do is make a git pull to fetch all the files from your central repository so that you can get updated with all the changes that has been recently made by everyone else. And after you're done working, after you're sure that your code is running, then only make the git push so that everyone can see it. You should not make very frequent changes into the central repository because that might interrupt the work of your other collaborators or other contributors as well. So let us move ahead and see how we can make changes. So now Git actually has a concept. It has an intermediate layer that resides between your workspace and your local repository. Now when you want to commit changes or make changes in your local repository, you have to add those files in the index first. So this is the layer that is between your workspace and local repository. Now if your files are not in the index, you cannot make commit or you cannot make changes into your local repository. So for that you have to use the command git add. And you might get confused that which all files are in the index and which all are not. So if you want to see that, you can use the command git status. And after you have added the changes in the index, you can use the command git commit to make the changes in the local repository. Now let me tell you what is exactly a git commit. Everyone will be talking about git commit, committing changes when you're making changes. So let us just know what is a git commit. So let's say that you have not made any kind of changes, or this is your initial project. So what a commit is that it is a kind of object which is actually a version of your project. So let's say that you have made some changes and you have committed those changes. What your version control system will do is that it will create another commit object, and this is going to be your different version with the changes. So your commit snapshots are actually going to contain snapshots of the project which is actually changed. So this is what commit is. So I'll just go ahead and show you how to commit changes in your local repository. So we're back into our local repository, and so let's just create some files here. So now if you're developing a project, you might be just only contributing your source code files into the central repository. So now I'm not just going to tell you all about coding, so we're just going to create some text files, write something in that, which is actually pretty much the same if you're working on a code and you're storing your source code in your repositories. So I'll just go ahead and create a simple text file. I'll just name it edu1 and just write something. So I'll just write first file. Save this file, close it. So now remember that even if I have created inside this repository, this is actually showing my workspace, and it is not in my local repository now because I have not committed it. So what I'm going to do is that I'm going to see what all files are in my index. But before that, I'll clear my screen because I don't like junk on my screen. Okay, so the first thing that we're going to see is that what all files are added in my index, and for that I just told you we're going to use the command git status. So you can see that it is calling edu1.txt, which we just have written. It is calling it an untracked file. Now untracked files are those which are not added in the index yet. So this is newly created. I have not added it explicitly into the index. So if I want to commit changes in edu1.txt, I will have to add it in the index. So for that, I'll just use the command git add and the name of your file, which is edu1.txt, and it has been added. So now let us check the status again. So for that we'll just use git status, and you can see that changes ready to be committed is the edu1.txt because it's in the index, and now you can commit changes on your local repository. So in order to commit, the command that you should be using is git commit -m, because whenever you're committing, you always have to give a commit message so that everyone can see who made all these commits and what exactly is changed. So this commit message is just for your purpose, that you can see what exactly was changed. But even if you don't write it, the version control system is also going to do that, and if you have configured your git, it is always going to show that who is the user who has committed this change. So I was just talking about writing a commit message, so I'm just going to write something like adding first commit in local and press enter. So you can see one file change, something has been inserted. So this is the changes are finally committed in my local repository, and if you want to see how actually Git stores all this commit, actually I'll show you after I show you how to commit multiple files together. So let's just go back into our local repo folder, and we'll just create some more files, some more text files. So I'm just going to name it edu2. I'll create another one and just name it edu3. Let's just write something over here. We'll just say second file, say third file. So let's go back to our git bash terminal, and now let us see the git status. So now you can see that it is showing that edu2 and edu3 are not in my index, and if you remember, edu1 was already in the index. Actually, let me just go back and make some modifications in edu1 as well. So just I'm going to write modified 1. So we'll just see git status again, And you can see that it is showing that edu1 is modified and there are untracked files edu2 and edu3 because I haven't added them in my index yet. So now Sebastian and Jamie, you have been asking me how to add all multiple files together. So now I'm going to add all these files at once. So for that I'm just going to use git add -capital A. Just press enter and now see the git status. And you see that all the files have been added to the index at once. And it's similarly with commit as well. So now that you have added all the files in the index, I can also commit them all at once. And how to do that? Let me just show you. You just have to write git commit and -a. So if you want to commit all, you have to use -a in case of git commit, whereas in case of git add, if you want to add all the files, you have to use -capital A. So just remember that difference. And add message, adding 3 files. So you can see 3 files has been changed. And now let me show you how does actually Git stores all these commits. So you can perform an operation called the git log, and you can see, so this is the 40-digit hexadecimal code that I was talking about, and this is the SHA1 hash, and you can see the date, and you have got the commit message that we have just provided. I just wrote adding 3 files together, and it shows it. It shows the date and the exact time and the author, and this is me because I've already configured it with my name. So this is how you can see commit, and this is actually how version control system like Git actually stores all your commit. So let us go back and see the next operation, which is how to do parallel development or a nonlinear development. And the first operation is branching. Now we've been talking about branching a lot, and let me just tell you what exactly is branching and what exactly you can do with branching. Well, you can think of branches like a pointer to a specific commit. Let's say that you have made changes in your main branch. Now remember that your main branch that I told you about, it's called the master branch, and the master branch will contain all the code. So let's say that you're working on the master branch and you've just made a change and you've decided to add some new feature onto it. So you want to work on the new feature individually, or you don't want to interfere with the master branch. So if you want to separate that, you can actually create a branch from this commit, and let me show you how to actually create branches. Now I'll also tell you that there are two kinds of branches. There are local branches and remote tracking branches. Your remote branches are the branches that is going to connect your branches from your local repository to your central repository, and local branches are something that you only create in your workspace that is only going to work with the files in your local repository. So I'll just show you how to create branches and then everything will be clear to you. So let us go back to our git bash, clear the screen, and right now we are in the master branch, and this indicates which branch you are on to right now. So we're in the master branch right now, and we're going to create a different branch. So for that you just have to type the command git branch and write a branch name. So let us just call it first branch and enter. So now you have created a branch, and this first branch will now contain all the files that were in the master because it originated from the master branch. So now this shows that you are still in the master branch, and if you want to switch to the new branch that you just created, you have to use this command, git checkout. Well, it's called checking out. If you want to move from one branch to another, it's called checking out in Git. So we're going to use git checkout and the name of the branch. So switch to first branch, and now you can see that we're in the first branch, and now we can start doing all the work in our first branch. So let us create some more files in the first branch. So let's go back, and this will actually show me my workspace of my first branch right now. So we'll just create another text document and we're going to name it edu4. And you can just write something first branch. Just save it. Just we'll go back and now we've made some changes. So let us just commit this changes all at once. So let me just use git add. After that, what you have to do, if you remember, is that you have to perform a git commit. And enter. Okay, so one file changed. So now remember that I have only made this edu4 change in my first branch, and this is not in my master branch yet, because now we're in the first branch. If it lists out all the files in the first branch, you can see that you've got the edu1, edu2, edu3, and the readme, which was in the master branch, because it will be there because it originated from the master branch. And apart from that, it has a new file called edu4.txt. And now if you just move back into the master branch, let's say we're going back into the master branch. And if you just see the files in master branch, you'll find that there is no edu4 because I've only made the changes in my first branch. So what we have done now is that we have created branches and we have also understood the purpose of creating branches. Okay, so we're moving on to the next topic. The next thing we'll see is merging. So now if you're creating branches and you're developing a new feature and you want to add that new feature, so you have to do an operation called merging. Now merging means combining the work of different branches all together. And it's very important that after you have branched off from your master branch, always combine it back in at the end. After you're done working with the branch, always remember to merge it back in. So now we have created branches, let us see, and we have made changes in our branch, like we have added edu4, and if you want to combine that back in our master branch, because like I told you, your master branch will always contain your production quality code. So let us now actually start merging those files because I've already created branches. It's time that we merge them. So we're back in my terminal and what we need to do is merge those changes. And if you remember that we've got a different file in my first branch, which is the edu4, and it's not there in my master branch yet. So what I want to do is merge that branch into my master branch. So for that, I'll use a command called git merge and the name of my branch. And there is a very important thing to remember when you're merging is that you want to merge the work of your first branch into master. So you want master to be the destination. So whenever you're merging, you have to remember that you were always checked out in the destination branch. So I'm already checked out in the master branch, so I don't have to change it back. So I'll just use the command git merge and the name of the branch, which work you want to merge it into. And you have to provide the name of the branch whose work you want merged into the current branch that you were checked out. So for now, I've just got one branch, which is called the first branch, and enter. So you can see that one file changed, something has been added. We are in the master branch right now, so now let us list out all the files in the master branch. And there you see now you have edu4.txt, which was not there before I merged it. So this is what merging does. Now you have to remember that your first branch is still separate. Now if you want to go back into your first branch and modify some changes again in the first branch and keep it there, you can do that. It will not actually affect the master branch until you merge it. So let me just show you an example. So I'll just go back to my first branch. So now let us make changes in edu4. So I'll just write modified in first branch. we'll go back and we'll just commit all these changes, and I'll just use git commit. So now remember that the git commit all is also performed for another purpose. Now it doesn't only actually commit all the uncommitted file at once. If your files are in the index and you have just modified, it also does the job of adding it to the index again by modifying it and then committing it. But it won't work if you have never added that file in the index. Now edu4 was already in the index. Now after modifying it, I have not explicitly added in the index. And if I'm using git commit all, it will explicitly add it in the index because it was already a tracked file, and then it will commit the changes also in my local repository. So you see, I didn't use the command git add, I just did it with git commit because it was already a tracked file. So one file has been changed. So now if you just scat it, and you can see that it's different. It shows the modification that we have done, which is modified in first branch. Now let's just go back to my master branch. Now remember that I have not merged it yet, and my master branch also contains a copy of edu4, and let's see what this copy actually contains. So you see that the modification has not affected in the master branch because I have only done the modification in the first branch. So the copy that is in the master branch is not the modified copy because I have not merged it yet. So it's very important to remember that if you actually want all the changes that you have made in the first branch, all the things that you have developed in your branch that you have created, make sure that you merge it in. Don't forget to merge, or else it will not show any kind of modifications. So I hope that you've understood why merging is important, how to actually merge different branches together. So we'll just move on to the next topic, and which is rebasing. Now, when you say rebasing is also another kind of merging. So the first thing that you need to understand about rebase is that it actually solves the same problem as of git merge. And both of these commands are designed to integrate changes from one branch into another. It's just that they just do the same task in a different way. Now, what rebasing means, if you see the workflow diagram here, is that you've got your master branch and you've got your new branch. Now, when you're rebasing it, what it does, if you see in this workflow diagram here, is that you've got a new branch and your master branch, and when you're rebasing it, instead of creating a similar commit which will have two parent commits, what rebasing does is that it actually places the entire commit history of your branch onto the tip of the master. Now you'd ask me, why should we do that? Like, what is the use of that? Well, the major benefit of using a rebase is that you get a much cleaner project history. So I hope you've understood the concept of rebase. So let me just show you how to actually do rebasing. Okay, so what we're going to do is that we're going to do some more work in our branch, and after that we'll rebase our branch onto master. So we'll just go back to our branch, use git checkout, first branch, and now we're going to create some more files here. Let's name it edu5, and let's say edu6. So we're going to write some random stuff. Let's say we're saying welcome to Edureka 1. I'll write the same thing again. Let's say welcome 2. So we've created this, and now we're going back to our git bash, and we're going to add all these new files, because now we need to add, because we cannot do it with just git commit all, because these are untracked files. This is the files that I've just created right now. So I'm using, and now we're going to commit. And it has been committed. So now if you just see all the files, you'll see edu 1, 2, 3, 4, 5, 6 and a readme. And if you go back to the master, and if you just list out all the files in master, it only has up to 4. The 5 and 6 are still in my first branch, and I have not merged it yet. And I'm not going to use git merge right now. I'm going to use rebase this time instead of using git merge. And this, you'll see that this will actually do the same thing. So for that, you just have to use the command. So let us go back to our first branch. Okay, I did a typing error. IRSTBRANCH. Okay, switch to first branch. And now we're going to use the command git rebase master. Now it is showing that my current branch, first branch, is up to date, just because whatever is in the master branch is already there in my first branch, and there were no new files to be added. So that is the thing. So but if you want to do it in the reverse way, I'll show you what will happen. So let's just go and check out. So let's do rebasing, git rebase first branch. So now what happened is that all the work of first branch has been attached to the master branch, and it has been done linearly. There was no new set of commits. So now if you see all the files in the master branch, you'll find that you've got edu5 and edu6 as well, which was in the first branch. So basically rebasing has merged all the work of my first branch into the master. But the only thing that happened is that it happened in a linear way. All the commits that we did in first branch actually got reattached to the head in the master. So this was all about a nonlinear development. I have told you about branching, merging, rebasing. We've made changes, we've pulled changes, committed changes, but I remember that I haven't shown you how to push changes. So since we're done working in our local repository now, we have made our all final changes, and now we want it to contribute in our central repository. So for that, we're going to use git push, and I'm going to show you how to do a git push right now. Before I go ahead to explain you a git push, you have to know that when you're actually setting up your repository, if you remember your GitHub repository as a public repository, it means that you're giving a read access to everyone else in the GitHub community. So everyone else can clone or download your repository files. So when you're pushing changes in a repository, you have to know that you need to have certain access rights, because it is a central repository. This is where you're storing your actual code. So you don't want other people to interfere in it by pushing wrong codes or something. So we're going to connect my central repository via SSH in order to push changes into my central repository. Now, at the beginning, when I was trying to make this connection with SSH, I was facing some certain kind of problems. Let me go back to the repository and let me show you. When you click this button, you see that this is your HTTPS URL that you use in order to connect with your central repository. Now, if you want to use SSH, So this is your SSH connection URL. So in order to connect with SSH, what you need to do is that you have to generate a public SSH key and then just add that key simply into your GitHub account. And after that, you can start pushing changes. So first we'll do that. We'll generate a SSH public key. So for that, we'll use this command ssh-keygen. So under file, there is already an SSH key. So do you want to override it? Yes. So my SSH key has been generated and it has been saved in here. So if I want to see it, I'll just use cat and just copy it. So this is my public SSH key. Now if I want to add this SSH key, I'll go back into my GitHub account and here I'll go back in settings and we'll go and click on this option, SSH and GPG keys. And I've already had two SSH keys added and I want to add my new one. So I'm going to click this button, new SSH key, and just make sure that you provide a name to it. I'm just going to keep it in order because I've named the other ones as SSH1 and SSH2. So I'm going to say it's SSH3. So just paste your SSH key in here. So just copy this key. Paste it and click on this button, which is add SSH key. Okay, so now, well, the first thing you need to do is clear the screen. And now what you need to do is you need to use this command ssh-t and your SSH URL that we use, which is git@github.com, and enter. So my SSH authentication has been successfully done. So I'll go back to my GitHub account and if I refresh this, you can see that the key is green. It means that it has been properly authenticated and now I'm ready to push changes onto the central repository. So we'll just start doing it. So let me just tell you one more thing, that if you are developing something in your local repository and you have done it in a particular branch in your local repository, and let's say that you don't want to push these changes into the master branch of your central repo or your GitHub repository. So and let's say that whatever work that you have done, it will stay in a separate branch in your GitHub repository so that it does not interfere with the master branch and everyone can identify that it is actually your branch and you have created it and this branch only contains your work. So for that, let me just go to the GitHub repository and show you something. Let's go to the repositories, and this is the repository that I have just created today. So when you go in the repository, you can see that I have only got one branch here, which is the master branch. And if I want to create branches, I can create it here, but I would advise you to create all branches from your command line or from your git bash only in your central repository as well. So let us go back in our branch. So now what I want is that I want all the work of the first branch in my local repository to make a new branch in the central repository, and that branch in my central repository will contain all the files that is in my first branch of my local repository. So for that, I'll just perform git push the name of my remote, which is origin and first branch. And you can see that it has pushed all the changes. So let us verify it. Let us go back to our repository and let's refresh it. So this is the master branch, and you can see that it has created another branch which is called the first branch, because I have pushed all the files from my first branch into and I have created a new branch called first branch, as similar to my first branch in my local repository here in GitHub. So now if we go to branch, you can see that there is not only a single master, we have also got another branch which is called the first branch. Now if you want to check out this branch, just click on it and you can see it has all the files with all the commit logs here in this branch. So this is how you push changes, and if you want to push all the change into master, you can do the same thing. Let us go back to our branch master. And we're going to perform a git push here, but only what we're going to do this time is we're going to push all the files into the master branch in my central repository. So for that, I'll just use this git push. Okay, so the push operation is done, and if you go back here and if you go back to master, you can see that all the files that were in the master branch in my local repo has been added into the master branch of my central repo also. So this is how you make changes from your central repository to local repository. So this is exactly what you do with Git. So if I have to summarize what I just showed you entirely in this, when I was telling about Git add and committing and pushing and pulling, so this is exactly what is happening. So this is your local repository, this is your working directory. So the staging area is your index, the intermediate layer between your workspace and your local repository. So you have to add your files into the staging area or the index with git add, and you commit those changes with git commit into your local repository. And if you want to push all these changes into the remote repository or the central repository where everyone can see it, you use a git push. And similarly, if you want to pull all those files or fetch all those files from your GitHub repository, you can use git pull. And if you want to use branches, if you want to move from one branch to another, you can use git checkout. And if you want to combine the work of different branches together, you can use git merge. So this is entirely what you do when you're performing all these kind of operations. So I hope it is clear to everyone. So I'll just show you how can you check out what has been changed and modifications. So just clear your screen and okay, so let us go back to our terminal, and just for experimentation purpose, just to show you that how we can actually get revert back to our previous changes. So now you might not want to change everything that you made in edu1, edu2, edu4 or some other files that we just created. So let's just go and create a new file, modify it 2 times and revert back to the previous version just for demonstration purpose. So I'm just going to create a new text file. Let's call it revert. And now let us just type something. Hello. Let's just keep it that simple. Just save it and go back. We'll add this file. Then commit this. Let's say, just call it revert 1. Just remember that this is the first commit that I made with revert 1. Enter. So it has been changed. So now let's go back and modify this. So after I've committed this file, it means that it has stored a version with the text hello exclamation in my revert text file. So I'm just going to go back and change something in here. So let us just add there, hello there. Save it. Let's go back to our bash. Now let us commit this file again because I've made some changes and I want a different version of the revert file. So I'll just go ahead and commit again. So I'll use git commit all. say it's revert to, and enter, and it's done. So now if I want to revert back to, okay, so now if you just see the file, you can see I've modified it, so now it has got hello there. Let's say that I want to go back to my previous version. I would just want to go back to when I had just hello. So for that, I'll just check my git log. And you can check here that this is the commit log or the commit hash when I first committed revert. It means that this is the version 1 of my revert. Now, what you need to do is that you need to copy this commit hash. Now you can just copy the first 8 hexadecimal digits and that will be it. So just copy it whole. I just clear the screen first. So you just need to go use this command, git checkout, and the hexadecimal code or the hexadecimal digits that you just copied and the name of your file, which is revert.txt. So you just have to use this command, git checkout, and the commit hash that you just copied, the first 8 digits, and you have to name the file, which is revert.txt. So now when you just see this file, you have gone back to the previous commit, and now when you just display this file, you can see that now I've only got just hello. It means that I have rolled back to the previous version because I have used the commit hash when I initially committed with the first change. So this is how you revert back to a previous version. So this is what we have learned today in today's tutorial. We have understood what is version control and why do we need version controls, and we've also learned about the different version control tools, and in that we have primarily focused on Git, and we have learned all about Git and GitHub, about how to create repositories and perform some kind of operations and commands in order to push, pull, and move files from one repository to another. We've also studied about the features of Git, and we've also seen a case study about how Dominion Enterprises, which is one of the biggest publishing company who makes very popular websites that we have got right now, we have seen how they have used GitHub as well.
Hello everyone, this is Saurabh from Edureka. In today's session, we'll focus on what is Jenkins. So without any further ado, let us move forward and have a look at the agenda for today. First, we'll see why we need continuous integration. What are the problems that industries were facing before continuous integration was introduced? After that, we'll understand what exactly is continuous integration, and we'll see various types of continuous integration tools. Among those continuous integration tools, we'll focus on Jenkins, and we'll also look at Jenkins distributed architecture. Finally, in our hands-on part, we'll prepare a build pipeline using Jenkins, and I'll also tell you how to add Jenkins slaves. Now I'll move forward and we'll see why we need continuous integration. So this is the process before continuous integration. Over here, as you can see, that there's a group of developers who are making changes to the source code that is present in the source code repository. This repository can be a Git repository, subversion repository, etc. And when the entire source code of the application is written, it will be built by tools like Ant, Maven, etc. And after that, that built application will be deployed onto the test server for testing. If there's any bug in the code, developers are notified with the help of the feedback loop, as you can see it on their screen. And if there are no bugs, then the application is deployed onto the production server for release. I know you must be thinking that what is the problem with this process? This process looks fine. As you first write the code, then you build it, then you test it, and finally you deploy it. But let us look at the flaws that were there in this process one by one. So this is the first problem, guys. As you can see that there is a developer who is waiting for a long time in order to get the test results. As first, the entire source code of the application will be built, and then only it will be deployed onto the test server for testing. It takes a lot of time. So developers have to wait for a long time in order to get the test results. The second problem is, since the entire source code of the application is first built and then it is tested,
So if there's any bug in the code, developers have to go through the entire source code of the application. As you can see that there is a frustrated developer because he has written a code for an application which was built successfully, but in testing there were certain bugs in that. So he has to check the entire source code of the application in order to remove that bug, which takes a lot of time. So basically locating and fixing of bugs was very time consuming. So I hope we are clear with the two problems that we have just discussed. Now we'll move forward and we'll see two more problems that were there before continuous integration. So the third problem was software delivery process was slow. Developers were actually wasting a lot of time in locating and fixing of bugs instead of building new applications. As we just saw that locating and fixing of bugs was a very time consuming task, due to which developers were not able to focus on building new applications. You can relate that to the diagram which is present in front of your screen. As we all waste a lot of time in watching TV, doing social media, similarly developers were also wasting a lot of time in fixing bugs. Alright, so let us have a look at the fourth problem, that is continuous feedback. Continuous feedback related to things like build failures, test status, etc. was not present, due to which the developers were unaware of how their application is doing. The process that you showed before continuous integration, there was a feedback loop present. So what I'll do, I'll go back to that particular diagram and I'll try to explain you from there. So the feedback loop is here. When the entire source code of the application is built and tested, then only the developers are notified about the bugs in the code. Alright? When we talk about continuous feedback, suppose this developer that I'm highlighting makes any commit to the source code that is present in the source code repository. And at that time, the code should be pulled and it should be built. And the moment it is built, the developer should be notified about the build status. And then once it is built successfully, it is then deployed onto the test server for testing. At that time, whatever the test status is, the developer should be notified about it. Similarly, if this developer makes any commit to the source code, at that time the code should be pulled, it should be built, and the build status should be notified to the developers. After that, it should be deployed onto the test server for testing, and the test results should also be given to the developers. So I hope we all are clear what is the difference between continuous feedback and feedback. So in continuous feedback, you're getting the feedback on the run. So we'll move forward and we'll see how exactly continuous integration addresses these problems. Let us see how exactly continuous integration is resolving the issues that we have discussed. So what happens here, there are multiple developers. So if any one of them makes any commit to the source code that is present in the source code repository, the code will be pulled, it will be built, tested and deployed. So what advantage we get here? So first of all, any commit that is made to the source code is built and tested, due to which if there is any bug in the code, developers actually know where the bug is present or which commit has caused that error. So they don't need to go through the entire source code of the application. They just need to check that particular commit which has introduced the bug. Alright, so in that way, locating and fixing of bugs becomes very easy. Apart from that, the first problem that we saw, that developers have to wait for a long time in order to get the test result. Here, every commit made to the source code is tested. So they don't need to wait for a long time in order to get the test results. So when we talk about the third problem, that was software delivery process was slow, is completely removed with this process. Developers are not actually focusing on locating and fixing of bugs, because that won't take a lot of time as we just discussed. Instead of that, they're focusing on building new applications. Now our fourth problem was continuous feedback was not present. But over here, as you can see on the run, developers are getting the feedback about the build status, test results, etc. Developers are continuously notified about how their application is doing. So I'll move forward. Now I'll compare the two scenarios, that is before continuous integration and after continuous integration. Now over here what you can see is before continuous integration, as we just saw, first the source code of the application will be built, the entire source code, then only it will be tested. But when we talk about after continuous integration, every commit, whatever change you made in the source code, whatever change, a minute change as well, you commit it to the source code, that time only the code will be pulled, it will be built and then it will be tested. Developers have to wait for a long time in order to get the test results, as we just saw, because the entire source code will be first built and then it will be deployed onto the test server. But when we talk about continuous integration, the test result of every commit will be given to the developers. And when we talk about feedback, there was no feedback that was present earlier, but in continuous integration, feedback is present. For every commit you made to the source code, you'll be provided with the relevant result. Alright? So now let us move forward and we'll see what exactly is continuous integration. Now in continuous integration process, developers are required to make frequent commits to the source code. They have to frequently make changes in the source code, and because of that, any change made in the source code, it will be pulled by the continuous integration server, and then that code will be built, or you can say it will be compiled. Alright. Now depending on the continuous integration tool that you are using, or depending on the need of your organization, it will also be deployed onto the test server for testing, And once testing is done, it will also be deployed onto the production server for release. And developers are continuously getting the feedback about their application on the run. So I hope I'm clear with this particular process. So we'll see the importance of continuous integration with the help of a case study of Nokia. So Nokia adopted a process called nightly build. Nightly build can be considered as a predecessor to continuous integration. Let me tell you why. All right. So over here, as you can see that there are developers who are committing changes to the source code that is present in a shared repository. All right. And then what happens in the night, there's a build server. This build server will poll the shared repository for changes, and then it will pull that code and prepare a build. All right. So in that way, whatever commits are made throughout the day are compiled in the night. So obviously this process is better than writing the entire source code of the application and then compiling it. But again, since if there is any bug in the code, developers have to check all the commits that have been made throughout the day. So it is not the ideal way of doing things because you are again wasting a lot of time in locating and fixing of bugs. All right. So I want answers from you all guys. What can be the solution to this problem? How can Nokia address this particular problem? Since we have seen what exactly continuous integration is and why we need. Now, without wasting any time, I'll move forward and I'll show you how Nokia solved this problem. So Nokia adopted continuous integration as a solution, in which what happens, developers commit changes to the source code in a shared repository, all right? And then what happens is a continuous integration server. This continuous integration server polls the repository for changes if it finds that there is any change made in the source code, and it will pull the code and compile it. So what is happening? The moment you commit a change in the source code, continuous integration server will pull that and prepare a build. So if there's any bug in the code, developers know which commit is causing that error, all right? So they can just go through that particular commit in order to fix the bug. So in this way, locating and fixing of bugs was very easy. But we saw that in nightly builds, if there's any bug, they have to check all the commits that have been made throughout the day. So with the help of continuous integration, they know which commit is causing that error. So locating and fixing of bugs didn't take a lot of time. Okay, before I move forward, let me give you a quick recap of what we have discussed till now. First, we saw why we need continuous integration. What were the problems that industries were facing before continuous integration was introduced? After that, we saw how continuous integration addresses those problems, and we understood what exactly continuous integration is. And then in order to understand the importance of continuous integration, we saw case study of Nokia, in which they shifted from nightly build to continuous integration. So we'll move forward and we'll see various continuous integration tools available in the market. These are the four most widely used continuous integration tools. First is Jenkins, on which we'll focus in today's session. Then BuildBot, Travis, and Bamboo. All right. And let us move forward and see what exactly Jenkins is. So Jenkins is a continuous integration tool. It is an open source tool and it is written in Java. How it achieves continuous integration? It does that with the help of plugins. Jenkins have well over 1,000 plugins. And that is a major reason why we are focusing on Jenkins. Let me tell you guys, it is the most widely accepted tool for continuous integration because of its flexibility and the amount of plugins that it supports. So as you can see from the diagram itself, that it is supporting various development, deployment, testing technologies. For example, Git, Maven, Selenium, Puppet, Ansible, Nagios. All right. So if you want to integrate a particular tool, you need to make sure that plugin for that tool is installed in your Jenkins. Now for better understanding of Jenkins, let me show you the Jenkins dashboard. I've installed Jenkins in my Ubuntu box. So if you want to learn how to install Jenkins, you can refer the Jenkins installation video. So this is the Jenkins dashboard, guys. As you can see that there are currently no jobs. Because of that, this section is empty. Otherwise, it will give you the status of all your build jobs over here. Now when you click on new item, you can actually start a new project all over from the scratch. All right. Now let us go back to our slides. Let us move forward and see what are the various categories of plugins. As I've told you earlier as well, that Jenkins achieves continuous integration with the help of plugins. All right. And Jenkins supports well over 1,000 plugins. And that is a major reason why Jenkins is so popular nowadays. So the plugin categorization is there on your screen. There are certain plugins for testing like JUnit, Selenium, etc. When we talk about reports, we have multiple plugins, for example, HTML Publisher. For notification also, we have many plugins, and I've written one of them, that is Jenkins Build Notification plugin. When we talk about deployment, we have plugins like Deploy plugin. When we talk about compile, we have plugins like Maven and etc. All right. So let us move forward and see how to actually install a plugin on the same Ubuntu box where my Jenkins is installed. So over here, in order to install Jenkins, what you need to do is you need to click on Manage Jenkins option. And over here, as you can see, that there's an option called Manage Plugins. Just click over there. as you can see that it has certain updates for the existing plugins which I have already installed. Alright, then there's an option called installed where you'll get the list of plugins that are there in your system. Alright, and at the same time there's an option called available. It will give you all the plugins that are available with Jenkins. Alright, so now what I'll do, I'll go ahead and install a plugin that is called HTML Publisher. So it's very easy. What you need to do is just type the name of the plugin. Here it is, HTML Publisher plugin. Just click over there and install without restart. So it is now installing that plugin. We need to wait for some time. So it has now successfully installed. Now let us go back to our Jenkins dashboard. So we have understood what exactly Jenkins is, and we have seen various Jenkins plugins as well. So now is the time to understand Jenkins with an example. We'll see a general workflow how Jenkins can be used. Alright, so let us go back to our slides. So now, as I've told you earlier as well, we'll see a Jenkins example. So let us move forward. So over here what is happening, developers are committing changes to the source code, and that source code is present in a shared repository. It can be a Git repository, Subversion repository, or any other repository. Alright, now let us move forward and see what happens now. Now over here what is happening, there's a Jenkins server. It is actually polling the source code repository at regular intervals to see if any developer has made any commit to the source code. If there is a change in the source code, it will pull the code and it will prepare a build. And at the same time, developers will be notified about the build results. Now let us execute this practically. Alright, so I'll again go back to my Jenkins dashboard, which is there in my Ubuntu box. Over here what I'm going to do is I'm going to create a new item. Alright, basically a new project. Now over here I'll give a suitable name to my project. You can use any name that you want. I'll just write compile, and now I'll click on freestyle project. The reason for doing that is freestyle project is the most configurable and the flexible option. It is easier to set up as well. And at the same time, many of the options that we configure here are present in other build jobs as well. Move forward with freestyle project and I'll click on OK. Now over here what I'll do, I'll go to the source code management tab, and it will ask you for what type of source code management you want. I'll click on Git, and over here you need to type your repository URL. In my case it is https github.com, your username / the name of your repository, and finally .git. Alright, now in the build option you have multiple options. Alright, so what I'll do, I'll click on invoke top level Maven targets. So now over here let me tell you guys that Maven has a build lifecycle, and that build lifecycle is made up of multiple build phases. Typically the sequence for build phase will be, first you validate the code, then you compile it, then you test it, then you perform unit test by using suitable unit testing framework, then you package your code in a distributable format like jars, then you verify it, and you can actually install any package that you want with the help of install build phase, and then you can deploy it in the production environment for release. So I hope you have understood the Maven build lifecycle. So in the goals tab, so what I need to do is I need to compile the code that is present in the GitHub account. So for that, in the goals tab, I need to write compile. So this will trigger the compile build phase of Maven. Now that's it guys. That's it. Just click on apply and save. Now on the left hand side there's an option called build now to trigger the build. Just click over there and you will be able to see that the build is starting. In order to see the console output, you can click on that build and you'll see the console output. So it has validated the GitHub account and it is now starting to compile that code which is there in the GitHub account. So we have successfully compiled the code that was present in the GitHub account. Now let us go back to the Jenkins dashboard. Now in this Jenkins dashboard, you can see that my project is displayed over here. And as you can see, the blue color of the ball indicates that it has been successfully executed. Alright, now let us go back to the slides. Now let us move forward and see what happens once you have compiled your code. Now the code that you have compiled, you need to test it. Alright, so what Jenkins will do, it will deploy the code onto the test server for testing. And at the same time, developers will be notified about the test results as well. So let us again execute this practically. I'll go back to my Ubuntu box again. So in the GitHub repository, the test cases are already defined. Alright, so we are going to analyze those test cases with the help of Maven. So let me tell you how to do it. We'll again go and click on new item. And over here we'll give any suitable name to our project. I'll just type test. And I'll again use freestyle project for the reason that I've told you earlier. Click on OK. And in the source code management tab, Now before applying unit testing on the code that I've compiled, I need to first review it. With the help of PMD plugin, I'll do that. So for that, I'll again click on new item. And over here, I need to type the name of the project. So I'll just type it as code_review. Freestyle project, click OK. Now in the source code management tab, I'll again choose Git and give my repository URL, https github.com/username/name of the repository .git. Alright, now scroll down. Now in the build tab, I'm going to click over there, and again I'll click on invoke top level Maven targets. Now in order to review the code, I'm going to use the matrix profile of Maven. So how to do that? Let me tell you. You need to type here -p matrix pmd::pmd. Alright, and this will actually produce a PMD report that contains all the warnings and errors. Now in the post build action tab, I click on publish PMD analysis result. That's all. Click on apply and save. Now finally click on build now and let us see the console output. So it has now pulled the code from the GitHub account and performing the code review. So it has successfully reviewed the code. Now let us go back to the project. Over here you can see an option called PMD warnings. Just click over there and it will display all the warnings that are there present in your code. So this is the PMD analysis report. Over here, as you can see that there are total 11 warnings, and you can find the details here as well, like package you have, then you have categories, then the types of warnings which are there, like for example empty catch blocks, empty finally block. Now you have one more tab called warnings. Over there you can find where the warning is present, the file name, package. All right, then you can find all the details. In the details tab, it will actually tell you where the warning is present in your code. All right, now let us go back to the Jenkins dashboard, and now we'll perform unit test on the code that we have compiled. For that, again I'll click on new item and I'll give a name to this project. I'll just type test and I'll click on freestyle project. Okay. Now in the source code management tab, I'll click on Git. Now over here I'll type the repository URL, https github.com/username/name of the repository .git, and in the build option I'll click on again invoke top level Maven targets. Now over here, as I've told you earlier as well, that Maven build lifecycle has multiple build phases. Like first it will validate the code, compile, then test it, package, then it will verify, then it will install if certain packages are required, and then finally it will deploy it. Alright, so one of the phase is actually testing, that performs unit testing using the suitable unit testing framework. The test cases are already defined in my GitHub account. So to analyze that test case, in the goal section I need to write test. Alright, and it will invoke the test phase of the Maven build lifecycle. Alright, so just click on apply and save. Finally click on build now. To see the console output, click here. Now in the source code management tab, I'll select Git. Alright, over here again I need to type my repository URL, that is https github.com/username/repository name.git, and now in the build tab I'll select invoke top level Maven targets. And over here, as I've told you earlier as well, that the Maven build lifecycle has multiple phases. Alright, and one of that phase is a unit test. So in order to invoke that unit test, what I need to do is in the goals tab I need to write test, and it will invoke the test build phase of the Maven build lifecycle. Alright, so the moment I write test here and I'll build it, it will actually analyze the test cases that are present in the GitHub account. So let us write test and apply and save. Finally click on build now, and in order to see the console output, click here. So it has pulled the code from the GitHub account, and now it is performing unit test. So we have successfully performed testing on that code. Now I'll go back to my Jenkins dashboard. Over here, as you can see that all the 3 build jobs that I've executed are successful, which is indicated with the help of blue colored ball. Alright, now let us go back to our slides. So we have successfully performed a unit test on the test cases that were there on the GitHub account. Now we'll move forward and see what happens after that. Now finally you can deploy that build application onto the production environment for release. But when you have one single Jenkins server, there are multiple disadvantages. So let us discuss that one by one. So we'll move forward and we'll see what are the disadvantages of using one single Jenkins server. Now what I'll do, I'll go back to my Jenkins dashboard and I'll show you how to create a build pipeline. Alright. So for that, I'll move to my Ubuntu box once again. Now over here, you can see that there's an option of plus. Okay. Just click over there. Now over here, click on build pipeline view. Whatever name you want, you can give. I'll just give it as edureka underscore pipeline and click on OK. Now over here, what you can do, you can give some certain description about your build pipeline. All right. And there are multiple options that you can just have a look. And over here, there's an option called select initial job. So I want compile to be my first job. And there are display options over here, number of display builds that you want. I'll just keep it as 5. Now the row headers that you want, column headers. So you can just have a look at all these options and you can play around with them. Just for the introductory example, let us keep it this way. Now finally click on apply and OK. Now currently you can see that there is only one job that is compile. So what I'll do, I'll add more jobs to this pipeline. For that, I'll go back to my Jenkins dashboard and over here, I'll add code review as well. So for that, I'll go to configure and in this build triggers tab, what I'll do, I'll click on build after other projects are built. So whatever project that you want to execute before code review, just type that. So I want compile. Yeah, click on compile. And over here you can see that there are multiple options like trigger only if build is stable, trigger even if the build is unstable, trigger even if the build fails. So I'll just click on a trigger even if the build fails. Alright, finally click on apply and save. Similarly, if I want to add my test job as well to the pipeline, I can click on configure. And again the build triggers tab, I'll click on build after other projects are built. So over here type the project that you want to execute before this particular project. In our case it is code review. So let us click over there, trigger even if the build fails, apply and save. Now let us go back to the dashboard and see how our pipeline looks like. So this is our pipeline. Okay, so when we click on run, let us see what happens. First, it will compile the code from the GitHub account. That is, it will pull the code and it will compile it. So now this compile is done. All right, now it will review the code. So the code review has started. In order to see the log, you can click on console. It will give you the console output. Now once code review is done, it will start testing. It will perform unit test. All right, so code has been successfully reviewed. With the, as you can see, the color has become green. Now the testing has started. It will perform unit test on the test cases that are there in the GitHub account. So we have successfully executed the 3 build jobs, that is compile the code, then review it and then perform testing. Alright, and this is the build pipeline, guys. So let us go back to the Jenkins dashboard and we'll go back to our slides now. So now we have successfully performed unit test on the test cases that are present in the GitHub account. Alright, now let us move forward and see what else you can do with Jenkins. Now the application that we have tested, that can also be deployed onto the production server for release as well. Alright. So now let us move forward and see what are the disadvantages of this one single Jenkins server. So there are 2 major disadvantages of using one single Jenkins server. First is you might require different environments for your builds and test jobs. Alright, so at that time one single Jenkins server cannot serve our purpose. And the second major disadvantage is suppose you have heavier projects to build on regular basis. So at that time one single Jenkins server cannot simply handle the load. Let us understand this with an example. Suppose if you need to run web tests using Internet Explorer, so at that time you need a Windows machine, but your other build jobs might require a Linux box. So you can't use one single Jenkins server. Alright, so let us move forward and see what is actually the solution to this problem. The solution to this problem is Jenkins distributed architecture. So the Jenkins distributed architecture consists of a Jenkins master and multiple Jenkins slaves. So this Jenkins master is actually used for scheduling build jobs. It also dispatches builds to the slaves for actual execution. Alright. It also monitors the slave that is possibly taking them online and offline as required. And it also records and presents the build results. And you can directly execute a build job on master instance as well. Now when we talk about Jenkins slaves, these slaves are nothing but the Java executable that are present on remote machines. Alright. So these slaves basically here's a request from the Jenkins master, or you can say they perform the jobs as told by the Jenkins master. They operate on variety of operating system. So you can configure Jenkins in order to execute a particular type of build job on a particular Jenkins slave or on a particular type of Jenkins slave, or you can actually let Jenkins pick the next available Jenkins slave. Alright. Now I'll go back again to my Ubuntu box and I'll show you practically how to add Jenkins slaves. Now over here, as you can see that there is an option called Manage Jenkins. Just click over there, and when you scroll down, you'll see an option called Manage Nodes. And on the left hand side, there is an option called New Node. Just click over there. Click on Permanent Agent. Give a name to your slave. I'll just give it as slave_1. Click on OK. Over here, you need to write the remote root directories. So I'll keep it as /home/edureka, and labels are not mandatory. Still, if you want, you can use that. And launch method, I want it to be launch slave agents via SSH. Alright, over here you need to give the IP address of your host. So let me show you the IP address of my host. This is my Jenkins slave, which I'll be using like Jenkins slave. So this is the machine that I'll be using as Jenkins slave. In order to check the IP address, I'll type ifconfig, and this is the IP address of that machine. Just copy it. Now I'll go back to my Jenkins master, and in the host tab, I'll just paste that IP address. And over here, you can add the credentials. To do that, just click on add, and over here, you can give the username. I'll give it as root, password. That's all. Just click on add, and over here select it. Now finally save it. Now it is currently adding the slave. In order to see the logs, you can click on that slave again. Now it has successfully added that particular slave. Now what I'll do, I'll show you the logs. For that, I'll click on slave, and on the left hand side you will notice an option called log. Just click over there and it'll give you the output. So as you can see, agent has successfully connected and it is online right now. Now what I'll do, I'll go to my Jenkins slave and I'll show you in /home/edureka that it is added. Let me first clear my terminal. Now what I'll do, I'll show you the contents of /home/edureka. As you can see that we have successfully added slave.jar. That means we have successfully added Jenkins slave to our Jenkins master. Hello everyone, this is Saurabh from Edureka. In today's session, we'll focus on what is Docker. So without any further ado, let us move forward and have a look at the agenda for today. First, we'll see why we need Docker. We'll focus on various problems that industries were facing before Docker was introduced. After that, we'll understand what exactly Docker is. And for better understanding of Docker, we'll also look at a Docker example. After that, we'll understand how industries are using Docker with a case study of Indiana University. Our fifth topic will focus on various Docker components like images, containers, etc. And our hands-on part will focus on installing WordPress and PHP-MyAdmin using Docker Compose. So we'll move forward and we'll see why we need Docker. So this is the most common problem that industries were facing. As you can see that there is a developer who has built an application that works fine in his own environment. But when it reached production, there were certain issues with that application. Why does that happen? That happens because of difference in the computing environment between dev and product. I'll move forward and we'll see the second problem. Before we proceed with the second problem, it is very important for us to understand what are microservices. Consider a very large application. That application is broken down into smaller services. Each of those services can be termed as microservices. Or we can put it in another way as well. Microservices can be considered as small processes that communicates with each other over a network to fulfill one particular goal. Let us understand this with an example. As you can see that there is an online shopping service application. It can be broken down into smaller microservices like account service, product catalog, cart server, and order server. Microservice architecture is gaining a lot of popularity nowadays. Even giants like Facebook and Amazon are adopting microservice architecture. There are three major reasons for adopting microservice architecture, or you can say there are three major advantages of using microservice architecture. First, there are certain applications which are easier to build and maintain when they are broken down into smaller pieces or smaller services. Second reason is, suppose if I want to update a particular software or I want a new technology stack in one of my module or in one of my service, so I can easily do that because the dependency concerns will be very less when compared to the application as a whole. Apart from that, the third reason is if any of my module or any of my service goes down, then my whole application remains largely unaffected. So I hope we are clear with what are microservices and what are their advantages. So we'll move forward and see what were the problems in adopting this microservice architecture. So this is one way of implementing microservice architecture. Over here, as you can see that there's a host machine, and on top of that host machine, there are multiple virtual machines. Each of these virtual machines contains the dependencies for one microservice. So you must be thinking, what is the disadvantage here? The major disadvantage here is in virtual machines, there is a lot of wastage of resources. Resources such as RAM, processor, disk space are not utilized completely by the microservice which is running in these virtual machines. So it is not an ideal way to implement microservice architecture. And I have just given you an example of 5 microservices. What if there are more than 5 microservices? What if your application is so huge that it requires 50 microservices? So at that time, using virtual machines doesn't make sense because of the wastage of resources. So let us first discuss the implementation of microservice problem that we just saw. So what is happening here, there's a host machine, and on top of that host machine, there's a virtual machine. And on top of that virtual machine, there are multiple Docker containers, and each of these Docker containers contains the dependencies for one microservice. So you must be thinking, what is the difference here? Earlier we were using virtual machines, now we are using Docker containers on top of virtual machines. Let me tell you guys, Docker containers are actually lightweight alternatives of virtual machines. What does that mean? In Docker containers, you don't need to pre-allocate any RAM or any disk space. So it will take the RAM and disk space according to the requirements of applications. All right. Now let us see how Docker solves the problem of not having a consistent computing environment throughout the software delivery lifecycle. Let me tell you, first of all, Docker containers are actually developed by the developers. So now let us see how Docker solves the first problem that we saw, where an application works fine in development environment but not in production. So Docker containers can be used throughout the SDLC lifecycle in order to provide consistent computing environment. So the same environment will be present in dev, test, and product. So there won't be any difference in the computing environment. So let us move forward and understand what exactly Docker is. So the Docker containers does not use the guest operating system. It uses the host operating system. Let us refer to the diagram that is shown. This is the host operating system, and on top of that host operating system, there's a Docker engine. And with the help of this Docker engine, Docker containers are formed. And these containers have applications running in them. And the requirements for those applications, such as all the binaries and libraries, are also packaged in the same container. All right. And there can be multiple containers running. As you can see that there are two containers here, 1 and 2. So on top of the host machine, there's a Docker engine. And on top of the Docker engine, there are multiple containers. And each of those containers will have an application running in them. And whatever the binaries and libraries required for that application is also packaged in the same container. So I hope we are clear. So now let us move forward and understand Docker in more detail. So this is a general workflow of Docker, or you can say one way of using Docker. Over here, what is happening? A developer writes a code that defines an application requirements or the dependencies in an easy to write Docker file. And this Docker file produces Docker images. So whatever dependencies are required for a particular application is present inside this image. And what are Docker containers? Docker containers are nothing but the runtime instance of Docker image. This particular image is uploaded onto the Docker Hub. Now what is Docker Hub? Docker Hub is nothing but a Git repository for Docker images. It contains public as well as private repositories. So from public repositories, you can pull your image as well. And you can upload your own images as well onto the Docker Hub. All right. From Docker Hub, various teams such as QA or production team will pull the image and prepare their own containers, as you can see from the diagram. So what is the major advantage we get through this workflow? So whatever the dependencies that are required for your application is actually present throughout the software delivery lifecycle. If you can recall the first problem that we saw, that an application works fine in development environment, but when it reaches production, it is not working properly. So that particular problem is easily resolved with the help of this particular workflow, because you have a same environment throughout the software delivery lifecycle, be it dev, test, or product. We'll see, for better understanding of Docker, a Docker example. So this is another way of using Docker. In the previous example, we saw that Docker images were used, and those images were uploaded onto the Docker Hub. And from Docker Hub, various teams were pulling those images and building their own containers. But Docker images are huge in size and requires a lot of network bandwidth. So in order to save that network bandwidth, we use this kind of a workflow. Over here, we use Jenkins servers or any continuous integration server to build an environment that contains all the dependencies for a particular application or a microservice. And that build environment is deployed onto various teams like testing, staging, and production. So let us move forward and see what exactly is happening in this particular image. Over here, developer has written complex requirements for a microservice in an easy to write Docker file. And the code is then pushed onto the Git repository. From Git repository, continuous integration servers like Jenkins will pull that code and build an environment that contains all the dependencies for that particular microservice. And that environment is deployed onto testing, staging, and production. So in this way, whatever requirements are there for your microservice is present throughout the software delivery lifecycle. So if you can recall the first problem where application works fine in dev but does not work in prod. So with this workflow, we can completely remove that problem because the requirements for the microservice is present throughout the software delivery lifecycle. And this image also explains how easy it is to implement a microservice architecture using Docker. Now let us move forward and see how industries are adopting Docker. So this is the case study of Indiana University. Before Docker, they were facing many problems. So let us have a look at those problems one by one. The first problem was they were using custom script in order to deploy their application onto various VMs. So this requires a lot of manual steps. And the second problem was their environment was optimized for legacy Java-based applications. But their growing environment involves new products that aren't solely Java-based. So in order to provide their students the best possible experience, they needed to begin modernizing their applications. Let us move forward and see what all other problems Indiana University was facing. So in the previous problem of Indiana University, they wanted to start modernizing their applications. So for that, they wanted to move from a monolithic architecture to a microservice architecture. And the previous slides, we also saw that if you want to update a particular technology in one of your microservice, it is easy to do that because there'll be very less dependency constraints when compared to the whole application. So because of that reason, they wanted to start modernizing their application. They wanted to move to a microservice architecture. Let us move forward and see what are the other problems that they were facing. Indiana University also needed security for their sensitive student data such as SSN and student healthcare data. So there are four major problems that they were facing before Docker. Now let us see how they have implemented Docker to solve all these problems. The solution to all these problems was Docker Data Center. And Docker Data Center has various components which are there in front of your screen. First is Universal Control Plane, then comes LDAP, Swarm, CS Engine, and finally Docker Trusted Registry. Now let us move forward and see how they have implemented Docker Data Center in their infrastructure. This is a workflow of how Indiana University has adopted Docker Data Center. This is Docker Trusted Registry. It is nothing but the storage of all your Docker images. And each of those images contains the dependencies for one microservice. As we saw that Indiana University wanted to move from a monolithic architecture to a microservice architecture. So because of that reason, these Docker images contain the dependencies for one particular microservice, but not the whole application. All right. After that comes Universal Control Plane. It is used to deploy services onto various hosts with the help of Docker images that are stored in the Docker Trusted Registry. So IT Ops team can manage their entire infrastructure from one single place with the help of Universal Control Plane web user interface. They can actually use it to provision Docker installed software on various hosts and then deploy application, so without doing a lot of manual steps. As we saw in the previous slides that Indiana University was earlier using custom scripts to deploy application onto VMs. That requires a lot of manual steps. That problem is completely removed here. When we talk about security, the role-based access controls within the Docker data center allowed Indiana University to define a level of access to various teams. For example, they can provide read-only access to Docker containers for production team. And at the same time, they can actually provide read and write access to the dev team. So I hope we all are clear with how Indiana University has adopted Docker Data Center. We'll move forward and see what are the various Docker components. First is Docker registry. Docker registry is nothing but the storage of all your Docker images. Your images can be stored either in public repositories or in private repositories. These repositories can be present locally or it can be present on the cloud. Docker provides a cloud-hosted service called Docker Hub. Docker Hub has public as well as private repositories. From public repositories, you can actually pull an image and prepare your own containers. At the same time, you can write an image and upload that onto the Docker Hub. You can upload that into your private repository or you can upload that on a public repository as well. That is totally up to you. So for better understanding of Docker Hub, let me just show you how it looks like. So this is how Docker Hub looks like. So first you need to actually sign in with your own login credentials. After that, you'll see a page like this which says welcome to Docker Hub. Over here, as you can see that there is an option of create repository where you can create your own public or private repositories and upload images. And at the same time, there's an option called explore repositories. This contains all the repositories which are available publicly. So let us go ahead and explore some of the publicly available repositories. So we have repositories for Nginx, Redis, Ubuntu, then we have Docker registry, Alpine, Mongo, MySQL, Swarm. So what I'll do, I'll show you a CentOS repository. So this is the CentOS repository which contains the CentOS image. Now what I'll do, later in the session, I'll actually pull a CentOS image from Docker Hub. Now let us move forward and see what are Docker images and containers. So Docker images are nothing but the read-only templates that are used to create containers. These Docker images contains all the dependencies for a particular application or a microservice. You can create your own image and upload that onto the Docker Hub, and at the same time you can also pull the images which are available in the public repositories and in Docker Hub. Let us move forward and see what are Docker containers. Docker containers are nothing but the runtime instances of Docker images. It contains everything that is required to run an application or a microservice. And at the same time, it is also possible that more than one image is required to create one container. All right. So for better understanding of Docker images and Docker containers, what I'll do on my Ubuntu box, I'll pull a CentOS image and I'll run a CentOS container in that. So let us move forward and first install Docker in my Ubuntu box. So guys, this is my Ubuntu box. Over here, first I'll update the packages. So for that, I'll type sudo apt get update. So asking for password. It is done now. Before installing Docker, I need to install the recommended packages. So for that, I'll type sudo apt get install linux -image -extra -uname space -r, and now a linux -image -extra -virtual, and here we go. Press Y. So we are done with the prerequisites. So let us go ahead and install Docker. So for that, I'll type sudo apt get install docker -engine. So we have successfully installed Docker. If you want to install Docker and CentOS, you can refer the CentOS Docker installation video. Now we need to start this Docker service. So for that, I'll type sudo service docker start. So it says the job is already running. Now what I'll do, I'll pull a CentOS image from Docker Hub and I'll run the CentOS container. So for that, I'll type sudo docker pull and the name of the image, that is CentOS. So first it will check the local registry for CentOS image. If it doesn't find there, then it will go to the Docker Hub for CentOS image and it will pull the image from there. So we have successfully pulled a CentOS image from Docker Hub. Now I'll run the CentOS container. So for that, I'll type sudo docker run -it CentOS. That is the name of the image. And here we go. So we are now in the CentOS container. Let me exit from this. Clear my terminal. So let us now recall what we did. First, we installed Docker on Ubuntu. After that, we pulled CentOS image from Docker Hub. And then we built a CentOS container using that CentOS image. Now I'll move forward and I'll tell you what exactly Docker Compose is. So let us understand what exactly Docker Compose is. Suppose you have multiple applications on various containers and all those containers are actually linked together. So you don't want to actually execute each of those containers one by one, but you want to run those containers at once with a single command. So that's where Docker Compose comes into the picture. With Docker Compose, you can actually run multiple applications present on various containers with one single command, that is docker-compose up. As you can see that there is an example in front of you. Imagine you're able to define 3 containers, one running a web app, another running a Postgres, and another running a Redis in a YAML file. That is called Docker Compose file. And from there, you can actually execute all these 3 containers with one single command, that is docker-compose up. Let us understand this with an example. Suppose you want to publish a blog. For that, you'll use CMS. And WordPress is one of the most widely used CMS. So you need one container for WordPress, and you need one more container for MySQL as backend. And that MySQL container should be linked to the WordPress container. Apart from that, you need one more container for PHP-MyAdmin that should be linked to MySQL database, as it is used to access MySQL database. So what if you are able to define all these 3 containers in one YAML file, and with one command, that is docker-compose up, all 3 containers are up and running. So let me show you practically how it is done on the same Ubuntu box where I've installed Docker and I've pulled a CentOS image. So this is my Ubuntu box. First, I need to install Docker Compose here. But before that, I need Python pip. So for that, I'll type sudo apt-get install python-pip, and here we go. So it is done now. I will clear my terminal and now I'll install Docker Compose. For that, I'll type sudo pip install docker-compose, and here we go. So Docker Compose is successfully installed. Now I'll make a directory and I'll name it as WordPress. mkdir WordPress. Now I'll enter this WordPress directory. Now over here, I'll edit docker-compose.yaml file using gedit. You can use any other editor that you want. I'll use gedit. So I'll type sudo gedit docker-compose.yaml, and here we go. So over here, what I'll do, I'll first open a document and I'll copy this YAML code and I will paste it here. So let me tell you what I've done. First, I've defined a container and I've named it as WordPress. It is built from an image, WordPress, that is present on the Docker Hub. But this WordPress image does not have a database. So for that, I've defined one more container and I've named it as WordPress_DB. It is actually built from the image that is called MariaDB, which is present in the WordPress. And I need to link this WordPress_DB with the WordPress container. So for that, I've written links WordPress_DB:MySQL. All right. And in the port section, this port 80 of the Docker container will actually be linked to port 8080 of my host machine. So are we clear till here? Now what I've done, I've defined a password here as edureka. You can give whatever password that you want. And I've defined one more container called PHP myadmin. This container is built from the image corbinus/docker-php myadmin that is present on the Docker Hub. Again, I need to link this particular container with WordPress_DB container. So for that, I've written links WordPress_DB:MySQL. And the port section, the port 80 of my Docker container will actually be linked to port 8181 of the host machine. And finally, I've given a username that is root, and I've given a password as edureka. So let us now save it and we'll quit. Let me first clear my terminal. And now I'll run a command sudo docker-compose up-d, and here we go. So this command will actually pull all the three images and will build the three containers. So it is done now. Let me clear my terminal. Now what I'll do, I'll open my browser, and over here I'll type the IP address of my machine, or I can type the host name as well. Host name of my machine is localhost. So I'll type localhost and port 8080 that I've given for WordPress. So it will direct you to a WordPress installation page. Over here you need to fill this particular form which is asking you for site title. I'll give it as edureka. Username also I'll give as edureka. Password I'll type edureka. Confirm the user weak password. Then type your email address. And it is asking search engine visibility, which I want, so I won't click here. And finally I'll click on install WordPress. So this is my WordPress dashboard, and WordPress is now successfully installed. Now what I'll do, I'll open one more tab, and over here I'll type localhost or the IP address of my machine, and I'll go to port 8181 for PHP myadmin. And over here I need to give the username. If you can recall, I've given root, and password I've given as edureka. And here we go. So PHP myadmin is successfully installed. This PHP myadmin is actually used to access a MySQL database. And this MySQL database is used as backend for WordPress.
If you've landed on this video, then it's definitely because you want to install a Kubernetes cluster at your machine. Now, we all know how tough the installation process is, hence this video on our YouTube channel. My name is Vardhan, and I'll be your host for today. So without wasting any time, let me show you what are the various steps that we have to follow. Now, there are various steps that we have to run both at the master's end and the slave end, and then a few commands only at the master's end to bring up the cluster, and then one command which has to be run at all the slave ends so that they can join the cluster. Okay, so let me get started by showing you those commands and those installation steps which have to be run commonly on both the master's end and the slave end. First of all, we have to update your repository. Okay, since I'm using Ubuntu, I'll have to update my apt-get repository. Okay, and after that, we will have to turn off the swap space. Be it the master's end or the slave's end, Kubernetes will not work if the swap space is on. Okay, we have to disable that. So there are a couple of commands for that. And then the next part is we have to update the host name, the hosts file, and we have to set a static API address for all the nodes in your cluster. Okay, we have to do that because at any point of time, if your master or if your node in the cluster fails, then when they restart, they should have the same IP address. If you have a dynamic IP address, and then if they restart because of a failure condition, then it'll be a problem because they will not be able to join the cluster because they'll have a different IP address. So that's why we have to do these things. All right, there are a couple of commands for that. And after that, we have to install the OpenSSH server and Docker. That is because Kubernetes requires the OpenSSH functionality, and it of course needs Docker because everything in Kubernetes is containers, right? So we are going to make use of Docker containers. So that's why we have to install these two components. And finally, we have to install kubeadm, kubelet, and kubectl. Now, these are the core components of your Kubernetes. All right. So these are the various components that have to be installed on both your master and your slave end. So let me first of all open up my VMs and then show you how to get started. Now, before I get started, let me tell you one thing. You have a cluster, you have a master, and then you have slaves in that cluster, right? Your master should always have better configurations than your slave. So for that reason, if you're using virtual machines on your host, then you have to ensure that your master has at least 2 GB of RAM and 2 core CPUs, okay? And your slave has 2 GB of RAM, and at least 1 core CPU. So these are the basic necessities for your master and slave machines. On that note, I think I can get started. So first of all, I'll bring up my virtual machine and go through these installation processes. So I hope everyone can see my screen here. This is my first VM, and what I'm going to do is I'm going to make this my master. Okay, so all the commands to install the various components are present with me in my notepad. Okay, so I'm going to use this for reference and then quickly execute these commands and show you how Kubernetes is installed. So first of all, we have to update our apt-get repository. Okay, but before that, let's log in as su. Okay, so I'm going to do a sudo su so that I can execute all the following commands as sudo user. Okay, so sudo su, there goes my root password, and now you can see the difference here, right? Here I was executing it as a normal user, but from here I'm a root user, so I'm going to execute all these commands as su. So first of all, let's do an update. I'm going to copy this and paste it here. apt-get update updates my Ubuntu repositories. All right, so it's going to take quite some time, so just hold on till it's completed. Okay, so this is done. The next thing I have to do is turn off my swap space. Okay, now the command to disable my swap space is swap off space flag A. Let me go back here and do the same. Okay, swap off with flag A. And now we have to go to this fs tab. So this is a file called fs tab. Okay, and we will have a line with the entry of swap space, because at any point of time, if you've enabled swap space, then you'll have a line over there. Now we have to disable that line. Okay, we can disable that line by commenting out that line. So let me show you how that's done. I'm just using the nano editor to open this fs tab file. Okay, so you can see this line, right, where it says swap file. This is the one which I have to comment out. So just let me come down here and comment it out like this. Okay, with a hash. Now let me save this and exit. Now the next thing I have to do is update my host name and my hosts file and then set a static IP address. So let me get started by first updating the host name. So for that, I have to go to this file host name, which is in this /etc path. So I'm again using nano for that. You can see here it's edureka-virtualbox, right? So let me replace this and say kmaster as in Kubernetes master. So let me save this and exit. Now if you want your host name to reflect over here, because right now it says root@edureka-virtualbox. The host name does not look updated as yet. And if you want it to be updated to kmaster, then you have to first of all restart this VM or your system. If you're doing it on a system, then you have to restart your system. And if you're doing it on a VM, you have to restart your VM. Okay, so let me restart my VM in some time. But before that, there are a few more commands which I want to run. And that is set a static IP address. Okay, so I'm going to copy this ifconfig. I'm going to run the ifconfig command. Okay, so right now my IP address is 192.168.56.101. And the next time when I turn on this machine, I do not want a different IP address. So to set this as a static IP address, I have a couple of commands. Let me execute that command first. So you can see this interfaces file, right? So under etc/network, we have a file called interfaces. So this is where you define all your network interfaces. Now let me enter this file and add the rules to make it a static IP address. As you can see here, the last 3 lines are the ones which ensure that this machine will have a static IP address. These 3 lines are already there on my machine. Now, if you want to set a static IP address at your end, then make sure that you have these things defined correctly. Okay, my IP address is .101, so I would just retain it like this. So let me just exit. So the next thing that I have to do is go to the hosts file and update my IP address over there. Okay, so I'm gonna copy this and go to my etc/hosts files. Now over here you can see that there's no entry, so I have to mention that this is my kmaster. So let me specify my IP address first. This is my IP address, and now we have to update the name of the host. So this host of mine is kmaster. So I'm just gonna enter that and save this. Okay, now the thing that we have to do now is restart this machine. So let me just restart this machine and get back to you in the meanwhile. Okay, so now that we are back on, let me check if my host name and hosts have all been updated. Yes, there you go. You can see here, right, edureka@kmaster. So this means that my host name has been successfully updated. We can also verify if my IP address is the same. Let me do an if config. And as you can see, my IP address has not changed. All right, so this is good. Now this is what we wanted. Now let's continue with our installation process. Let me clear the screen and go back to the notepad and execute those commands, which first of all install my OpenSSH server. So this is going to be the command to do that, and we have to execute this as sudo user, right? So sudo apt-get install OpenSSH server, that's the command. Okay, let me say yes and enter. Okay, so my SSH server would have been installed by now. Let me clear the screen and install Docker. But before I run this command, which installs Docker, I need to update my repository. Okay, so let me log in as sudo first of all. Okay, sudo su is the command, and okay, I've logged in as root user. Now the next thing is update my repository. So I have to do an apt-get update. Now again, this is going to take some more time, so just hold on till then. Okay, this is also done. Now I can straight away run the command to install Docker. Now this is the command to install Docker. Okay, from the apt-get repository, I'm installing Docker. I'm just specifying -y because -y is my flag. So whenever there's a prompt that comes in while installation saying, do you want to install it, yes or no, then when you specify -y, then it means that by default it will accept y as a parameter. Okay, so that is the only concept behind -y. So again, installing Docker is going to take a few more minutes. Just hang on till then. Okay, great. So Docker is also installed. Okay, so let me go back to the notepad. So to establish the Kubernetes environment, the three main components that Kubernetes is made up of are kubeadm, kubelet, and kubectl. But just before I install these three components, there are a few things I have to do. They are like installing curl and then downloading certain packages from this URL and then running an update. Okay, so let me execute these commands one after the other first and then install Kubernetes. So let's first of all start with this command where I'm installing curl. Okay, now the next command is basically downloading these packages using curl. And curl is basically this tool using which you can download these packages using your command line. Okay, so this is basically a web URL, right? So I can access whatever packages are there on this web URL and download them using curl. So that's why I've installed curl in the first place. So when executing this command, I get this, which is perfect. Now when I go back, then there is this which I have to execute. Okay, let me hit enter and I'm done. And finally, I have to update my apt-get repository. And the command for that is this one, apt-get update. Okay, great. So all the pre-installation steps are also done. Now I can straight away set up my Kubernetes environment by executing this command. So in the same command, I say install kubelet, kubeadm, and kubectl. And to just avoid the yes prompt, I'm specifying the -y flag, okay, which would by default take yes as a parameter. And of course, I'm taking it from the apt-get repository, right? So let me just copy this and paste it here. Give it a few more minutes, guys, because installing Kubernetes is going to take some time. Okay, bingo. So my Kubernetes has also been installed successfully. Okay, now let me conclude the setting up of this Kubernetes environment by updating the Kubernetes configuration. Okay, so there's this file here, right? kubeadm.conf. So the kubeadm is the one that's going to let me administer my Kubernetes. So I have to go into this file and add this one line. Okay, so let me first of all open up this file using my nano editor. So let me again log in as sudo su, and this is the command. So as you can see, we have these set of environment variables. So right after the last environment variable, I have to add this one line, and that line is this one. All right, now let me just save this and exit. Brilliant. So with that, the components which have to be installed at both the master and the slave come to an end. Now what I have to do next is run certain commands only at the master to bring up the cluster, and then run this one command at all my slaves to join the cluster. All right, so before I start doing anything more over here, let me also tell you that I have already done the same steps on my node. So if you are doing it at your end, then whatever steps you've done so far, run the same set of commands on another VM, because that will be acting as your node VM. But in my case, I've already done that just to save some time, So let me show you that. This is my K master, and right here, I have my K node, which is nothing but my Kubernetes node. And I've basically run the same set of commands in both the places. But there's just one thing which I have to ensure before I bring up the cluster, and that is ensure the network IP addresses and the host name and the hosts. So this is my Kubernetes node. So first of all, I'm going to do a cat and say /etc hosts. Okay. Now over here, I have the IP address of my Kubernetes node, that is this very machine, and I've specified the name of the host. However, the name of my Kubernetes master host is not present, and neither is the IP address. So that is one manual entry we have to do. If you remember, let me go to my master and check what is the IP address. Yes, so the IP address over here is 192.168.56.101. So this is the IP address I have to add in my node end. So I have to modify this file for that. All right. But before that, you have to also ensure that this is a static IP address. So let me ensure that the IP address of my cluster node does not change. So the first thing we have to do before anything is check what is the current IP address. And for my node, the IP address is 192.168.56.102. Okay. Now let me run this command, network interfaces. Okay. So as you can see here, this is already set to be a static IP address. You have to ensure that these same lines are there in your machine if you want it to be a static IP address. Since it's already there for me, I'm not going to make any change, but rather I'm going to go and check what's my host name. I mean, the host name should anyways give the same thing, because right now it's Knode, so that's what it's going to reflect. But anyways, let me just show it to you. Okay, so my host name is Knode. Brilliant. So this means that there's just one thing which I have to change, and that is nothing but adding the particular entry for my master. So let me first clear the screen, and then using my nano editor, in fact, I'll have to run it as sudo. So as a sudo user, I'm going to open my nano editor and edit my hosts file. Okay, so here, let me just add the IP address of my master. So what exactly is the IP address of the master? Yes, this is my K master. So I'm just going to copy this IP address, come back here and paste the IP address. And I'm going to say the name of that particular host is K master. And now let me save this. Perfect. Now what I have to do now is go back to my master and ensure that the host file here has details about my slave. I'll clear the screen, and first I'll open up my hosts file. So on my master's end, the only entry is there for the master. So I have to write another line where I'll specify the IP address of my slave and then add the name of that particular host, that is Knode. And again, let me use the nano editor for this purpose. So I'm going to say sudo nano /etc hosts. Okay. So I'm going to come here, say 192.168.56.102, and then say Knode. All right. Now all the entries are perfect. I'm going to save this and exit. So the hosts file on both my master and my slave has been updated. The static IP address for both my master and the slave has been updated, and also the Kubernetes environment has been established. Okay. Now before we go further and bring up the cluster, let me do a restart because I've updated my hosts file. Okay, so let me restart both of my master and my slave VMs. And if you're doing it at your end, then you have to do the very same. Okay, so let's say restart. And similarly, let me go to my node here and do a restart. Okay, so I've just logged in. And now that my systems are restarted, I can go ahead and execute the commands at only the master's end to bring up the cluster. Okay, so first of all, let me go through the steps which are needed to be run on the master's end. So at the master, first of all, we have to run a couple of commands to initiate the Kubernetes cluster, and then we have to install a pod network. We have to install a pod network because all my containers inside a single pod will have to communicate over a network. Pod is nothing but a network of containers. So there are various container networks which I can use. So I can use the Calico pod network, I can use the Flannel pod network, or I can use anyone. You can see the entire list in the Kubernetes documentation. And in this session, I'm going to use the Calico network. Okay, so that's pretty simple and straightforward. And that's what I'm going to show you next. So once you've set up the pod network, you can straight away bring up the Kubernetes dashboard. And remember that you have to set up the Kubernetes dashboard and bring this up before your nodes join the cluster. Because in this version of Kubernetes, if you first get your nodes to join the cluster, and after that, if you try bringing the Kubernetes dashboard up, then your Kubernetes dashboard gets hosted on the node. And you don't want that to happen, right? If you want the dashboard to come up at your master's end, you have to bring up the dashboard before your nodes join the cluster. So these will be the 3 commands that we will have to run: initiating the cluster, installing the pod network, and then setting up the Kubernetes dashboard. So let me go to my master and execute commands for each of these processes. So I suppose this is my master, and yes, this is my K master. So first of all, to bring up the cluster, we have to execute this command. Let me copy this, and over here we have to replace the IP addresses. So the IP address of my master, right? So this machine, I have to specify that IP address over here, because this is where the other IP addresses can come and join. This is the IP address of the master, right? So I'm just saying API server advertise the address 56.101 so that all the other nodes can come and join the cluster on this IP address. And along with this, I have to also specify the pod network. Since I've chosen the Calico pod network, there's a network range which my Calico pod network uses. So CNI basically stands for Container Network Interface. If I'm using the Calico pod network, then I have to use this network range. But in case if you want to use a flannel pod network, then you can use this network range. Okay, so let me just copy this one and paste it. All right, so the command is sudo kubeadm init pod network followed by the IP address from where the other nodes will have to join. So let's go ahead and hit enter. So since you're doing it for the first time, give it a few minutes because Kubernetes takes some time to install. So just hold on until that happens. All right. Okay, great. Now it says that your Kubernetes master has initialized successfully. That's good news. And it also says that to start using your cluster, you need to run the following commands as a regular user. Okay, so note that log out as a sudo user, and as a regular user, execute these 3 commands. And also, if I have to deploy a pod network, then I have to run a command. Okay, so this is that command which I have to run to bring up my pod network. So I'll be basically cloning the YAML file which is present over here. So before I get to all these things, let me show you that we have a kube join command which is generated, right? So this is generated at my master's end, and I have to execute this command at my node to join the cluster. But that would be the last step, because like I said earlier, these 3 commands will have to be first executed, then I have to bring up my pod network, then I have to bring up my dashboard, and then I have to get my nodes to join the cluster using this command. So for my reference, I'm just going to copy this command and store it somewhere else. Okay, so right under this, let me just store this command for later reference. And in the meanwhile, let me go ahead and execute all these commands one after the other. These are as per Kubernetes' instructions, right? Yes, I would like to rewrite it. And then, okay. Now that I've done with this, let me first of all bring up my pod network. Okay, now the command to bring up my pod network is this. Perfect. So my Calico pod has been created. Now I can verify if my pod has been created by running the kubectl get pods command. Okay, so this is my kubectl get pods. I can say -o wide all namespaces. Okay, by specifying the -o wide and all namespaces, I'll basically get all the pods ever deployed, even the default pods which get deployed when the Kubernetes cluster initiates. So basically the Kubernetes cluster is initiated and deployed along with a few default ones, especially for your pod network. There's one pod which is hosted for your cluster, there's one pod for your pod itself, and then there's one pod which is deployed for your dashboard and whatnot. So this is the entire list, right? So for your Calico, for your etcd, there's one pod. For your kube controller, there's a pod, and we have various pods like this, right? For your master and your API server and many things. So these are the default deployments that you get. So anyways, as you can see, the default deployments are all healthy because it says the status is all running and everything is basically running in the kube system namespace. All right, and it's all running on my K master. That's my Kubernetes master. So the next thing that I have to do is bring up the dashboard before I can get my nodes to join. Okay, so I'll go to the notepad and copy the command to bring up my dashboard. So copy and paste. So great. This is my Kubernetes dashboard, which has, basically this pod has come up. Now, if I execute this same kubectl get pods command, then you can see that I've got one more pod which is deployed for my dashboard basically. So last time this was not there because I had not deployed my dashboard at that time, right? So I had only deployed my pod network and whatnot and the other things, right? So I've deployed it and the container is creating. So in probably a few more seconds, this would also be running. Anyways, in the meanwhile, what we can do is we can work on the other things which are needed to bring up the dashboard. To first of all enable your proxy and get it to be hosted on web server, there's this kubectl proxy command. Okay, so with this, your service would be starting to be served on this particular port number. Okay, localhost port number 8001 of my master. Okay, not from the nodes. So if I could just go to my Firefox and go to localhost 8001, then my dashboard would be up and running over there. So basically my dashboard is being served on this particular port number. But if I want to actually get my dashboard which shows my deployments and all my services, then that's a different URL. Okay, so yeah, as you can see here, localhost 8000/API/v1, right? This entire URL is which is going to lead me to my dashboard. But at this point of time, I cannot log into my dashboard because it's prompting me for a token. And I do not have a token because I have not done any cluster role binding and I have not mentioned that I am the admin of this particular dashboard. So to enable all those things, there are a few more commands that we have to execute, starting with creating a service account for your dashboard. So this is the command to create your service account. So go back to the terminal and probably a new terminal window, execute this command. Okay, so with this, you're creating a service account for your dashboard. And after that, you have to do the cluster role binding for your newly created service account. Okay, so the dashboard has been created in default namespace as per this. Okay, and here I'm saying that my dashboard is going to be for admin and I'm doing the cluster role binding. Okay, and now that this is created, I can straight away get the token, because if you remember, it's asking me for a token to log in, right? So even though I'm the admin now, I will not be able to log in without the token. So to generate the token, I have to again run this command, kubectl get secret key. Okay, so I'm going to copy this and paste it here. So this is the token, or this is the key that basically needs to be used. So let me copy this entire token and paste it over here. So let me just save this. And yeah, now you can see that my Kubernetes cluster has been set up and I can see the same thing from the dashboard over here. So basically by default, the Kubernetes service is deployed, right? So this is what you can see, but I've just brought up the dashboard now and my cluster is not ready until my nodes join in. So let's go to the final part of this demonstration, wherein I'll ask my slaves to join the cluster. So you remember I had copied the join cluster which was generated at my master's end in my notepad. So I'm going to copy that and execute that at the slave's end to join the cluster. Okay, so let me first of all go to my notepad, and yeah, this is the join command which I had copied, right? So I'm going to copy this and now I'm going to go to my node. Yeah, so let me just paste this and let's see what happens. Let me just run this command as sudo. So perfect, I've got the message that I've successfully established connection with the API server on this particular IP address and port number, right? So this means that my node has joined the cluster. We can verify that from the dashboard itself. So if I go back to my dashboard, which is hosted on my master's end, so I have an option here as nodes. If I click on this, then I will get the details about my nodes over here. So earlier I only had the K master, but now I have both the K master and the K node. Give it a few more seconds until my node comes up. I can also verify the same from my terminal. So if I go to my terminal here and if I run the command kubectl get nodes, then it will give me the details about the nodes which are there in my cluster. So kmaster is one that is already there in the cluster, but knode, however, will take some more time to join my cluster. All right, so that's it, guys. So that is about my deployment, and that's how you deploy a Kubernetes cluster. So from here on, you can do whatever deployment you want. Whatever you want to deploy, you can deploy it easily, very effectively, either from the dashboard or from the CLI. And there are various other video tutorials of ours which you can refer to see how a deployment is made on Kubernetes. So I would request you to go to the other videos and see how deployment is made. And I would like to conclude this video on that note. If you're a DevOps guy, then you would have definitely heard of Kubernetes. But I don't think the DevOps world knows enough of what exactly Kubernetes is and where it's used. And that's why we at Edureka have come up with this video on what is Kubernetes. My name is Vardhan, and I'll be representing Edureka in this video. And as you can see from the screen, these will be the topics that I'll be covering in today's session. I'll first start off by talking about what is the need for Kubernetes. And after that, I will talk about what exactly it is and what it's not. And I will do this because there are a lot of myths surrounding Kubernetes and there's a lot of confusion. People have misunderstood Kubernetes to be a containerization platform. Well, it's not. Okay, so I will explain what exactly it is over here, and then after that I will talk about how exactly Kubernetes works. I will talk about the architecture and all the related things. And after that, I will give you a use case. I will tell you how Kubernetes was used at Pokemon Go and how it helped Pokemon Go become one of the best games of the year 2017. And finally, at the end of the video, you will get a demonstration of how to do deployment with Kubernetes. Okay, so I think the agenda is pretty clear to you. I think we can get started with our first topic then. Now, first topic is all about why do we need Kubernetes. Okay, now to understand why do we need Kubernetes, let's understand what are the benefits and drawbacks of containers. Now, first of all, containers are good. They are amazingly good, right? Any container for that matter of fact, a Linux container or a Docker container or even a Rocket container, right? They all do one thing. They package your application and isolate it from everything else, right? They isolate the application from the host mainly. And this makes the container fast, reliable, efficient, lightweight, and scalable. Now, hold the thought. Yes, containers are scalable, but then there's a problem that comes with that. And this is what is the resultant of the need for Kubernetes. Even though containers are scalable, they are not very easily scalable. Okay, so let's look at it this way. You have one container, you might want to probably scale it up to 2 containers or 3 containers. Well, it's possible, right? It's going to take a little bit of manual effort, but yeah, you can scale it up. You're not going to have a problem. But then look at a real world scenario where you might want to scale up to like 50 to 100 containers. Then in that case, what happens? I mean, after scaling up, what do? You have to manage those containers, right? You have to make sure that they're all working, they're all active, and they're all talking to each other. Because if they're not talking to each other, then there's no point of scaling up itself. Because in that case, the servers would not be able to handle the loads if they're not able to talk to each other, correct? So it's really important that they are manageable when they are scaled up. And now let's talk about this point. Is it really tough to scale up containers? Well, the answer for that might be no. It might not be tough. It's pretty easy to scale up containers, but the problem is what happens after that. Okay, once you scale up containers, you'll have a lot of problems. Like I told you, the containers first of all should have to communicate with each other because there are so many in number, and they work together to basically host the service, right? The application. And if they are not working together and talking together, then the application is not hosted and scaling up is a waste. So that's the number one reason. And the next is that the containers have to be deployed appropriately and they have to also be managed. They have to be deployed appropriately because you cannot have the containers deployed in just random places. You have to deploy them in the right places. You cannot have one container in one particular cloud and the other one somewhere else. So that would have a lot of complications. Well, of course it's possible, but yeah, it would lead to a lot of complications internally. You want to avoid all that. So you have to have one place where everything is deployed appropriately, and you have to make sure that the IP addresses are set everywhere and the port numbers are open for the containers to talk to each other and all these things, right? So these were the 2 other points. The next point or the next problem with scaling up is that auto scaling is never a functionality over here. Okay, and this is one of the things which is the biggest benefit with Kubernetes. The problem technically is there's no auto scaling functionality. Okay, there's no concept of that at all. And you may ask at this point of time, why do we even need auto scaling? Okay, so let me explain the need for auto scaling with an example. So let's say that you are an e-commerce portal, okay, something like an Amazon or a Flipkart, and let's say that you have decent amount of traffic on the weekdays, but on the weekends you have a spike in traffic. Probably you have like 4x or 5x the usual traffic. And in that case, what happens is maybe your servers are good enough to handle the requests coming in on weekdays, right? But the requests that come on the weekends, right, from the increased traffic, that cannot be serviced by your servers, right? Maybe it's too much for your servers to handle the load. And maybe in the short term, it's fine. Maybe once or twice you can survive, but there will definitely come a time when your server will start crashing because it cannot handle that many requests per second or per minute. And if you want to really avoid this problem, what do? You have to scale up. And now would you ideally keep scaling up every weekend and scaling down after the weekend, right? I mean, technically, is it possible? Will you be buying your servers and then setting it up, and every Friday would you be again buying new servers, setting up your infrastructure, and then the moment your weekday starts, would you just destroy all your servers, whatever you built? Would you be doing? No, right? Obviously, that's a pretty tedious task. So that's where something like Kubernetes comes in. And what Kubernetes does is it keeps analyzing your traffic and the load that's being used by the container. And as and when the traffic is reaching the threshold, auto scaling happens, wherein if the servers have a lot of traffic and if it needs more such servers for handling requests, then it starts scaling up the containers on its own. There's no manual intervention needed at all. So that's one benefit with Kubernetes, and one traditional problem that we have with scaling up of containers. Okay, and then yeah, the one last problem that we have is the distribution of traffic. That is still challenging without something that can manage your containers. I mean, you have so many containers, but how will the traffic be distributed? Load balancing, how does that happen? You just have containers, right? You have 50 containers. How does the load balancing happen? So all these are questions we should really consider, because containerization is all good and cool. It was much better than VMs. Yes, containerization, it was basically a concept which was sold on the basis of scaling up, right? We said that VMs cannot be scaled up easily, so we told use containers, and with containers you can easily scale up. So that was the whole reason we basically sold containers with the tagline of scaling up. But in today's world, our demand is ever more that even the regular containers cannot be enough. So scaling up is so much or in so detail that we need something else to manage your containers. Correct? Do we agree there? We need something, right? And that is exactly what Kubernetes is. So Kubernetes is a container management tool. All right. So this is open source, and this basically automates your container deployment, your container scaling and descaling, and your container load balancing. The benefit with this is that it works brilliantly with all the cloud vendors, with all your public cloud vendors or your hybrid cloud vendors, and it also works on premises. So that is one big selling point of Kubernetes, right? And if I should give more information about Kubernetes, then let me tell you that this was a Google developed product. Okay, it's basically a brainchild of Google, and that pretty much is the end of the story for every other competitor out there, because the community that Google brings in along with it is going to be huge. Or basically the head start that Kubernetes would get because of being a Google brainchild is humongous, and that is one of the reasons why Kubernetes is one of the best container management tools in the market, period. And given that Kubernetes is a Google product, they have written the whole product on Go language, and of course now Google has contributed this whole Kubernetes project to the CNCF, which is nothing but the Cloud Native Computing Foundation, or simply Cloud Native Foundation, right? You can just call them either that, and they've donated their open source project to them. And if I have to just summarize what Kubernetes is, you can just think of it like this. It can group like a number of containers into one logical unit for managing and deploying an application or a particular service. So that's a very simple definition of what Kubernetes is. It can be easily used for deploying your application. Of course, it's going to be Docker containers which you will be deploying, but since you will be using a lot of Docker containers as part of your production, you will also have to use Kubernetes, which will be managing your multiple Docker containers, right? So this is the role it plays in terms of deployment. And scaling up, scaling down is primarily the game of Kubernetes. From your existing architecture, it can scale up to any number you want. It can scale down anytime. And the best part is the scaling can also be set to be automatic, like I just explained some time back, right? You can make Kubernetes would analyze the traffic and then figure out if the scaling up needs to be done or the scaling down can be done, and all those things. And of course, the most important part, load balancing, right? I mean, what good is your container or group of containers if load balancing cannot be enabled, right? So Kubernetes does that also. And these are some of the points based on which Kubernetes is built. So I'm pretty sure you have got a good understanding of what Kubernetes is by now, right? A brief idea at least. So moving forward, let's look at the features of Kubernetes. Okay, so we've seen what exactly Kubernetes is, how it uses Docker containers or other containers in general. But now let's see some of the selling points of Kubernetes, or why it's a must for you. Let's start off with automatic bin packing. When we say automatic bin packing, it's basically that Kubernetes packages your application and it automatically places containers based on their requirements and the resources that are available. So that's the number one advantage. The second thing, service discovery and load balancing. There is no need to worry. I mean, if if you're going to use Kubernetes, then you don't have to worry about networking and communication, because Kubernetes will just automatically assign containers their own IP addresses and probably a single DNS name for a set of containers which are performing a logical operation. And of course, there will be load balancing across them. So you don't have to worry about all these things. So that's why we say that there is service discovery and load balancing with Kubernetes. And the third feature of Kubernetes is that storage orchestration. With Kubernetes, you can automatically mount your storage system of your choice. You can choose that to be either a local storage or maybe on a public cloud provider such as a GCP or AWS, or even a network storage system such as NFS or other things, right? So that was the feature number 3. Now, feature number 4, self-healing. Now, this is one of my favorite parts of Kubernetes. Actually, not just Kubernetes, even with respect to Docker Swarm, I really like this part of self-healing. What self-healing is all about is that whenever Kubernetes realizes that one of your containers has failed, then it will restart that container on its own, right? It will create a new container in place of this crashed one. And in case your node itself fails, then what Kubernetes would do in that case is whatever containers were running in that failed node, those containers would be started in another node, right? Of course, you would have to have more nodes in that cluster. If there's another node in the cluster, definitely room would be made for this failed container to start its service. So that happens. So the next feature is batch execution. So when we say batch execution, it's that along with services, Kubernetes can also manage your batch and CI workloads, which is more of a DevOps role, right? So as part of your CI workloads, Kubernetes can replace your containers which fail, and it can restart and restore the original state. That is what is possible with Kubernetes. And secret and configuration management. That is another big feature with Kubernetes. And that is the concept of where you can deploy and update your secrets and application configuration without having to rebuild your entire image and without having to expose your secrets in your stack configuration or anything, right? So if you want to deploy and update your secrets, only that can be done. So it's not available with all the other tools, right? So Kubernetes is one that does that. You don't have to restart everything and rebuild your entire container. That's one benefit. And then we have horizontal scaling, which of course you people might be aware of already. You can scale your applications up and down easily with a simple command. The simple command can be run on the CLI, or you can easily do it on your GUI, which is your dashboard, your Kubernetes dashboard, or auto scaling is possible, right? Based on the CPU usage, your containers would automatically be scaled up or scaled down. So that's one more feature. And the final feature that we have is automatic rollbacks and rollouts. Now, Kubernetes, what it does is whenever there's an update to your application which you want to release, Kubernetes progressively rolls out these changes and updates to the application or its configurations by just ensuring that one instance after the other is sent these updates. And it makes sure that not all instances are updated at the same time, thus ensuring that, yes, there is high availability. And even if something goes wrong, then the Kubernetes will roll back that change for you. So all these things are enabled, and these are the features with Kubernetes. So if you're really considering a solution for your containers, for managing your containers, then Kubernetes should be your solution, right? So that should be your answer. So that is about the various features of Kubernetes. Now, moving forward, here let's talk about a few of the myths surrounding Kubernetes. And we are doing this because a lot of people have confusion with respect to what exactly it is. So people have this misunderstanding that Kubernetes is like Docker, which is a containerization platform, right? That's what people think. And that is not true. So this kind of a confusion is what I intend to solve in the upcoming slides. I will talk about what exactly Kubernetes is and what Kubernetes is not. Let me start with what it's not. Now, the first thing is that Kubernetes is not to be compared with Docker because it's not the right set of parameters which you are comparing them against. Docker is a containerization platform and Kubernetes is a container management platform, which means that once you have containerized your application with the help of Docker containers or Linux containers, and when you are scaling up these containers to a big number like 50 or 100, that's where Kubernetes would come in. When you have like multiple containers which need to be managed, that's where Kubernetes can come in and effectively do it. You can specify the configurations and Kubernetes would make sure that at all times these conditions are satisfied. So that's what Kubernetes is. You can tell in your configurations that at all time I want these many containers running, I want these many pods running, and so many other needs, right? You can specify much more than that. And whatever you do, at all times, your cluster master or your Kubernetes master would ensure that this condition is satisfied. So that is what exactly Kubernetes is. But that does not mean that Docker does not solve this purpose. So Docker also have their own plugin. I wouldn't call it a plugin. It's actually another tool of theirs. So there's something called as Docker Swarm. And Docker Swarm does a similar thing. It does container management, like mass container management. So similar to what Kubernetes does, when you have like 50 to 100 containers, Docker Swarm would help you in managing those containers. But if you look at who is prevailing in the market today, I would say it's Kubernetes because Kubernetes came in first And the moment they came in, they were backed by Google, and they had this huge community which they just swept along with them. So they have like hardly left any market for Docker and for Docker Swarm. But that does not mean that they are better than Docker, because they are at the end of the day using Docker. So Kubernetes is only as good as what Docker is. If there are no Docker containers, then there's no need for Kubernetes in the first place. So Kubernetes and Docker, they go hand in hand. Okay, so that is the point you have to note. And I think that would have also explained the point that Kubernetes is not for containerizing applications, right? And the last thing is that Kubernetes is not for applications with a simple architecture. Okay, if your architecture, if your application's architecture is pretty complex, then you can probably use Kubernetes to uncomplex that architecture. Okay, but if you're having a very simple one in the first place, then using Kubernetes would not serve you any good, and it could probably make it a little more complicated than what it already is, right? So this is what Kubernetes is not. Now, speaking of what exactly Kubernetes is, the first point is Kubernetes is robust and reliable. Now, when I say robust and reliable, I'm referring to the fact that the cluster that is created, the Kubernetes cluster, right? This is very strong. It's very rigid, and it's not going to be broken easily. The reason being the configurations which you specify, right? At any point of time, if any container fails, a new container would come up, right? Or that whole container would be restarted. One of the things will definitely happen. If your node fails, then the containers which are running in a particular node, they would start running in a different node, right? So that's why it's reliable and it's strong, because at any point of time, your cluster would be at full force. And at any time, if it's not happening, then you would be able to see that something's wrong and you have to troubleshoot your node, and then everything would be fine. So Kubernetes would do everything possible, and it pretty much does everything possible to let us know that the problem is not at its end, and it's giving the exact result that we want. That's what Kubernetes are doing. And the next thing is that Kubernetes actually is the best solution for scaling up containers, at least in today's market, because the two biggest players in this market are Docker Swarm and Kubernetes. And Docker Swarm is not really the better one here, because they came in a little late. Even though Docker was there from the beginning, Kubernetes came after that. But Docker Swarm, which we are talking about, came in somewhere around 2016 or 2017, right? But Kubernetes came somewhere around 2015, and they had a very good head start. They were the first ones to do this, and their backing by Google is just icing on the cake, because whatever problem you have with respect to containers, if you just go up and if you put your error there, then you will have a lot of people on github.com and GitHub queries, and then on Stack Overflow, who will be resolving those errors, right? So that's the kind of market they have. So it's backed by a really huge community. That's what Kubernetes is. And to conclude this slide, Kubernetes is a container orchestration platform and nothing else. All right, so I think these two slides would have given you more information and more clarity with respect to what Kubernetes is and how different it is from Docker and Docker Swarm, right? So now moving on, let's go to the next topic, where we will compare Kubernetes with Docker Swarm. And we are comparing with Docker Swarm because we cannot compare Docker and Kubernetes head on. Okay, so that is what you have to understand. If you are this person over here, if you are Sam who is wondering which is the right comparison, then let me reassure you that the difference can only be between Kubernetes and Docker Swarm. Okay, so let's go ahead and see what the difference is actually. Let's start off with your installation and configuration. Okay, so that's the first parameter we'll use to compare these two. And over here, Docker Swarm comes out on top, because Docker is a little easier. You have around 2 or 3 commands which will help you have your cluster up and running. That includes the node joining the cluster, right? But with Kubernetes, it's way more complicated than Docker Swarm, right? So you have like close to 10 to 11 commands which you have to execute, and then there's a certain pattern you have to follow to ensure that there are no errors, right? Yes, and that's why it's time consuming, and that's why it's complicated. But once your cluster is ready, that time Kubernetes is the winner, because the flexibility, the rigidness, and the robustness that Kubernetes gives you cannot be offered by Docker Swarm. Yes, Docker Swarm is faster, but yes, not as good as Kubernetes when it comes to your actual working. And speaking of the GUI, once you have set up your cluster, you can use a GUI with Kubernetes for deploying your applications, right? So you don't need to always use your CLI. You have a dashboard which comes up, and the dashboard, if you give it admin privileges, then you can use it. You can deploy your application from the dashboard itself. Everything just drag and drop, click functionality, right? With just click functionality, you can do that. The same is not the case with Docker Swarm. You have no GUI in Docker Swarm, okay, period. So Docker Swarm is not the winner over here. It's Kubernetes. And yes, going to the third parameter, scalability. So people again have a bad misconception that Kubernetes is better. It is the solution for scaling up, and it is better and faster than Docker Swarm. Well, it could be better, but yes, it's not faster than Docker Swarm. Even if you want to scale up, right? There's a report where I recently read that the scaling up in Docker Swarm is almost 5 times faster than the scaling up with Kubernetes. So that is the difference. But yes, once your scaling up is done, after that, your cluster strength with Kubernetes is going to be much stronger than your Docker Swarm cluster strength. That's again because of the various configurations that should have been specified by then. That is the thing. Now, moving on to the next parameter we have is load balancing. Requires manual service configuration. Okay, this is in case of Kubernetes. And yes, this could be a shortfall, but with Docker Swarm, there is inbuilt load balancing techniques, which you don't need to worry about. Okay, even the load balancing, which requires manual effort in case of Kubernetes, is not too much. There are times when you have to manually specify what are your configurations. You have to make a few changes, but yes, it's not as much as what you're thinking. And speaking of updates and rollbacks, what Kubernetes does is it does the process scheduling to maintain the services while updating. Okay. Yeah, that's very similar to how it works with Docker Swarm, wherein you have like progressive updates and service health monitoring happens throughout the update. But the difference is when something goes wrong, Kubernetes goes that extra mile of doing a rollback and putting you back to the previous state, right? Before the update was launched. So that is the thing with Kubernetes. And the next parameter we are comparing those two upon is data volumes. So data volumes in Kubernetes can be shared with other containers, but only within the same pod. So we have a concept called pods in Kubernetes. Okay, now pod is nothing but something which groups related containers, right? A logical grouping of containers together. So that is a pod. And whichever containers are there inside this pod, they can have a shared volume, okay, like storage volume. But in case of Docker Swarm, you don't have the concept of pod at all. So the shared volumes can be between any other container. There is no restriction with respect to that in Docker Swarm. And then finally, we have this parameter called the logging and monitoring. So when it comes to logging and monitoring, Kubernetes provides inbuilt tools for this purpose. Okay, but with Docker Swarm, you have to install third-party tools if you want to do logging and monitoring. So that is the fallback with Docker Swarm, because logging is really important. One, because you will know what the problem is, you'll know which container failed, what happened, where is exactly the error, right? So logs would help you give that answer. And monitoring is important because you have to always keep a check on your nodes, right? So as the master of the cluster, it's very important that there's monitoring. And that's where Kubernetes has a slight advantage over Docker Swarm. Okay, but before I finish this topic, there is this one slide I want to show you, which is about the statistics. So this stat, I picked it up from this Platform 9, which is nothing but a company that writes about tech. Okay, and what they've said is that the number of news articles that were produced, right, in that one particular year had 90% of those covered on Kubernetes compared to the 10% on Docker Swarm. Amazing, right? That's a big difference. That means for every one blog written or for every one article written on Docker Swarm, there are 9 different articles written on Kubernetes. And similarly for web searches. For web searches, Kubernetes is 90% compared to Docker Swarm's 10%. And publications, GitHub stars, the number of commits on GitHub, all these things are clearly won by Kubernetes everywhere. So Kubernetes is the one that's dominating this market, and that's pretty visible from this stat also, right? So I think that pretty much brings an end to this particular topic. Now moving forward, let me show you a use case. Let me talk about how this game, this amazing game called Pokemon Go, was powered with the help of Kubernetes. I'm pretty sure you all know what it is, right? You guys know Pokemon Go. It's the very famous game, and it was actually the best game of the year 2017. And the main reason for that being the best is because of Kubernetes. And let me tell you why. But before I tell you why, there are a few things which I want to just talk about. I'll give you a overview of what Pokemon Go is, and let me talk about a few key stats. So Pokemon Go is an augmented reality game developed by Niantic for your Android and for iOS devices. Okay, and those key stats read that they've had like 500 million plus downloads overall and 20 million plus daily active users. Now that is massive. Daily, if you're having like 20 million users plus, then you have achieved an amazing thing. So that's how good this game is. Okay. And then this game was actually initially launched only in North America, Australia, New Zealand. And I'm aware of this fact because I'm based out of India and I did not get access to this game because the moment news got out that we have a game like this, I started downloading it, but I couldn't really find any link or I couldn't download it at all. So They launched it only in these countries, but what they faced, right, in spite of just releasing it in these 3 countries, they had like a major problem. And that problem is what I'm going to talk about in the next slide, right? So my use case is based on that very fact that in spite of launching it only in these 3 countries, or in probably North America and then in Australia and New Zealand, they could have had a meltdown, but rather with the help of Kubernetes, they used that same problem as the basis for their success. So that's what happened. Now, let that be a suspense. And before I get to that, let me just finish this slide. One amazing thing about Pokemon Go is that it has inspired users to walk over 5.4 billion miles in a year. Okay, yes, do the math. 5.4 billion miles in 1 year. That's again a very big number. And it says that it has surpassed engineering expectations by 50 times. Now, this last line is not with respect to the Pokemon Go, the game, but it is with respect to the backend and the use of Kubernetes to achieve whatever was needed. Okay, so I think I've spent enough time over here. Let me go ahead and talk about the most interesting part and tell you how the backend architecture of Pokemon Go was. Okay, so you have a Pokemon Go container which had 2 primary components. One is your Google Bigtable, which is your main database where everything is going in and coming out. And then you have your programs, which is run on your Java cloud, right? So these 2 things are what is running your game. MapReduce and Cloud Dataflow were something which was used for scaling up. Okay, so it's not just the container scaling up, but it's with respect to the application, how the program would react when there are these increased number of users and how to handle increased number of requests. So that's where the MapReduce is the paradigm comes in, right? The mapping and then reducing that whole concept. So this was their one deployment. Okay, and when we say into 5, it means that they had their server capacities which could go up till 5 times. Okay, so technically they could only serve X number of requests, but in case of failure conditions or heavy traffic load conditions, the max the server could handle was 5x, because after 5x the server would start crashing. That was their prediction. Okay, and what actually happened at Pokemon Go on releasing in just those 3 different geographies is that the moment they deployed it, the usage became so much that it was not X number of times, which is technically their failure limit, and it is not even 5x, which is the server's capability, but the traffic that they got was up to 50 times, 50 times more than what they expected. So you know that when your traffic is so much, then you're going to be brought down to your knees. That's a definite and that's a given, right? This is like a success story, and this is too good to be true kind of a story. And in that kind of a scenario, if the requests start coming in are so much that if they reach 50x, then it's gone, right? The application is gone for a toss. So that's where Kubernetes comes in, and they overcome all the challenges. How do they overcome the challenges? Because Kubernetes can do both vertical scaling and horizontal scaling at ease. And that is the biggest problem, right? Because any application and any other company can easily do horizontal scaling, where you just spin up more containers and more instances and you set up the environment. But vertical scaling is something which is very specific, and this is even more challenging. Now it's more specific to this particular game because the virtual reality would keep changing. Whenever a person moves around or walks around somewhere in his apartments or somewhere on the road, then the RAM, right, that would have to increase. The memory, the in-memory and the storage memory, all this would increase. So in real time, your server's capacity also has to increase vertically. So once they have deployed it, it's not just about horizontal scalability anymore. It's not about satisfying more requests. It's about satisfying that same request with respect to having more hardware space, more RAM space, and all these things, right? That one particular server should have more performance abilities. That's what it is about. And Kubernetes solved both of these problems effortlessly. And Niantic were also surprised that Kubernetes could do it. And that was because of the help that they got from Google. I read an article recently that the head of Niantic's lab, he met with some of the top executives in Google and in GCP, right? And then they figured out how things are supposed to go. And they, of course, met with the heads at Kubernetes, and they figured out a way to actually scale it up to 50 times in a very short time. So that is the challenge that they were presented. And thanks to Kubernetes, they could handle 50 times the traffic that they expected, which is like a very one-off story, and which is very, very surprising that, something like this would happen. So that is about the use case, and that pretty much brings an end to this topic of how Pokemon Go used Kubernetes to achieve something. Because in today's world, Pokemon Go is a really revered game because of what it could, right? It basically beat all the stereotypes of a game, and whatever anybody could have anything negative against the game, right? So they could say that these mobile games and video games make you lazy, they make you just sit in one place and all these things, right? and Pokemon Go was something which was different. It actually made people walk around and it made people exercise, and that goes on to show how popular this game became. If Kubernetes lies at the heart of something which became so popular and something that became so big, then you should imagine how big Kubernetes or how useful Kubernetes is, right? So that is about this topic. Now, moving forward, let me just quickly talk about the architecture of Kubernetes. Okay, so the Kubernetes architecture is very simple. You have the kube master, which controls pretty much everything. You should note that it is not like Docker Swarm where your kube master will also have containers running. Okay, so there won't be containers over here. So all the containers will be running, all the services which will be running will be only on your nodes. It's not going to be on your master. And you would have to first of all create your master. That's the first step in creating your cluster, and then you would have to get your nodes to join your cluster. Okay, so be it your pods or be it your containers, everything would be running on your nodes, and your master would only be scheduling or replicating these containers across all these nodes and making sure that your configurations are satisfied, right? Whatever you specify in the beginning. And the way you access your kube master is via two ways. You can either use it via the UI or via the CLI. So the CLI is the default way, and this is the main way technically, because if you want to start setting up your cluster, you use the CLI, you set up your cluster, and from here you can enable the dashboard. And when you enable the dashboard, then you can probably get the GUI, and then you can start using your Kubernetes and start deploying by just with the help of the dashboard, right? By just the click functionality, you can deploy an application which you want rather than having to write a YAML file or feed commands one after the other from the CLI. So that is the working of Kubernetes. Okay, now let's concentrate a little more on how things work on the node end. Now, as said before, Kubernetes master controls your nodes, and inside nodes you have containers. Okay, and now these containers are not just contained inside them, but they are actually contained inside pods. Okay, so you have nodes inside which there are pods, and inside each of these pods there will be n number of containers depending upon your configuration and your requirement. Right now, these pods which contain n number of containers are a logical binding or a logical grouping of these containers. Supposing you have an application X which is running in node 1. Okay, so you will have a pod for this particular application, and all the containers which are needed to execute this particular application will be a part of this particular pod, right? So that's how pod works, and that's what the difference is with respect to Docker Swarm and Kubernetes, because in Docker Swarm you will not have a pod, you just have containers running on your node. And the other two terminologies which you should know is that of replication controller and service. Your replication controller is the master's resource to ensuring that the requested number of pods are always running on the nodes, right? So that's like your confirmation or an affirmation which says that, okay, this many number of pods will always be running and these many number of containers will always be running, something like that, right? So you say it and the replication controller will always ensure that's happening. And your service is just an object on the master that provides load balancing across a replicated group of pods, right? So that's how Kubernetes works. And I think this is good enough introduction for you. And I think now I can go to the demo part, wherein I will show you how to deploy applications on your Kubernetes via either your CLI or either via your YAML files or via your dashboard. Okay, guys, so let's get started. And for the demo purpose, I have two VMs with me. Okay, so as you can see, this is my kube master, which would be acting as my master in my cluster. And then I have another VM, which is my kube node 1. Okay, so it's a cluster with one master and one node. All right, now for the ease of purpose for this video, I have compiled the list of commands in this text document, right? So here I have all the commands which are needed to start your cluster and then the other configurations and all those things. So I'll be using these. I'll be copying these commands and then I'll show you side by side, and I will also explain when I do that as to what each of these commands mean. Now, there's one prerequisite that needs to be satisfied, and that is the master should have at least 2 core CPUs, okay, and 4 GB of RAM, and your node should have at least 1 core CPU and 4 GB of RAM. So just make sure that this much of hardware is given to your VMs, right? If you're using Ubuntu or a Linux operating system, well and good, but if you're using a VM on top of a Windows OS, then I would request you to satisfy these things, okay, these two criteria. And I think we can straight away start. Let me open up my terminal first of all. Okay, this is my node. I'm going back to my master. Okay, yes. So first of all, if you have to start your cluster, you have to start it from your master's end. Okay, and the command for that is kube adm init. You specify the pod network flag and the API server flag. We are specifying the pod network flag because the different containers inside your pod should be able to talk to each other easily, right? So that was the whole concept of self-discovery, which I spoke about earlier during the features of Kubernetes. So for the self-discovery, we have like different pod networks using which the containers would talk to each other. And if you go to the documentation, the Kubernetes documentation, you can find a lot of options there. You can use either a Calico pod, or you can use a flannel pod network. So when we say pod network, it's basically acronymed as CNI, okay, container network interface. Okay, so you can use either a Calico CNI or a flannel CNI or any of the other ones. These are the two popular ones, and I will be using the Calico CNI. Okay, so this is the network range for this particular pod, and this we'll have to specify over here. Okay, and then over here we'll have to specify the IP address of the master. So let me first of all copy this entire line, and before I paste it here, let me do an if config and find out what is the IP address of this particular machine, of my master machine. The IP address is 192.168.56.101. Okay, so let's just keep that in mind, and let me paste the command over here in place of the master IP address. I'm going to specify the IP address of the master, okay, which I just read out. It is 192.168.56.101. And the pod network, I told you that I'm going to use the Calico pod, so let's copy this network range and paste it here. So all my containers inside this particular pod would be assigned an IP address in this range. Okay, now let me just go ahead and hit enter, and then your cluster would begin to set up. So it's going as expected. So it's going to take a few minutes, so just hold on there. Okay, perfect. My Kubernetes master has initialized successfully, and if you want to start using your cluster, you have to run the following as a regular user, right? So we have 3 commands which is suggested by Kubernetes itself, and that is actually the same set of commands that even I have here. Okay, so I'll be running the same commands. This is to set up the environment, and then after that we have this token generated, right? The joining token. So the token along with the init address of the IP of the master, if I basically execute this command in my nodes, then I will be joining this cluster where this is the master, right? So this is my master machine. This just created the cluster. So now before I do this though, there are a few steps in the middle. One of those steps is executing all these 3 commands, and after that comes bringing up the dashboard and setting up the pod network, right? Mine is the Calico pod, so I'll have to set up the Calico pod, and then I have to also set up the dashboard. Because if I do not start the dashboard and this before the nodes, then the node cannot join, and I will have various other complications. So let me first of all go ahead and run these 3 commands one after the other. Okay, since I have the same commands in my text doc, I'll just copy it from there. Okay, I'll say Control C, paste, enter. Okay, and I'll copy this line. So remember, you have to execute all these things as regular user. Okay, you can probably use your sudo, but yeah, you'll be executing it as your regular user. And it's asking me if I want to overwrite the existing whatever's there in this directory. I would say yes, because I've already done this before. But if you are setting up the cluster for the first time, you will not have this prompt. Okay, now let me go to the 3rd line, copy this and paste it here. Okay, perfect. Now I've ran these 3 commands as I was told by Kubernetes. Now the next thing that I have to do is, before I check the node status and all these things, let me just set up the network, okay, the pod network. So like I said, this is the line, this is the command that we have to run to set up the Calico network, okay, to allow the nodes to join our particular network. So it will be copying the template of this calico.yaml file which is present over here in this docs. Okay, so hit enter, and yes, my thing is created. Calico cube controller is created. Now I'll just go back here and see, at this point of time I can check if my master is connected to the particular pod. Okay, so I can run the kubectl get nodes command. Okay, this would say that I have one particular resource connected to the cluster, okay, name of the machine, and this role is master, and yeah, the status is ready. Okay, if you want to get an idea of all the different pods which are running by default, then you can do the kubectl get pods along with a few options. Okay, you should specify these flags, and they are all namespaces, and with the flag O specify wide. Okay, so this way I get all the pods which are started by default. Okay, So there are different services like etcd for Cube controllers, for the Calico node, for the etcd master. For every single service, there's a separate container and pod started. Okay, so that's what you can understand from this part. Okay, that is the safe assumption. Now that we know the cluster, cluster is ready and the master is part of the cluster, let's go ahead and execute this dashboard. Okay, remember, if you want to use a dashboard, then you have to run this command before your nodes join this particular cluster. Because the moment your nodes join into the cluster, bringing up the dashboard is going to be challenging and it will start throwing errors. Okay, it will say that it's being hosted on the node, which we do not want. We want the dashboard to be on the server itself, right, on the master. So first, let's bring the dashboard up. So I'm going to copy this and paste it here. Okay, enter. Great. My Kubernetes dashboard is created. Now, the next command that you have to get your dashboard up and running is kubectl proxy. Okay, with this, you'll get a message saying that it's being served at this particular port number. And yes, you are right now there. You can, if you access localhost, what was the port number again? Localhost, yeah, 127.0.0.1 is localhost. Okay, followed by port number 8001. Okay, yeah, so right now we are not having the dashboard because it is technically accessed on another URL. But before we do that, there are various other things that we have to access. I mean, we have to set. Okay, because right now we have only enabled the dashboard. Now, if you want to access the dashboard, you have to first of all create a service account. Okay, the instructions are here. Okay, you have to first of all create a service account for your dashboard. Then you have to say that, okay, you are going to be the admin user of this particular service account, and you have to enable that functionality here. You should say dashboard admin privileges, and you should do the cluster binding. Okay, the cluster role binding is what you have to do. And after that, to join to that or to get access to that particular dashboard, we have to basically give a key. Okay, it's like a password. So we have to generate that token first, and then we can access the dashboard. So again, for the dashboard, there are these 3 commands. Well, you can get confused down the line, but remember, this is separate from the above. Okay, so what we did initially is ran these 3 commands which Kubernetes told us to execute. And after that, the next necessity was bring up a pod. So this was that command for the pod, and then this was the command for getting the dashboard up. And right after that, run the proxy, and then on that particular port number, it'll start being served. So my dashboard is being served, but I'm not getting the UI here. And if I want to get the UI, I have to create the service account and do these 3 things, right? So let's start with this and then continue. I hope this wasn't confusing, guys. Okay, I can't do it here. So let me open a new terminal. Okay, here I'm going to paste it. And yes, service account created. Let me go back here and execute this command where I'm doing the role binding. I'm saying that my dashboard should have admin functionalities, and that's going to be the cluster role. Okay, cluster admin. And then the service account is what I'm using, and it's going to be in default namespace. Okay, so when I created the account, I said that I want to create this particular account in default namespace. So the same thing I'm specifying here. Okay, dashboard admin created. Good. So let's generate the token that is needed to access my dashboard. Okay, before I execute this command, let me show you that once. So if you go to this URL, right, /API/v1/namespaces. Yep, let me show it you here. Okay, so this is the particular URL where you will get access to the dashboard. Okay, login access to the dashboard, localhost 8001 API v1 namespaces /kubesystem/services/https Kubernetes dashboard :/proxy. Okay, remember this one. That is the same thing over here. And like I told you, it's asking me for my password. So I would say token, but let me go here and hit the command and generate the token. So this is the token. I'm going to copy this from here till here. I'm going to say copy, and this is what I have to paste over here. All right, so sign and update. Yes, perfect. So this is my dashboard, right? This is my Kubernetes dashboard, and this is how it looks like. Whatever I want, I can get an overview of everything. So there is workloads. If I come down, there is deployments. I have option to see the pods, and then I can see what are the different services running among most of the other functionalities. Okay, so right now we don't have any bar graph or pie graph showing you which cluster is up, which pod is up and all, because I have not added any node and there is no service that is running, right? So I mean, this is the outlay of the dashboard. Okay, you will get access to everything you want from the left. You can drill down into each of these namespaces or pods or containers, right? Now, if you want to deploy something through the dashboard, right, through the click functionality, then you can go here. Okay, But before I create any container or before I create any pod or any deployment for that matter of fact, I have to have nodes because these will be running only on nodes, correct? Whatever I deploy, they run only on nodes. So let me first open up my node and get the node to join this particular cluster of mine. Now, if you remember, the command to join the node got generated at the master end, correct? So let me go and fetch that again. So that was the first command that we ran, right? This one. So let's just copy this and paste this one at my node end. This is the IP of my master, and it will just join at this particular port number. Let me hit enter. Let's see what happens. Okay, let me run it as root user. Okay, perfect. Successfully established connection with the API server, and it says this node has joined the cluster, right? Bingo. So this is good news to me. Now if I go back to my master, and in fact if I open up the dashboard, there would be an option of nodes, right? So initially now it's showing this master. Master is the only thing that is part of my nodes. Let me just refresh it, and you would see that even node-1 would be a part of it, right? So there are two resources, two instances. One is the master itself and the other is the node. Now if I go to overview, you will get more details. If I start my application, if I start my servers or containers, then all those would start showing up here, right? So it's high time I start showing you how to deploy it. To deploy it using the dashboard, I told you this is the functionality. So let's go ahead and click on this create. And yeah, mind you, from the dashboard is the easiest way to deploy your application, right? So even developers around the world do the same thing. For the first time, probably they create it using the YAML file, and then from there on, they start editing the YAML file on top of the dashboard itself, or they create or deploy the application from here itself. So we'll do the same thing. Go to create an app using functionality, click functionality, you can do it over here. So let's give a name to your application. I'll just say Edureka demo. Okay, let that be the name of my application. And I want to basically pull an Nginx image. Okay, I want to launch an Nginx service. So I'm going to specify the image name in my Docker hub. Okay, so it says either the URL of a public image or any registry, or a private image hosted on Docker hub or Google Container Registry. So I don't have to specify the URL per se, but if you're specifying a Docker hub, if you're specifying this image to be pulled from Docker hub, then you can just use the name of the image which has to be pulled. That's good enough, right? Nginx is the name, and that's good enough. And I can choose to set my number of pods to 1 or 2. In that way, I will have 2 containers running in the pod, right? So this is done. And the final part is actually, without the final part, I can straight away deploy it. Okay, but if I deploy it, then my application would be created, but I would just not get the UI. I mean, I won't see the Nginx service. So that I get the service, I have to enable one more functionality here. Okay, the servers here, click on the drop down and you will have external option, right? So click on external. This would let you access this particular service from your host machine, right? So that is the definition. So you can see the explanation here. An internal or external service can be defined to map an incoming port to a target port seen by the container. So Nginx, which would be hosted on one of the container ports that could not be accessible if I don't specify anything here. But now that I've said access it externally on a particular port number, then it would get mapped for me. By default, Nginx runs on port number 80. So the target port would be the same, but the port I want to expose it to, that I can map it to anything I want. So I'm going to say 82. All right. So that's it. It's as simple as this. This way your application is launched with 2 pods. So I can just go down and click on deploy, and this way my application should be deployed. My deployment is successful. There are 2 pods running. So what I can do is I can go to the service and try to access the UI, right? So it says that it's running on this particular port number 82153. So copy this and say localhost 32153. Okay, hit enter. Bingo. So it says welcome to Jenkins, and I'm getting the UI, right? So I'm able to access my application which I just launched through the dashboard. It was as simple as that. So this is one way of launching or making a deployment. There are 2 other ways, like I told you. One is using your CLI itself, your command line interface of your Linux machine, which is the terminal, or you can do it by uploading the YAML file. You can do it by uploading the YAML file because everything here is in the form of YAML or JSON. Okay, that's like the default way. So whatever deployment I made, right, that also, those configurations are stored in the form of YAML. So if I click on view or edit YAML, all the configurations I specified, the default ones have been taken. So I said the name should be Edureka demo. That is what has been taken over here. That is the name of my deployment. Okay, so kind is deployment. The version of my API, it's this one, extension slash v1 beta 1. And then under metadata, I have various other lists. So if you know how to write a YAML file, then I think it will be a little more easier for you to understand and create your deployment, because YAML file is everything about lists and maps. And these YAML files are always lists about maps and maps about lists. So it might be a little confusing. So probably we'll have another tutorial video on how to write a YAML file for Kubernetes deployment, but I would keep that for another session. Okay, let me get back to this session and show you the next deployment. Okay, the next deployment technique. So let me just close this and go back to overview. Okay, so I have this one deployment. Very good. Okay, so let's go to this. Yeah, so what I'll do is let me delete this deployment. Okay, or let me at least scale it down, because I don't want too many resources to be used on my node also, because I will have to show 2 more deployments, right? So I have reduced my deployment over here, and I think it should be good enough. Great. So let's go back to the kube setup, this document of mine. So this is where we were, right? We could check our deployments, we could do all these things. So one thing which I might have forgotten is showing the nodes which are part of the cluster, right? So this is my master. Yeah, so I kind of forgot to show you this kubectl get node. So the same view that you got on your dashboard, you get it here also. I mean, these are the 2 nodes, and this is the name and all these things. Okay, and I can also do the kubectl get pods, which would tell me all the pods that are running. Edureka demo is the pod which I have started. Okay, this is my pod. Now if I specify with the other flags, right, with all namespaces and with wide, then all the default pods which get created along with your Kubernetes cluster, those will also get displayed. Let me show you that also, just in case. Okay, yeah, so this is the one which I created, and the other ones are the default deployments that come with Kubernetes. The moment you install set up the cluster, these get started. Okay, and if you can see here, this particular Edureka demo which I started is running on my node 1 along with this kube proxy and this particular Calico node. So these 2 services are running on master and node, and this one is running only on my node 1, right? You can see this, right? The Calico node runs both on my node over here and on my master, and similarly the kube proxy runs on my node here and on my master. So this is the one that's running only on my node. Okay, so getting back to what I was about to explain you, the next part is how to deploy anything through your terminal. Now to deploy your same Nginx application through your CLI, we can follow these set of commands. Okay, so there are a couple of steps here. First of all, to create a deployment, you have to run this command. Okay, kubectl create deployment Nginx, and then the name of the image that you want to create. This is going to be the name of your deployment, and this is the name of the image which you want to use. So Control C, and let me go to the terminal here. On my master, I'm executing this command, kubectl create deployment. Okay, so the deployment Nginx is created. If you want, we can verify that also over here. So under deployments, right now we have 1 entry, Edureka demo, and yes, now you can see there are 2, Nginx and Edureka demo. So this is pending. I mean, it would take a few seconds. So in the meanwhile, let's just continue with the other steps. Once you have created your deployments, you have to create the service. Okay, you have to say which is the node port which can be used to access that particular service, right? Because deployment is just a deployment. You're just deploying your container. If you want to access it, like I told you earlier, from your from your host machine or all those things, then you have to enable the node port. If you want to get your deployments on your terminal, you can run this command, kubectl get deployments. Okay, Nginx also comes up over here, right? If you want more details about your deployment, you can use this command, kubectl describe. You'll get like more details about this particular deployment as to what is the name, what is the port number it's residing on, and all these things. Okay, let's not complicate this. You can probably use that for your understanding later. So once that is done, the next thing that you have to do is you have to create the service on the nodes. You have created the deployment, but yes, create the service on the nodes using this particular command, kubectl create service, and say node port. Okay, this means you want to access it at this particular port number. You're doing the port mapping 80 is to 80. Okay, container port 80 to the internal node port 80. Okay, so service for Nginx is created. And if you want to check which of the deployments are running in which nodes, you can run the command kubectl get svc. Okay, this would tell you, okay, you have two different services, Edureka demo and Nginx, and they are running on these port numbers and on these nodes, right? So Kubernetes is the one which got created automatically. Edureka demo is the one which I created. Okay, Nginx is again the one which I created. Kubernetes comes up on its own. I'm just specifying to you because this is a container for the cluster itself. Okay, so let's just go back here, and then yes, and similarly, if you want to delete a deployment, then you can just use this command kubectl delete deployment followed by the name of the deployment, right? It's pretty simple. You can do it this way. Otherwise, from the dashboard also you can delete it, like how I showed you earlier. Click over here and then you can click on delete, and then if you want to scale it, you can scale it. So both of these deployments of mine have one pod each, right? So let's do one thing. So let's just go to the Nginx service, and here let's try accessing this particular service. Localhost. Okay, perfect. Here also it says welcome to Nginx, right? So with this you can understand that the port mapping worked, and by going to service you will get to know on which port number you can access it on your host machine, right? So this is the internal container port mapped to this particular port of mine. Okay, now if not for this, if this doesn't work, you can also use the cluster IP for the same thing. Cluster IP is going to basically the IP using which all your containers access each other, right? So for your pod you will have an IP, so whatever is running in your containers, that will again be accessible on your cluster IP. So it's the same thing, right? So let me just close these pages, and that's how you deploy an application through your CLI. So this comes to our last part of this video, which is nothing but deployment via YAML file. So for again deployment via YAML file, you have to write your YAML code, right? You have to either write your YAML code or your JSON code, correct? So this is the code which I have written, which is in YAML format, and in fact I already have it in my machine here. So how about I just do an ls? Yeah, there is deployment.yaml, right? So let me show you that. So this is my YAML file. Okay, so here I specify various configurations similar to how I did it using the GUI or I did it using the CLI. It's something similar. It's just that I specify everything in one particular file. Here, if you can see that I've specified the API version. Okay, so I'm using extensions dot slash b1 or beta 1. Okay, I can do this, or I can just simply specify version 1. I can do either of those. And then the next important line is the kind. So kind is important because you have to specify what kind of file it is. Is it a deployment file, or is it for a pod deployment, or is it for your container deployment, or is it the overall deployment? What is it? So I've said deployment, okay, because I want to deploy the containers also along with the pod. So I'm saying deployment. In case you want to deploy only the pod, which you realistically don't need to, okay, why would you just deploy a pod? But in case if you want to deploy a pod, then you can go ahead and write pod here and then just specify what are the different containers. Okay, but in my case it's a complete deployment, right, with the pods and the services and the containers. So I will go ahead and write other things. And under the metadata, I will specify the name of my application. I can specify what I want. I can put my name also over here, like Vardhan. Okay, and I can save this. And then the important part is this spec part. So here is where you set the number of replicas. Do you remember I told you that there's something called as replication controller, which controls the number of pods that you will be running? So it is that line. So if I've set 2 over here, it means that I will have 2 pods running of this particular application of Vardhan. Okay, what exactly am I doing here? Under spec, I'm saying that I want 2 containers. So I've intended a container line over here, and then I have 2 containers inside. So the first container which I want to create is of the name front end. Okay, and I'm using an Nginx image. And similarly, the port number that this would be active on is container port 80. All right, and then I'm saying that I want a second container, and the container for this I could rename this to anything. I can say backend, and I can choose which image I want. I can probably choose a HTTPD image also. Okay, and I can again say the ports that this will be running on. I can say the container port that it should run on is port number is 88, right? So that's how simple it is. All right, and since it's your first video tutorial, the important takeaways from this YAML file configuration is that under spec you'll have to specify the containers and yes, everything in JSON format with all the indentations and all these things. Okay, Even if you have an extra space anywhere over here, then your YAML file would throw an invalid error. So make sure that is not there. Make sure you specify the containers appropriately. If it's going to be just one container, well and good. If it's two containers, make sure you indent it in the right way, and then you can specify the number of pods you want to give a name to your deployment, and mainly establish these rules. Okay, so once you're done with this, just save it and close this YAML file. Okay, so this is your deployment.yaml. Now you can straight away upload this YAML file to your Kubernetes. Okay, and that way your application would be straight away deployed. Okay, now the command for that is kubectl create -f and the name of the file. Okay, so let me copy this, and then the name of my file is deployment.yaml. So let me hit enter. Perfect. So my deployment, the third deployment, Vardhan, is also created, right? So we can check our deployments from the earlier command, that is nothing but kubectl get deployments. Okay, it's not get deployment.yaml, sorry, it's get deployments. And as you can see here, there is an Edureka demo, there is Nginx, and there is Vardhan. And the funny thing which you should have noticed is that I said I want two replicas, right? Two pods. So that's why the desired is two. Currently we have two, up to date is one. So okay, up to date is two. Brilliant. Available is 0 because let's just give it a few seconds. In 23 seconds, I don't think the pod would have started. So let's go back to our dashboard and verify if there's a third deployment that comes up over here. Okay, perfect. So that's how it's going to work. Okay, so probably it's going to take some more time because the container is just restarting. So let's just give it some more time. This could well be because of the fact that my node has very less resource, right? So I have too many deployments. That could be the very reason. So what I can do is I could go ahead and delete other deployments so that my node can handle these many containers and pods, right? So let me delete this particular deployment, Nginx deployment. And let me also delete this Edureka demo deployment of mine. Okay, now let's refresh and just wait for this to happen. Okay, so what I can do instead is I could have a very simple deployment, right? So let me go back to my terminal and let me delete my deployment. Okay, and let me redeploy it again. So kubectl delete deployment. Okay, so Vardhan, this deployment has been deleted. Okay, so let's just clear the screen and let's do gedit of the YAML file again. And here let's make things simpler. Let me just delete this container from here. Let me save this. All right, and close this. Now let me create a deployment with this. Okay, so Vardhan is created. Let me go up here and refresh. Let's see what happens. Okay, so this time it's all green because it's all healthy. My nodes are successful, or at least it's going to be successful. Container creating. Perfect. So two pods of mine are up and running, and both my pods are running, right? And both are running on node 1. Pods 2 out of 2. Those are the two deployments, and replica set, and then services, right? So it's Nginx, which is the base image which is being used. So well and good. This is also working. So guys, yeah, that's about it, right? So when I tried to upload it, maybe there was some other error, probably in the YAML file. There could have been some small mistake, or it could have been because my node had too many containers running. Those could have been the reasons. But anyways, this is how you deploy it through your YAML file. All right, so that kind of brings us to the end of this session, where I've showed you a demonstration of deploying your containers in 3 different ways: CLI, dashboard, and your YAML files.
Hey everyone, this is Reshma from Edureka, and today we'll be learning what is Ansible. First, let us look at the topics that we'll be learning today. Well, it's quite a long list. It means we'll be learning a lot of things today. So let us take a look at them one by one. So first, we'll see the problems that were before configuration management and how configuration management helped to solve it. We'll see what Ansible is and the different features of Ansible. After that, we'll see how NASA has implemented Ansible to solve all their problems. After that, we'll see how we can use Ansible for orchestration, provisioning, configuration management, application deployment, and security. And in the end, we'll write some Ansible playbooks to install LAMP stack on my node machine and host a website in my node machine. Now, before I tell you about the problems, let us first understand what configuration management actually is. Well, configuration management is actually the management of your software on top of your hardware. What it does is that it maintains the consistency of your product based on its requirements, its design, and its physical and functional attributes. Now, how does it maintain the consistency? It is because the configuration management is applied over the entire life cycle of your system, and hence it provides you with very good visibility and control. When I say visibility, it means that you can continuously check and monitor the performances of all your systems. So if at any time the performance of any of your system is degrading, the configuration management system will notify you, and hence you can prevent errors before it actually occurs. And by control, I mean that you have the power to change anything. So if any of your servers failed, you can reconfigure it again to repair it so that it is up and running again, or you can even replace the server if needed. And also the configuration management system holds the entire historical data of your infrastructure. It documents all the snapshots of every version of your infrastructure. So overall, the configuration management process facilitates the orderly management of your system information and system changes so that you can use it for beneficial purposes. So let us proceed to the next topic and see the problems before configuration management and how configuration management solved it. And with that, you will understand more about configuration management as well. So let's see now, why do we need configuration management? Now, the necessities behind configuration management was dependent upon a certain number of factors and certain number of reasons. So let us take a look at them one by one. So the first problem was managing multiple servers. Now, earlier every system was managed by hand, and by that I mean that you have to log into them via SSH, make changes, and then log off again. Now imagine if a system administrator would have to make changes in multiple number of servers. You'll have to do this task of logging in, making changes, and logging off again and again repeatedly. So this would take up a lot of time, and there is no time left for the system administrators to monitor the performances of the system continuously. So if at any time any of the servers would fail, it took a lot of time to even detect the faulty server and took even more time to repair it, because the configuration scripts that they wrote was very complex and it was very hard to make changes onto them. So after configuration management system came into the picture, what it did is that it divided all the systems in my infrastructure according to their dedicated tasks, their design or architecture, and they organized my system in an efficient way. Like I've grouped my web servers together, my database servers together, application servers together. And this process is known as baselining. Now let's, for an example, say that I wanted to install LambStack in my system. And LambStack is a software bundle where L stands for Linux, A for Apache, M for MySQL, and P for PHP. So I need these different softwares for different purposes, like I need Apache server to host my web pages, I need PHP for my web development, I need Linux as my operating system, and MySQL as my data definition language or data manipulation language. Since now all the systems in my infrastructure is baseline, I would know exactly where to install each of the softwares. For example, I'll use Apache as my web server here. For database, I will install the MySQL here. And also it became easy for me to monitor my entire system. For example, if my web pages are not running, I would know that there is something wrong with my web servers. So I'll go check in here. I don't have to check the database servers and application servers for that. Similarly, if I'm not able to insert data or extract data from my database, I would know that something is wrong with my database servers. I don't need to check these two for that matter. So what configuration management system did with baselining is that it organized my system in an efficient way so that I can manage and monitor all my servers efficiently. Now let us see the second problem that we had, which was scaling up and scaling down. See, nowadays you can come up with requirements at any time, and you might have to scale up or scale down your systems on the fly. And this is something that you cannot always plan ahead. And scaling up your infrastructure doesn't always mean that you just buy new hardware and just place them anywhere haphazardly. You cannot do that. You also need to provision and configure these new machines properly. So with configuration management system, I've already got my infrastructure baselined. So I know exactly how these new machines are going to work according to their dedicated task and where should I actually place them. And the scripts that configuration management uses are reusable. So you can use the same scripts that you use to configure your older machines to configure your new machines as well. So let me explain it to you with an example. Let's say that if you're working in an e-commerce website and you decide to hold a mega sale, a New Year, Christmas sale or anything. So it's obvious that there is going to be a huge rise in the traffic. So you might need more web servers to handle that amount of requests, and you might even need a load balancers or maybe two to distribute that amount of traffic onto your web servers. And these changes, however, need to be made at a very short span of time. So after you've got the necessary hardware, you also need to provision them accordingly. And with configuration management, you can easily provision these new machines using either recipes or playbooks or any kind of script that configuration management uses. And also after the sale is over, you don't need that many web servers or a load balancer, so you can disable them using the same easy scripts as well. And also scaling down is very important when you are using cloud services. When you do not need any of those machines, it's no point in keeping them. So you have to scale down as well because you have to reconfigure your entire infrastructure as well. And with configuration management, it is a very easy thing to auto scale up and scale down your infrastructure. So I think you all have understood this problem and how configuration management solved it. So let us take a look at the third problem. The third problem was the work velocity of the developers were affected because the system administrators were taking time to configure the servers. After the developers have written a code, the next job is to deploy them on different servers like test servers and production servers for testing it out and releasing it. But then again, every server was managed by hand before, so the system administrators would again have to do the same thing, log into each server, configure them properly by making changes, and do the same thing again to all servers. So this was taking a lot of time. Now before DevOps came into the picture, there was already agility in the developers' end, for which they were able to release new softwares very frequently. But it was taking a lot of time for the system administrators to configure the servers for testing. So the developers would have to wait for all the test results, and this highly hampered the work velocity of the developers. But after there was configuration management, the system administrator had got access to a configuration management tool which allowed them to configure all the servers at one go. All they had to do is write down all the configurations and write down the list of all the softwares that they need to provision the servers and deploy it on all of the servers at one go. So now agility even came into the system administrators' end as well. So after configuration management, the developers and the system administrators were finally able to work in the same pace. Now this is how configuration management solved the third problem. Now let us take a look at the last problem. Now the last problem was rolling back. In today's scenario, everyone wants a change, and you need to keep making changes frequently because customers will start losing interest if things stay the same. So you need to keep releasing new features to upgrade your application. Even giants like Amazon and Facebook, they do it now and then, and still they're unsure if the users are going to like it or not. Now imagine if the users did not like it. They would have to roll back to the previous version again. So let's see how it creates a problem. Now before there was configuration management, let's say you've got the old version, which is the version 1. When you're upgrading it, you're changing all the configurations in the production server. You're deleting the old configurations completely and deploying the new version. Now, if the users did not like it, you would have to reconfigure this server again with the old configurations, and that will take up a lot of time. So your application is going to be down for that amount of time that you need for reconfiguring this server. And this might create a problem. But when you're using configuration management system, as you know that it documents every version of your infrastructure, when you're upgrading it with configuration management, it will remove the configurations of the older version, but it will be well documented. It will be kept there. And then the newer version is deployed. Now, if the users did not like it this time, the older configuration version was already documented. So all you have to do is just switch back to the old version. And this won't take up any time, and you can upgrade or roll back your application in zero downtime. Zero downtime means that your application would be down for zero time. It means that the users will not notice that your application went down, and you can achieve it seamlessly. And this is how configuration management system solved all the problems that was before. So guys, I hope that you've all understood how configuration management did that. So let us now move on to the next topic. Now the question is, how do I incorporate configuration management in my system? Well, you do that using configuration management tools. So let us take a look at all the available configuration management tools. So here I've got the 4 most popular tools that is available in the market right now. I've got Ansible and SaltStack, which are a push-based configuration management tool. By push-based, I mean that you can directly push all those configurations onto your node machines directly. While Chef and Puppet are both pull-based configuration management tools, it means that they rely on a central server for configurations. They pull all the configurations from a central server. There are other configuration management tools available in the market too, but these 4 are the most popular ones. So now let's know more about Ansible. Now Ansible is a configuration management tool that can be used for provisioning, orchestration, application deployment, automation, and it's a push-based configuration management tool like I told you. What it does is that it automates your entire IT infrastructure and gives you large productivity gains. And it can automate pretty much anything. It can automate your cloud, your networks, your servers, and all your IT processes. So let us move on to the next topic. So now let us see the features of Ansible. The first feature is that it's very simple. It's simple to install and set up, and it's very easy to learn because Ansible playbooks are written in a very simple data serialization language which is known as YAML, and it's pretty much like English, so anyone can understand that, and it's very easy to learn. The next feature because of which Ansible is preferred over other configuration management tools is because it's agentless. It means that you do not need any kind of agents or any kind of client softwares to manage your node machines. All you have to do is install Ansible in your control machine and just make an SSH connection with your nodes and start pushing configurations right away. The next feature is that it's very powerful. Even though you call Ansible simple and it does not require any agent, it has the capabilities to model very complex IT workflows. And it comes with a very interesting feature which is called the batteries included. It means that you've got everything that you already need. And in Ansible, it's because it comes with more than 750 inbuilt modules, which you can use them for any purpose in your project. And it's very efficient because all the modules that Ansible comes with, they are extensible. It means that you can customize them according to your needs. And for doing that, you do not need to use the same programming language that it was originally written in. You can choose any kind of programming language that you're comfortable with and then customize those modules for your own use. So this is the power and liberty that Ansible gives you. Now let us take a look at the case study of NASA. What were the problems that NASA was facing and how Ansible solved all those problems? Now, NASA is an organization that has been sending men to the moon. They are carrying out missions in Mars, and they're launching satellites now and then to monitor the Earth. And not just the Earth, they are even monitoring other galaxies and other planets as well. So you can imagine the kind and the amount of data that NASA might be dealing with. But all the applications were in a traditional hardware-based data center, and they wanted to move into a cloud-based environment because they wanted better agility and they wanted better adaptive planning for that. And also they wanted to save costs because a lot of money was spent on just the maintenance of the hardware. And also they wanted more security because NASA is a government organization of the United States of America, and obviously they wanted more security because NASA is a government organization of the United States of America, and they hold a lot of confidential details as well for the government. So they just cannot always rely on the hardware to store all these confidential files. They needed more security because if at any time the hardware fails, they cannot afford to lose that data. And that is why they wanted to move all their 65 applications from a hardware environment to a cloud-based environment. Now let us take a look what was the problem. Now for this migration of all the data into a cloud environment, they contacted a company called Infozen. Now Infozen is a company who is a cloud broker and integrator who implements solutions to meet needs with security. So Infozen was responsible for making this transition. And NASA wanted to make this transition in a very short span of time. So all the applications were migrated as it is into the cloud environment. And because of this, all the AWS accounts and all the virtual private clouds that was previously defined, they all got accumulated in a single data space, and this made up a huge chunk of data. And NASA had no way of centrally managing it. And even simple tasks like giving a particular system administrator access rights to a particular account, this became a very tedious job. Well, NASA wanted to automate end-to-end deployment of all their apps, and for that they needed a management system. So this was the situation when NASA moved into the cloud. So you can see that all those AWS accounts and virtual private clouds, they got accumulated and made a huge chunk of data, and everyone was accessing directly to it. So there was a problem in managing the credentials for all the users and the different teams. What NASA needed was divide up all their inventories, all their resources into groups and number of hosts, and also they wanted to divide up all the users into different teams and give each team different credentials and permissions. And also if you look in the more granular level, each user in each team could also have different credentials and permissions. Let's say that you want to give the team leader of a particular team access to some kind of data while you don't want the other users in the team to access that data. So also NASA wanted to define different credentials for each individual member as well. They wanted to divide up all the data according to the projects and jobs also. NASA wanted to move from chaos into a more organized manner. And for that, they adopted Ansible Tower. Now, Ansible Tower is Ansible in a more enterprise level. Ansible Tower provides you with a dashboard which provides all the status summary of all the host and job. Now, Ansible Tower is a web-based interface for managing your organization. It provides you with a very easy to use user interface for managing quick deployments and monitoring all the configurations. So let's see what Ansible Tower did. It has the credential management system which could give different access permission to each individual user and teams. And also it divided up the user into teams and single individual users as well. And it has a job assignment system, and you can also assign jobs using Ansible Tower. You suppose, let's say that you have assigned job 1 to a single user, job 2 another single user, while job 3 could be assigned to a particular team. Similarly, the whole inventory was also managed. All the servers, let's say, dedicated to a particular mission was grouped together, all the host machines and other systems as well. So Ansible Tower helped NASA to organize everything. Now let us take a look at the dashboard that Ansible Tower provides us. So this is the screenshot of the dashboard at a very initial level. You can see right now there are 0 hosts, nothing is there, but I'm just showing you what Ansible Tower provides you. So on the top you can check all the users and teams. You can manage the credentials from here. You can check your different projects and inventories. You can make job templates and schedule jobs as well. So this is where you can schedule jobs and provide every job with a particular ID so that you can track it. You can check your job status here, whether your job was successful or failed. And since Ansible Tower is a configuration management system, it will hold the historical data as well, so you can check the job statuses of the past month or the month before that. You can check the host status as well. You can check how many hosts are up and running. You can see the host count here. So this dashboard of Ansible Tower provides you with so much ease of monitoring all your systems. So it's very easy to use Ansible Tower dashboard. Anyone in your company, anyone can use it because it's very user-friendly. Now let us see the results that NASA achieved after it has used Ansible Tower. Now updating nasa.gov used to take 1 hour of time, and after using Ansible it got down to just 5 minutes. Security patching updates were a multi-day process, and now it requires only 45 minutes. The provisioning of OS accounts can be done in just 10 minutes. Earlier, the application stack-up time required 1 to 2 hours, and now it's done in only 10 minutes. It also achieved near real-time RAM and disk monitoring and baselining all the standard Amazon machine images. This used to be a 1-hour manual process, and now you don't even need manual interference for that. It became a background invisible process. So you can see that how Ansible has drastically changed the overall management system of NASA. So guys, I hope that you've understood how Ansible helped NASA. If you have any question, you may ask me at any time on the chat window. So let us proceed to the next topic. Now this was all about how others have used Ansible. So now let us take a look at the Ansible architecture so that we can understand more about Ansible and decide how we can use Ansible. So this is the overall Ansible architecture. I've got the Ansible automation engine, and I've got the inventory and a playbook inside the automation engine. I've got the configuration management database here and host. And this configuration management database is a repository that acts as a data warehouse for all your IT installations. It holds all the data relating to the collection of your all IT assets. And these are commonly known as configuration items. And it also holds the data which describe the relationships between such assets. So this is a repository for all your configuration management data. And here I've got the Ansible automation engine. I've got the inventory here, and inventory is nothing but the list of all the IP addresses of all my host machines. Now, as I told you how to use configuration management, you use it with the configuration management tool like Ansible. But how do you use Ansible? Well, you do that using playbooks. And playbooks describe the entire workflow of your system. Inside playbooks, I've got modules, APIs, and plugins. Now modules are the core files. Now playbooks contain a set of plays, which are a set of tasks. And inside every task, there is a particular module. So when you run a playbook, it's the modules that actually get executed on all your node machines. So modules are the core files. And like I told you before, Ansible already comes with inbuilt modules which you can use, and you can also customize them as well. It comes with different cloud modules, database modules, and don't worry, I'll be showing you how to use those modules in Ansible. And there are different APIs as well. Well, APIs in Ansible are not meant for direct consumption. They're just there to support the command line tools. For example, they have the Python API, and these APIs can also be used as a transport for cloud services, whether it's public or private, you can use it. Then I've got plugins. Now plugins are a special kind of module that allow to execute Ansible tasks as a job build step. And plugins are pieces of code that augment the Ansible's core functionality. And Ansible also comes with a number of handy plugins that you can use. For example, you have action plugins, cache plugins, callback plugins. And also you can create plugins of your own as well. Now let me tell you how exactly different it is from a module. Let me give you the example of action plugin. Now action plugin are front-end modules, and what it does is that when you start running a playbook, something needs to be done on the control machine as well. So these action plugins trigger those action and execute those tasks in the controller machine before calling the actual modules that are getting executed in the playbook. And also you have a special kind of plugin called the connection plugin, which allows you to connect to the Docker containers in your node machine and many more. And finally, I have this host machine that is connected via SSH, and these host machines could be either Windows or Linux or any kind of machines. And also let me tell you that it's not always needed to use SSH for connection. You can use any kind of network authentication protocol. You can use Kerberos, and also you can use the connection plugins as well. So this is fairly a very simple Ansible architecture. So now that you've understood the architecture, let us write a playbook now. Now let me tell you how to write a playbook. And playbooks in Ansible are simple files written in YAML code. And YAML is a data serialization language. You can think of data serialization language as a translator for breaking down all your data structure and serialize them in a particular order, which can be reconstructed again for later use. And you can use this reconstructed data structure in the same environment or even in a different environment. So this is the control machine where Ansible will be installed, and this is where you'll be writing your playbooks. So let me show you the structure of how to write a playbook. Now every playbook starts with 3 dashes on the top. So first you have to mention the list of all your host machines here. It means where do you want this playbook to run. Then you can mention variables by gathering facts. Then you can mention the different tasks that you want. Now remember that the tasks get executed in the same order that you write them. For example, if you want to install software A first and then software B later on, so make sure that the first task would be install software A and the next task would be install software B. And then I've got handlers at the bottom. The handlers are also tasks, but the difference is in order to execute handlers, you need some sort of triggers in the list of tasks. For example, we use notify. I'll show you an example now. Okay, let me show you an example of playbook so that you can relate to this structure. So this is an example of an Ansible playbook to install Apache. Like I told you, it starts with 3 dashes on the top. And remember that every list starts with a dash in the front or a hyphen. Here I've only mentioned just the name of one group. You can mention the name of several groups where you want to run your playbook. Then I've got the tasks. You give a name for the task, which is install Apache, and then you use a module. Here I'm using the apt module to download the package. So this is the syntax of writing the apt module. So you give the name of the package, which is Apache 2. Update cache is equal to yes. So it means that it will make sure that apt-get is already updated in your node machine before it installs the Apache 2. And you mention state equal to latest. It means that it will download the latest version of Apache 2. And this is the trigger because I'm using handlers here, right? And the handler here is to restart Apache, and I'm using the service module here. And the name of the software that I want to restart is Apache 2, and state is equal to restart it. So in Notify, I've mentioned that there is going to be a handler whose job would be to restart Apache 2. And then the task in the handler would get executed and it will restart Apache 2. So this is a simple playbook, and we'll also be writing similar kind of playbooks later on the hands-on part. So you'll be learning again. So if it's looking a little gibberish for you, we'll be doing that on the hands-on part, so then it'll clear all your doubts. So now let us see how to use Ansible and understand its applications. So we can use Ansible for application deployment, configuration management, security and compliance, provisioning, and orchestration. So let us take a look at them one by one. First, let us see how we can use Ansible for orchestration. Well, orchestration means, let's say that we have defined configurations for each of my systems, but I also need to make sure how these configurations will interact with each other. So this is the process of orchestration where I decide that how the different configurations on different of my systems and my infrastructure would interact with each other in order to maintain a seamless flow of my application. And your application deployments need to be orchestrated, because you've got a front end and back end services, you've got databases, you've got monitoring, networks, and storage, and each of them has their own role to play with their configuration and deployment. And you cannot just run all of them at once and expect that the right thing happens. So what you need is that you need an orchestration tool that all these tasks happen in the proper order, that the database is up before the backend server and the front-end server is removed from the load balancer before it gets upgraded, and that your networks would have their proper VLANs configured. So this is what Ansible helps you to do. So let me give you a simple example so that you can understand it better. Let's say that I want to host a website on my node machines, and this is precisely what we're going to do later on the hands-on part. So first, and in order to do that, first I have to install the necessary software, which is the LAMP stack. And after that, I have to deploy all the HTML and PHP files on the web server. And after that, I'll be gathering some kind of information from my web pages that will go inside my database server. Now, if you want to perform these all tasks, you have to make sure that the necessary softwares are installed first. Now, I cannot deploy the HTML and PHP files on the web servers if I don't have a web servers, if Apache is not installed. So this is orchestration, where you mention that the task that needs to be carried out before and the task that needs to be carried out later. So this is what Ansible playbooks allow you to do. Now let's see what provisioning is. Like provisioning in English means to provide with something that is needed. It is same in case of Ansible. It means that Ansible will make sure that all the necessary softwares that you need for your application to run is properly installed in each of the environments of your infrastructure. So let us take a look at this example here to understand what provisioning actually is. Now if I want to provision a Python web application that I'm hosting on Microsoft Azure, And Microsoft Azure is very similar to AWS, and it is also a cloud platform on which you can build up all your applications. So let's say, now if I want to host so if I'm developing a Python web application, for coding I would need the Microsoft Azure document database, I would need Visual Studio, would need to install Python also, and some kind of software development kit and different APIs for that. So Ansible, so you can list out the name of all the software development kits and all these necessary softwares that you will require for coding this web, that you would require in order to develop your web application. So you can list out all the necessary softwares that you'd be needing in an Ansible playbook in order to develop your web application. And for testing your code out, you will again need Microsoft Azure document database, you would again need Visual Studio and some kind of testing software. So again, you can list out all the softwares in the Ansible playbook and it will provision your testing environment as well. And it's the same thing while you're deploying it on the production server as well. Ansible will provision your entire application at all stages, at coding stage, at testing, and at the production stage also. So guys, I hope you've understood what provisioning is. Let us move on to the next topic and see how we can achieve configuration management with Ansible. Now, Ansible configurations are simple data descriptions of your infrastructure, which is both human readable and machine parsable. And Ansible requires nothing more than an SSH key in order to start managing systems, and you can start managing them without installing any kind of agent or client software. So you can avoid the problem of managing the management, which is very common in different automation systems. For example, I've got my host machines and Apache web servers installed in each of the host machines. I've also got PHP and MySQL installed. Now if I want to make configuration changes, if I want to update Apache and update my MySQL, I can do it directly. I can push those new configuration details directly onto my host machines or my node machines and my server. And you can do it very easily using Ansible playbooks. So let us move on to the next topic and let us see how application deployment has been made easier with Ansible. Now, Ansible is the simplest way to deploy your applications. It gives you the power to deploy all your multi-tier applications very reliably and consistently. And you can do it all from a common framework. You can configure all the needed services as well as push application artifacts from one system. With Ansible, you can write playbooks, which are the description of the desired state of your system, and it is usually kept in the source control. So Ansible then does all the hard work for you to get your systems to the state, no matter what state they are currently in. And playbooks make all your installations, all your upgrades for day-to-day management very repeatable. So with Ansible, you can write playbooks, which are the descriptions of the desired state of the systems, and these are usually kept in the source control. Ansible then does all the hard work for you to get all your systems in the desired state, no matter what state they are currently in. And playbooks make all your installations, your upgrades, for all your day-to-day management in a very repeatable and reliable way. So let's say that I'm using a version control system like Git while I'm developing my app. And also I'm using Jenkins for continuous integration. Now Jenkins will extract code from Git every time there is a new commit and then make a software build. And later this build will get deployed in the test server for testing. Now if changes are kept making in the code base continuously, you would have to configure your test and the production server continuously as well according to the changes. So what Ansible does is that it continuously keeps on checking the version control system here so that it can configure the test and the production server accordingly and quickly. And hence it makes your application deployment like a piece of cake. So guys, I think you have understood the application deployment. And don't worry, in the hands-on part, we'll also be deploying our own applications on different servers as well. Now let us see how we can achieve security with Ansible. In today's complex IT environment, security is paramount. You need security for your systems, you need security for your data, and not just your data, your customers' data as well. Not only you must be able to define what it means for your systems to be secure, you also need to be able to simply apply that security. And also you need to constantly monitor your systems in order to ensure that they remain compliant with that security. And with Ansible, you can simply define security for your systems using playbooks. With playbooks, you can set up firewall rules, you can lock down different users or groups, and you can even apply custom security policies as well. Now Ansible also works with the MindPoint group, which writes Ansible roles to apply DSA-STIG. Now DSA-STIG is a cybersecurity methodology for standardizing security protocols within your network, servers, and different computers. And also it is very compliant with the existing SSH and WinRM protocols. And this is also a reason why Ansible is preferred over other configuration management tools. And it is also compatible with different security verification tools like OpenSCAP and Stigma. What tools like OpenSCAP and Stigma does is that it carries out a timely inspection of all your software inventory and check for any kind of vulnerabilities. And it allows you to take steps to prevent those attacks before they actually happen. And you can apply this security over your entire infrastructure using Ansible. So how about some hands-on with Ansible? So let us write some Ansible playbooks now. So what we're going to do is that we're going to install LambStack, and then we're going to host a website on the Apache server, and we'll also collect some data from our web page and store it in the MySQL server. So guys, let's get started. So here I'm using the Oracle VirtualBox Manager, and here I've created two virtual machines. The first is the Ansible control machine and the Ansible host machine. So Ansible control machine is the machine where I have installed Ansible, and this is where I'll be writing all my playbooks. And Ansible host 1 here is going to be my node machine. This is where the playbooks are going to get deployed. So in this machine I'll deploy my website. So I'll be hosting my website in the Ansible host 1. So let us go to my control machine and start writing the playbooks. So this is my Ansible control machine. Now let's go to the terminal first. So this is the terminal of my Ansible control machine. And now I've already installed Ansible here, and I've already made an SSH connection with my node machine. So let me here just become the root user first. Now you should know that you do not always need to become the root user in order to use Ansible. I'm just becoming the root user for my convenience because I like to get all the root privileges while I'm using Ansible. But you can sudo to any user if you like. So let me clear my screen first. Now before we start writing playbooks, let us first check the version of Ansible that is installed here. And for that I'll just use the command ansible --version. And as you can see here that I have got the Ansible 2.2.0.0 version here. Now let me show you my host inventory file. Since I've got only one node machine here, so I'm going to show you where exactly the IP address of my node machine is being stored. So I'll open the host file for you now. So I'm just going to open the file and show it to you. So I'm using the gedit editor, and the default location of your host inventory file is etc ansible/hosts. And this is your host inventory file. And now I have mentioned the IP address of my host machine here, which is 192.168.56.102. And I've named it under the group name test servers. So always write the name of your group under the square brackets. Now I just have one node machine, so there is only one IP address. If you have many node machines, you can just list down the IP address under this line. It's as simple as that. Or if you even want to group it under a different name, you can use a different name, use another square bracket and put a different name for another set of your hosts. Okay, now let me clear my screen first. So first let me just test out the SSH connection, whether it's working properly or not using Ansible. So for that I'll just type in the command ansible and ping, and then the name of the group of my host machines, which is test servers in my case. And ping changed to pong. It means that an SSH connection is already established between my control machine and my node machine. So we are all ready to write playbooks and start deploying it on the nodes. So the first thing that I need to do is write a provisioning playbook. Now since I'm going to host a website, I would first need to install the necessary softwares. So I'll be writing a provisioning playbook for that. And I'll provision my node machine using LambStack. So let us write a playbook to install LambStack on my node machine. Now I've already written that playbook, so I'm just going to show it to you. So I'm using the gedit editor again, and the name of my provisioning playbook is LambStack. And the extension for a YAML file is .yml. and this is my playbook. Now let me tell you how I have written this playbook. As I told you that every playbook starts with 3 dashes on the top, so here are the 3 dashes, and then I've given a name to this playbook, which is to install Apache, PHP, and MySQL. Now I've already got the L in my lamp because I'm using a Ubuntu machine, which is a Linux operating system. So I need to install Apache, PHP, and MySQL now. And then you have to mention the host here on which you want this playbook to get deployed. So I've mentioned test servers here, and then I want to escalate my privileges, for which I'm using become and become user. It is because sometimes you want to become another user different from what you are actually logged into the remote machine. So you can use escalating privileges tools like su or sudo to gain root privileges. And that is why I've used become and become user for that. So I'm becoming the user root. And I'm using become true here on the top. What it does is that it activates your privilege escalation, and then you become the root user on the remote machine. And then gather facts true. Now what it will do is that it will gather useful variables about the remote host. Now what exactly it will gather is some sort of files or some kind of keys which can be used later in a different playbook. And as you know that every playbook is a list of tasks that you need to perform, so this is the list of all my tasks that I'm going to perform. And since it's a provisioning playbook, which means I'm only installing the necessary softwares that will be needed in order to host a website on my node machine. So first I'm installing Apache. So I've given the task name as install Apache 2. And then I'm using the package module here. And this is the syntax of the package module. So you have to first specify the name of the package that you're going to download, which is Apache 2. And then you put state equal to present. Now since you're installing something for the first time and you want this package to be present in your node machine, so you're putting state equal to present. Now similarly, if you want to delete something, you can put state equal to absent, and it works that way. So I've installed an Apache PHP module, and I've installed PHP client, PHP encrypt, PHP GD library. I've installed a package PHP MySQL, and finally I've installed the MySQL server in the similar way that I've installed Apache 2. This is a very simple playbook to provision your node machine, and actually all the playbooks are simple. So I hope that you have understood how to write a playbook. Now let me tell you something that you should always keep in mind while you are writing playbooks. Make sure that you are always extra careful with the indentation, because YAML is a data serialization language and it differentiates between elements with different indentations. For example, I've got a name here and a name here also, but you can see that the indentations are different. It is because this is the name of my entire playbook while this is just the name of my particular task. So these two are different things and they need to have different indentations. The ones with the similar indentations are known as siblings. Like this one, this is also doing the same thing, this is also installing some kind of package, and this is also installing some kind of package. So these are similar. So that's why you should be very careful with indentation, otherwise it will create a problem for you. So what are we waiting for? Let us run this playbook. Clear my screen first. So in order to run a playbook, and the command that you should be using to run an Ansible playbook is ansible-playbook, and then the name of your file, which is lampstack.yaml. And here we go. And here it is okay because it is able to connect to my node machine. Apache 2 has been installed. And it's done. My playbook is successfully run. And how do I know that? I know that seeing these common return values. So these common return values like OK, changed, unreachable, and failed, they give me the status summary of how my playbook was run. So OK equal to 8, it means there were 8 tasks that was run OK. Changed equal to 7, it means that something in my node machine has been changed because obviously I've installed new packages into my node machine. So it's showing changed equal to 7. Unreachable is equal to 0, it means that there were 0 hosts that were unreachable. And failed equal to 0, it means that 0 tasks were failed. So my playbook was run successfully onto my node machine. So let us check my node machine and see if Apache and MySQL has been installed. So let us go to my node machine now. So this is my node machine. So let us check now if Apache server has been installed. So I'm going to my web browser. So this is my web browser in my Node machine. So let me go to the local host and check if Apache web server has been downloaded. And it's there. It works. Now this is the default web page of Apache 2 web server. So now I know for sure that Apache was installed in my Node machine. Now let us see if MySQL server has been installed. Let me go to my terminal. This is the terminal of my Node machine. Now if you want to check if MySQL is installed, just use this following command. MySQL user is root and then -p. Sudo password again for MySQL, and there it is. So MySQL server was also successfully installed in my Node machine. So let's go back to my control machine and let's do what is left to do. So we're back into our control machine. Now I've already provisioned my Node machine. So let us see what we need to do next. Now since we are deploying a website on the Node machine, let me first show you how my first web page looks like. So this is going to be my first web page, which is index.html, and I've got 2 more PHP files also. So I'll be actually deploying these files onto my Node machine. So let me just open the first web page to you. So this is going to be my first web page, and what I'm going to do is that I'm going to ask for name and email, because this is a registration page for Edureka where you have to register with your name and email, and I want this name and email to go into my database. So for that I need to create a database, and I also need to create a table for this name and email data to store into. So for that we'll write another playbook, and we'll be using database modules in that. Clear the screen first. Now again, I've already written that playbook, so let me just show it to you. So I'm using the gedit editor here again, and the name of this playbook is MySQL module. Okay, so this is my playbook. So like all playbook, it starts with 3 dashes, and here I have mentioned host all. Now I just have only one host. I know I could have mentioned either the only one IP address directly or even given the name of my group, but I've written just all here so that you can know that if you had many group names or if you have many nodes and you want this playbook to run on all of your node machines, you can use this all, and this playbook will get deployed on all your node machines. So this is another way of mentioning your hosts, and I'm using remote user root, and this is another method to escalate your privileges. It's similar to become and become user, so I want the remote user to have root privileges while this playbook would run. And then the list of the tasks. And so what I'm doing in this playbook is that since I have to connect to my MySQL server, which is present in my node machine, I need a particular software for that, which is the MySQL Python module. And I'm going to download and install it using pip. Now pip is the Python package manager with which you can install and download Python packages. But first I need to install pip in my node machine. So since I told you that the task that you write in a playbook, it gets executed in the same order that you write them. So my first task is to install pip, and then I'm using the apt module here. Here I've given the name of the package, which is Python pip and state equal to present. And after that I'm installing some other softwares using pip, and I'm installing some other related softwares as well. I'm also installing library MySQL client dev, and after that using pip I'm installing the MySQL Python module. Now notice that, so you can consider this as an orchestration playbook, because here I'm making sure that pip has to get installed first, and after pip is installed I'm using pip to install another Python package. So you see what we did here, right? And then I'm going to use the database modules for creating a new user to access the database, and then I'm creating the database named edu. So for creating a MySQL user, I have used the MySQL user database module that Ansible comes with, and this is the syntax of the MySQL user module. Here you create the name of the new user, which is Edureka. You mention the password, and the priv here, it means what privileges do you want to give it to the new user, and here I'm granting all privileges for all database. And since you're creating it for the first time and you want state to be present. Similarly, I'm using the MySQL DB module to create a database in my MySQL server named edu. So this is the very simple syntax of using MySQL DB module, where you have to just give the name of the database in DB equal to and state equal to present. So this will create a database named edu. And after that, I also need to create a table inside the database for storing my name and email details, right? And unfortunately, Ansible does not have any MySQL table creating modules. So what I did is that I've used the command module here. And with command module, I'm directly going to use MySQL queries to create a table. And the syntax is something like this. So you can write it down or remember it if you want to use it. So for that, since I'm writing a MySQL query, I'll start it with MySQL user edureka. The hyphen U is for the user. And then for password, it's edureka. And after hyphen E, just write the query that you need to execute on the MySQL server and write it in single quotations. So I've written the query to create a table, and this is create table reg, the name, the email, and then after that, just mention the name of the database on which you want to create this table, which is edu for me. So this is my orchestration playbook. Clear my screen first. The command is ansible-playbook and the name of your playbook, which is MySQL module. And here we go. So again, my common return values tell me that the playbook was run successfully because there are no failed tasks and no unreachable hosts. And there are change tasks in my node machine. So now all the packages are downloaded. Now my node machine is well provisioned. It's properly orchestrated. Now what are we waiting for? Let's deploy our application. Well, I'll clear the screen first. So now let me tell you what exactly do we need to do in order to deploy my application. And in my case, these are just 3 PHP files and HTML files that I need to deploy it on my node machine. In order to display these HTML files and PHP files on my web server in my node machine, what I need to do is that I need to copy these files from my control machine to the proper location in my node machine. And we can do that using playbooks. So let me just show you the playbook to copy files. And the name of my file is deploy website. So this is my playbook to deploy my application. And here again I've used the 3 dashes, and then the name of my playbook is copy. The host, as you know, that it's going to be test servers. I'm using privilege escalation again, and I'm using become and become user again. Then gather facts again, true. And here is the list of the tasks. And the task is to just copy my file from my control machine and paste it in my destination machine, which is my node machine. And for that, and for copying, I've used the copy module. And copy module is a file module that Ansible comes with. So this is the syntax of the copy module. Here you just need to mention a source. And source is the path where my file is contained in my control machine, which is home, edureka, documents, and the name of the file is index.html. And I want it to go to var www html and it's index.html. So I should be copying my files into this location in order for it to display it on the web page. And similarly, I've copied my other PHP files using the same copy module. I've mentioned the source and destination. I'm copying them to the same destination from the same source. So I don't think any of you would have questions here. This is the most easiest playbook that we have written today. So let us deploy our application now. And for that we need to run this playbook. And before that we need to clear the screen because there are a lot of stuff on our screen right now. So let's run the playbook. And here we go. And it was very quick because there was nothing much to do. You just had to copy files from one location to another. And these are very small files. So let us go back to our host machine and see if it's working. So we're back again at our host machine. So let's go to my web browser to check that. So let me refresh it. And there it is. And so here is my first web page. So my application was successfully deployed. So now let us enter our name and email here and check if it is getting entered in my database. So let's put our name and the email. xyz.com and add it. So new record created successfully. It means that it is getting inserted into my database. Now let's go back and view it. And there it is. So congratulations, you have successfully written playbooks to deploy your application. You've provisioned your node machines using playbooks and orchestrated them using playbooks. Now, even though at the beginning it seemed like a huge task to do, Ansible playbooks made it so easy.
Hello everyone, this is Saurabh from Edureka. In today's session, we'll focus on what is Puppet. So without any further ado, let us move forward and have a look at the agenda for today. First, we'll see why we need configuration management. What are the various problems that industries were facing before configuration management was introduced. After that, we'll understand what exactly is configuration management and we'll look at various configuration management tools. After that, we'll focus on Puppet and we'll see the Puppet architecture along with the various Puppet components. And finally, in our hands-on part, we'll learn how to deploy MySQL and PHP using Puppet. So I'll move forward and we'll see what are the various problems before configuration management. So this is the first problem, guys. Let us understand this with an example. Suppose you are a system administrator and your job is to deploy MeanStack, say on 4 nodes. Alright, MeanStack is actually MongoDB Enterprise, AngularJS and Node.js. So you need to deploy MeanStack on 4 nodes. That is not a big issue. You can manually deploy that on 4 nodes. But what happens when your infrastructure becomes huge? You may need to deploy the same MeanStack, say on hundreds of nodes. Now, how will you approach that task? You can't do it manually because if you do it manually, it'll take a lot of time. Plus, there will be wastage of resources. Along with that, there is a chance of human error. I mean, it increases the risk of human error. All right. So we'll take the same example forward and we'll see what are the other problems before configuration management. Now this is the second problem, guys. So it's fine, like you in the previous step, you have deployed MeanStack on hundreds of nodes manually. Now what happens, there's an updated version of MongoDB available and your organization wants to shift to that updated version. Now, how will you do that? You want to go to the updated version of MongoDB. So what you'll do, you'll actually go and manually update MongoDB on all the nodes in your infrastructure, right? So again, that will take a lot of time. But now what happens, that updated version of the software has certain glitches. Your company wants to roll back to the previous version of the software, which is MongoDB in this case. So you want to go back to the previous version. Now, how will you do that? Remember, you have not kept the historical record of MongoDB during the updating. I mean, you have updated MongoDB manually on all the nodes. You don't have the record of the previous version of MongoDB. So what you need to do, you need to go and manually reinstall MongoDB on all the nodes. So rollback was a very painful task. I mean, it used to take a lot of time. Now this is the third problem, guys. Over here, what happens, you have updated MongoDB in the previous step on, say, development environment and in the testing environment. But when we talk about the production environment, they're still using the previous version of MongoDB. Now what happens, there might be certain applications that work that are not compatible with the previous version of MongoDB, all right? So what happens, developers write a code and that works fine in his own environment or be it his own laptop. After that, it works fine till testing as well. Now when it reaches production, since they're using the older version of MongoDB, which is not compatible with the application that developers have built, so it won't work properly. There might be certain functions which won't work properly in the production environment. So there is an inconsistency in the computing environment due to which the application might work in the development environment, but in product it is not working properly. So now what I'll do, I'll move forward and I'll tell you how important configuration management is with the help of a use case. So configuration management at New York Stock Exchange. All right. This is the best example of configuration management that I can think of. What happened? A software glitch prevented the New York Stock Exchange from trading stocks for almost 90 minutes. This led to millions of dollars of loss. A new software installation caused the problem. The software was installed on 8 of its 20 trading terminals and the system was tested out the night before. However, in the morning, it failed to operate properly on the 8 terminals. So there was a need to switch back to the old software. You might think that this was a failure of New York Stock Exchange's configuration management process, but in reality, it was a success. As a result of proper configuration management process, NYSE recovered from that situation in 90 minutes, which was pretty fast, let me tell you guys. Had the problem continued longer, the consequences would have been more severe. So because of proper configuration management, New York Stock Exchange prevented loss of millions of dollars. They were able to roll back to the previous version of the software within 90 minutes. So we'll move forward and we'll see what exactly configuration management is. So what is configuration management? Configuration management is basically a process that helps you to manage changes in your infrastructure in a more systematic and structured way. If you're updating a software, you keep a record of what all things you have updated, what all changes you are making in your infrastructure, all those things. And how you achieve configuration management? You achieve that with the help of a very important concept called infrastructure as code. Now, what is infrastructure as code? Infrastructure as code simply means that you're writing code for your infrastructure. Let us refer the diagram that is present in front of your screen. Now what happens in infrastructure as code, you write the code for your infrastructure in one central location. You can call it a server, you can call it a master, or whatever you want to call it, all right? Now that code is deployed onto the dev environment, test environment, and the product environment. Basically your entire infrastructure, all right? Whatever nodes you want to configure, you configure that with the help of that one central location. So let us take an example, all right? Suppose you want to deploy Apache Tomcat, say on all of your nodes. So what you'll do, in one location, you'll write the code to install Apache Tomcat, and then you'll push that onto the nodes which you want to configure. What are the advantages you get here? First of all, the first problem, if you can recall, that configuring large infrastructure was a very hectic job. But because of configuration management, it becomes very easy. How it becomes easy? You just need to write the code in one central location and replicate that on hundreds of nodes. It is that easy. You don't need to go and manually install or update a software on all the nodes. All right. Now the second problem was you cannot roll back to the previous stable version in time. But what happens here, since you have everything well documented in the central location, rolling back to the previous version was not a time consuming task. Now the third problem was there was a variation or inconsistency in various teams like dev team, test team, and product team. Like the environment, the computing environment was different in dev, test, and product. But with the help of infrastructure as code, what happens, all your three environments, that is dev, test, and product, have the same computing environment. So I hope we all are clear with what is configuration management and what is infrastructure as code. So we'll move forward and we'll see what are the different type of configuration management approaches are there. Now there are two types of configuration management approaches. One is push configuration, another is pull configuration. All right. Let me tell you push configuration first. In push configuration, what happens? There's one centralized server and it has all the configurations inside it. If you want to configure a certain amount of nodes, all right, say you want to configure 4 nodes as shown in the diagram. So what happens? You push those configurations onto these nodes. There are certain commands that you need to execute on that particular central location, and with the help of that command, those configurations which are present will be pushed onto the nodes. Now let us see what happens in pull configuration. In pull configuration, there is one centralized server, but it won't push all the configurations onto the nodes. What happens? Nodes actually poll the central server at say 5 minutes or 10 minutes, basically at periodic intervals, all right? So it will poll the central servers for the configurations, and after that it will pull the configurations that are there in the central server. So over here you don't need to execute any command. Nodes will automatically pull all the configurations that are there in the centralized server. And Puppet and Chef both uses pull configuration, but when you talk about push configuration, Ansible and SaltStack uses push configuration. So I'll move forward and we'll look at various configuration management tools. So these are the 4 most widely adopted tools for configuration management. I've highlighted Puppet because in this session we are going to focus on Puppet, and it uses pull configuration. And when we talk about SaltStack, it uses push configuration. So does Ansible. Ansible also uses push configuration. Chef also uses the pull configuration. All right. So Puppet and Chef uses pull configuration, but Ansible and SaltStack uses push configuration. Now let us move forward and see what exactly Puppet is. So Puppet is basically a configuration management tool that is used to deploy a particular application, configure your nodes, and manage your servers. Like they can possibly take your servers online and offline as required, configure them and deploy a certain package or an application onto the nodes, all right? With the help of Puppet, you can do that with ease. And the architecture that it uses is master-slave architecture. Let us understand this with an example. So this is Puppet master. Over here, all the configurations are present. And these are all the Puppet agents, all right? So these Puppet agents poll the central or the Puppet master at regular intervals. and whatever configurations are present, it will pull those configurations basically. So let us move forward and focus on the Puppet master-slave architecture. Now this is a Puppet master-slave architecture, guys. Over here what happens, the Puppet agent or the Puppet node sends facts to the Puppet master. And these facts are basically a key value, a data pair that represents some aspect of slave state. That aspect can be its IP address, uptime, operating system, or whether it's a virtual machine. And then Factor gathers those basic information about Puppet slave, such as hardware details, network settings, operating system, type and version, IP addresses, MAC addresses, all those things. Now these facts are then made available in Puppet Master's manifest as variables. Now Puppet Master uses those facts that it has received from the Puppet agent or the Puppet node to compile a catalog. That catalog defines how the slave should be configured. And the catalog is a document that describes the desired state for each resource that Puppet Master manages on a slave. So it is basically a compilation of all the resources that Puppet Master applies to a given slave, as well as the relationship between those resources. So the catalog is compiled by the Puppet Master and then it is sent back to the node. And then finally, slave provides data about how it has implemented that catalog and send back a report. So basically the node or the agent sends the report back that the configurations are complete, and they can actually view that in the Puppet dashboard as well. Now what happens, the connection between the node or the Puppet agent and the Puppet master happens with the help of SSL, the secure encryption, alright? We'll move forward and we'll see how actually the connection between the Puppet master and Puppet node happens. So this is how Puppet master and slave connection happens. What happens, first of all, the Puppet slave, it requests for the Puppet master certificate, alright? It sends a request for the master certificate, and once Puppet master receives that request, it will send the master certificate. And once Puppet slave has received the master certificate, Puppet master will again send a request to the slave regarding its own certificate, alright? So it will request for the Puppet agent to send its own certificate. The Puppet slave will generate its own certificate and send it to Puppet master. Now what Puppet master has to do? Puppet master has to sign that certificate, alright? So once it has signed the certificate, Puppet slave can actually request for the data, alright, or the configurations. And then finally Puppet master will send those configurations onto the Puppet slave. This is how Puppet master and slave communicates. Now let me show you practically how this happens. I've installed Puppet master and Puppet slave on my CentOS machines, alright. I'm using two virtual machines, one for Puppet master and another for Puppet slave. So let us move forward and execute this practically. Now this is my Puppet master virtual machine. Over here I've already created a Puppet master certificate, but there is no Puppet agent certificate right now. And how will you confirm that? There's a command that is Puppet cert list, and it will display all the certificates that are pending in Puppet master. I mean that are pending for the approval from the master, alright? So currently there are no certificates available. So what I'll do, I'll go to my Puppet agent and I'll fetch the Puppet master certificate which I've generated earlier, and at the same time generate the Puppet agent certificate and send it to master for signing it. So this is my Puppet agent virtual machine. Now over here, as I've told you earlier as well, I'll generate a Puppet agent certificate, and at the same time I'll fetch the Puppet master certificate, and that agent certificate will be sent to Puppet master and it will sign that Puppet agent certificate. So let us proceed with that. So for that I'll type Puppet agent -t, and here we go. Alright, so it is creating a new SSL key for the Puppet agent, as you can see in the logs itself. So it has sent a certificate request, and this is the fingerprint for that. So exiting, no certificate found, and wait for cert is disabled. So what I need to do is I need to go back to my Puppet master virtual machine and assign this particular certificate that is generated by Puppet agent. Now over here, if you want to see the list of certificates, what you need to do, you need to type Puppet cert list. I have told you earlier as well. So let us see what all certificates are there now. So as you can see that there is a certificate that has been sent by Puppet agent, alright. So I need to sign this particular certificate. So for that what I'll do, I'll type Puppet cert sign and the name of the certificate, that is Puppet agent, and here we go. So it has successfully signed the certificate that was requested by Puppet agent. Now what I'll do, I'll go back to my Puppet agent virtual image, and over there I'll update the changes that have been made in the Puppet master. Let me first clear my terminal. And now again, I'll type puppet agent hyphen T. Alright, so we have successfully established a secure connection between Puppet Master and Puppet Agent. Now let me give you a quick recap of what we have discussed till now. First, we saw what were the various problems before configuration management. We focused on three major problems that were there. Alright, and after that we saw how important configuration management is with the help of a use case of New York Stock Exchange. And finally, we saw what exactly configuration management is and what do you mean by infrastructure as code. We also looked at various configuration management tools, namely Chef, Puppet, Ansible, and SaltStack. And after that, we understood what exactly Puppet is and what is the master-slave architecture that it has and how Puppet Master and Puppet Slave communicates. All right, so I'll move forward and we'll see what use case I have for you today. So what we are going to do in today's session, we are going to deploy MySQL and PHP using Puppet. So for that, what I'll do, I'll first download the predefined modules for MySQL and PHP that are there in the Puppet Forge. All right. Those modules will actually define the two classes, that is PHP and MySQL. Now you cannot deploy the class directly onto the nodes. So what you need to do when you in Puppet manifest, you need to declare those classes. Whatever class you have defined, you need to declare those classes. I'll tell you what are manifest modules, so you don't need to worry about that. I'm just giving you a general overview of what we are going to do in today's session. So you just need to declare those two classes, that is PHP and MySQL, and finally just deploy that onto the nodes. It is that simple, guys. So as you can see that there will be a code for PHP and MySQL, and from that Puppet Master, it will be deployed onto the nodes or the Puppet agents. We'll move forward and we'll see what are the various phases in which we'll be implementing the use case. All right. So first we'll define classes. All right. Classes are nothing but the collection of various resources. How we'll do that? We'll do that with the help of modules. We'll actually download a module from the Puppet Forge and we'll use that module that defines two classes, as I've told you, PHP and MySQL. And then I'm going to declare that class in the manifest and finally deploy that onto the nodes. All right. So let us move forward, and before actually doing this, it is very important for you to understand certain basics of Puppet, like code basics of Puppet, like what are classes, resources, manifest, modules, all those things. So we'll move forward and understand those things one by one. Now what happens is, first of all, I'll explain you resources, classes, manifests and modules separately. But before that, let me just give you an overview of what are these things, all right? How do they work together? So what happens, there are certain resources, all right? A user is a resource, a file is a resource, basically anything that is there can be considered as a resource. So multiple resources actually combine together to form a class. So now this class, you can declare it in any of the manifests that you want. You can declare it in multiple manifests. All right. And then finally, you can bundle all these manifests together to form a module. Now, let me tell you guys, it is not mandatory that you will combine the resources and define a class. You can actually deploy the resources directly. It is a good practice if you combine the resources in the form of classes, because it becomes easier for you to manage. The same goes for manifests as well. And I'll tell you how to do that as well. You can write a Puppet code and deploy that onto the nodes. And at the same time, it is not necessary for you to bundle the manifest that you're using in the form of modules. But if you do that, it becomes more manageable and it becomes more structured, all right? So it becomes easier for you to handle multiple manifests. All right, so let us move forward and have a look at what exactly are resources and what are classes in Puppet. Now, what are resources? Anything that is there is a resource. A user is a resource. As I've told you, a file can be a resource. Basically, anything that is there can be considered as a resource. So Puppet code is composed primarily of resource declarations. A resource describes something about the state of the system. It can be such as a certain user or a file should exist or a package should be installed. Now here we have the syntax of the resource, all right? First you write the type of the resource, then you give a name to it in the single quotes and various attributes that you want to define. In the example, I've shown you that it will create a file that is inetd.conf, and this attribute will make sure that it is present. So let us execute this practically, guys. I'll again go back to my CentOS virtual machine. Now over here, what I'll do, I'll use the gedit editor. You can use whatever editor you want. And I'll type the path for my manifest directory. And in this directory, I'll define a file, all right, and with the .pp extension. So I'll just name it as a site.pp. And here we go. Now over here, the resource example that I've shown you in the slide, I'll just write the same example and let us see what happens. File, open the braces. Now give the path etc/inetd.conf colon and now I'm going to write the attribute. So I'm going to make sure that it is present. Ensure that the file is created. etc inetd.conf comma and then now close the braces. Save it and close it. Now what you need to do, you need to go to the Puppet agent once more, and over there I'm going to execute agent-t command that will update the changes made in the Puppet master. Now over here I'll use the Puppet agent-t command and let us see if the file inetd.conf is created or not. Alright, so it has done it successfully. Now what I'll do, just to confirm that, I'll use ls command. For that I'll type ls etc inetd.conf, and as you can see that it has been created. Alright, so we have understood what exactly a resource is in Puppet, right? So now let us see what are classes. Classes are nothing but the group of resources. Alright, so you group multiple resources together to form one single class, and you can declare that class in multiple manifests as we have seen earlier. It has a syntax. Let us see. First you need to write class, then give a name to that class, open the braces, write the code in the body, and then close the braces. It's very simple, and it is pretty much similar to the other coding languages that you if you have come across any other coding languages, it is pretty much similar to the class that you define over there as well. Alright, so we have a question from Mayank. He's asking, can you specify what exactly the difference between a resource and a class? Classes are actually nothing but the bundle of resources. Alright, all those resources grouped together forms a class, and what you can say is a resource describes a single file or a package, but what happens, a class describes everything needed to configure an entire service or an application. So we'll move forward and we'll see what are manifest. So this is Puppet manifest. Now what exactly it is, every slave has got its configuration details in Puppet master, and it is written in the native Puppet language. These details are written in the language that Puppet can understand, and that language is termed as manifest. So this is manifest. All the Puppet programs are basically termed as manifest. So for example, you can write a manifest in Puppet master that creates a file and installs Apache server on Puppet slaves connected to the Puppet master. Alright, so you can see I've given you an example. Over here it uses a class that is called Apache, and this class is defined with the help of predefined modules that are there in Puppet Forge, and then various attributes like define the virtual host and the port and the root directory. So basically there are two ways to actually declare a class in Puppet manifest. Either you can just write include and the name of the class, or you can, if you don't want to use the default attributes of that class, you can make the changes in that by using this particular syntax. That is, you write the class, open the braces and the class name, colon, whatever changes or whatever the attributes that you want apart from the one which are there in by default, and then finally close the braces. All right, so now I'll execute a manifest practically that will install Apache on my nodes. All right, now I need to deploy Apache using Puppets. All right, so what I need to do, I need to write the code to deploy Apache in the manifest directory. I've already created a file with .pp extension, if you can remember when I was talking about resources, right? So now again I'll use the same file, that is site.pp, and I'll write the code to deploy Apache. All right, so what I'll do, I'll just I'll use the gedit editor. You can use whatever editor you feel like. Etc Puppet manifest and site.pp, and here we go. Now over here I'll just delete the resource that I've defined here. I like my screen to be nice and clean. And now I'll write the code to deploy Apache. So for that I'll type package httpd colon. Now I need to ensure it is installed. So for that I'll type ensure installed, give a comma. Now I need to start this Apache service. So for that I'll type service httpd ensure running through a comma. Now close the braces. Just save it and close it. Let me clear my terminal. And now what I'll do, I'll go to my Puppet agent. From there, it will pull the configurations that are present in my Puppet master. Now what happens, periodically Puppet agent actually pulls the configuration from Puppet master, and it is around 30 minutes, right? It takes around half an hour. After every half an hour, Puppet agent pulls the configurations from Puppet master, right? So you can configure that as well. If you don't want to do it, just throw in a command puppet agent -t, and it will automatically pull the configurations that are present in the Puppet master. So for that, I'll go to my Puppet agent virtual machine. Now over here, what I'll do, I'll type a command puppet agent -t, and let us see what happens. So it is done now. Now what I'll do, just to confirm that, I'll open my browser, and over here I'll type the host name of my machine, which is localhost, and let us see if Apache is installed. Alright, so Apache has been successfully installed. Now let us go back to our slides and see what exactly modules are. So what are Puppet modules? Puppet module can be considered as a self-contained bundle of code and data. Let us put it in another way. We can say that Puppet module is a collection of manifests and data, such as facts, files, templates, etc. Alright, and they have a specific directory structure. Modules are basically used for organizing your Puppet code because they allow you to split your code into multiple manifests. So they provide you a proper structure in order to manage your manifest, because in real time you'll be having multiple manifests. To manage those manifests, it is always a good practice to bundle them together in the form of modules. So by default, Puppet modules are present in the directory /etc/puppet/modules. Whatever modules you download from Puppet Forge will be present in this module directory, alright? Even if you create your own modules, you have to create in this particular directory, that is /etc/puppet/modules. So now let us start the most awaited topic of today's session. That is deploying PHP and MySQL using Puppet. Now what I'm going to do is, I'm going to download the two modules. One is for PHP and another is for MySQL. So those two modules will actually define PHP and MySQL class for me. Now after that, I need to declare that class in the manifest inside .pp file present in the Puppet manifest. So I'll declare that class in the manifest, and then finally I'll throw in a command puppet agent -t in my agent, and it will pull those configurations and PHP and MySQL will be deployed. So basically when you download a module, you are defining a class. You cannot directly deploy that class. You need to declare it in the manifest. And now I'll again go back to my CentOS box. Now over here, what I'll do, I'll download the MySQL module from the Puppet Forge. So for that, I'll type puppet module install Puppet Labs -MySQL -- give the version name. So I will use 3.10.0, and here we go. So what is happening here? As you can see, it is saying preparing to install into /etc/puppet/modules, alright? So it will be installed in this directory. Apart from that, it is actually downloading this from the forge api.puppetlabs.com. So it is done now. That means we have successfully installed MySQL module from Puppet Forge. Alright, let me just clear my terminal, and now I will install PHP modules. For that, I'll type puppet module install -php version, that is 4.0.0 beta 1, and here we go. So it is done now. That means we have successfully installed two modules. One is PHP, another is MySQL. Alright, let me show you where it is present in my machine. So what I'll do, I'll just hit an ls command and I'll show you in Puppet modules, and here we go. So as you can see that there's a MySQL module and PHP module that we have just downloaded from Puppet Forge. Now what I need to do is I have defined MySQL and PHP class, but I need to declare that in the site.bp file present in the Puppet manifest. So for that, what I'll do, I'll first use the gedit editor. You can use whatever editor that you want. I'm saying it again and again, but you can use whatever editor that you want. I personally prefer gedit. And now manifest site.pp, and here we go. Now, as I've told you earlier as well, I like my screen to be clean and nice, so I'll just remove this. And over here, I will just declare the two classes, that is MySQL and PHP. Include MySQL server, and in the next line I'll include the PHP class. So for that I'll type PHP, just save it. Now close it. Let me clear my terminal. Now what I'll do, I'll go to my Puppet agent, and from there I'll hit a command Puppet agent -t that will pull the configurations from Puppet master. So let us just proceed with that. Let me first clear my terminal, and now I'll type Puppet agent -t, and here we go. So we have successfully deployed PHP and MySQL using Puppet. Alright, let me just clear my terminal, and I'll just confirm it by typing MySQL -v. Alright, so this will display the version. Now I'll just exit from here, and now I'll show you the PHP version. So for that I'll type PHP -version, and here we go. Alright, so this means that we have successfully installed PHP and MySQL using Puppet. So now let me just give you a quick recap of what we have discussed till now. Alright, so first we saw why we need configuration management. What were the various problems that were there before configuration management, and we understood the importance of configuration management with a use case of New York Stock Exchange. Alright, after that we saw what exactly configuration management is, and we understood a very important concept called infrastructure as code. Then we focused on various type of configuration management approaches, namely push and pull. Then we saw various configuration management tools, namely Puppet, Chef, Ansible, and SaltStack. And after that we focused on Puppet, and we saw what exactly Puppet is, its master-slave architecture, how Puppet master and slave communicates, all those things. Then we understood the Puppet code basics. We understood what are resources, what are classes, manifests, modules. And finally, in our hands-on part, I told you how to deploy PHP and MySQL using Puppet.
My name is Saurabh, and today we'll be talking about Nagios. So let's move forward and have a look at the agenda for today. So this is what we'll be discussing. We'll begin by understanding why we need continuous monitoring, what is continuous monitoring, and what are the various tools available for continuous monitoring. Then we are going to focus on Nagios. We are going to look at its architecture, how it works. We are also going to look at one case study. And finally, in the demo, I'll be showing you how you can monitor a remote host using NRP, which is nothing but Nagios Remote Plugin Executor. So I hope we all are clear with the agenda. Let's move forward, and we'll start by understanding why we need continuous monitoring. Well, there are multiple reasons, guys, but I have mentioned 4 very important reasons why we need continuous monitoring. So let's have a look at each of these one by one. The first one is failure of CI/CD pipelines. Since DevOps is a buzzword in the industry right now, and most of the organizations are using DevOps practices, obviously they are implementing CI/CD pipelines, or it is also called as digital pipelines, right? Now, the idea behind the CI/CD pipeline is to make sure that the release should happen more frequently and it should be more stable in an automated fashion, right? Because there are a lot of competitors you might have in the market, and you want to release your product before them. So agility is very, very important, and that's why we use CI/CD pipelines. Now, when you implement such a pipeline, you realize that there can't be any manual intervention at any step in the process, or the entire pipeline slows down. So you will basically defeat the entire purpose. Manual monitoring slows down your deployment pipeline and increases the risk of performance problems propagating in production, right? So I hope you have understood this. If you notice the 3 points that I've mentioned, it's pretty self-explanatory. Rapid introduction of performance problems and errors, right? Because you are releasing software more frequently, so there has to be rapid introduction of performance problems. Rapid introduction of new endpoints causing monitoring issues. Again, this is pretty self-explanatory. Lengthy root cause analysis as the number of services expands because you are releasing software more frequently, right? So definitely the number of services are going to increase. And there's a lengthy root cause analysis, because of which you lose a lot of time, right? So let's move forward and we'll look at the next reason why we need continuous monitoring. For example, we have an application which is live, right? We have deployed it onto production server. Now we are running APM solutions, which is basically application performance monitoring. We are monitoring our application, how the performance is there any downtime, all those things, right? And then we figure out certain issues with our application, certain performance issues. Now to go back, basically to roll back and to incorporate those changes, to remove those bugs, developers are going to take some time because the process is huge because your application is already live, right? You cannot afford any downtime. Now imagine what if before releasing the software, on a pre-production server, which is nothing but the replica of my production server, I can run those APM solutions to figure out how my application is going to perform when it actually goes live, right? So that way, whatever issues are there, developers will be notified before and they can take the corrective actions. So I hope you have understood my point. The next thing is server health cannot be compromised at any cost. So I think it's pretty obvious, guys. Your application is running on a server. You cannot afford any downtime in that particular server or increase in the response time also, right? So you require some sort of a monitoring system to check your server health as well, right? What if your application goes down because your server isn't responding? Right. So you don't want any scenario like that in a world like today where everything is so dynamic and the competition is growing exponentially. You want to give best service to your customers, right? And I think server health is very, very important because that's where your application is running, guys. I don't think so I have to stress too much on this, right? So we basically require continuous monitoring of our server as well. Now, let me just give you a quick recap of the things that we have discussed. So we have understood why we need continuous monitoring by looking at 3, 4 examples, right? The first thing is we saw what are the issues with CI/CD pipelines, right? We cannot have any sort of manual intervention for monitoring in such a pipeline because you're going to defeat the purpose of such a pipeline. Then we saw that developers have to be notified about the performance issues of the application before releasing it in the market. Then we saw server health cannot be compromised at any cost, right? So these are the 3 major reasons why I think continuous monitoring is very important for most of the organizations, right? Although there are many other reasons as well, right? Now, let's move forward and understand what exactly is continuous monitoring because we just saw a lot of scenarios where manual monitoring or our traditional monitoring processes are not going to be enough, right? So let us understand what exactly is continuous monitoring and how is it different from our traditional process. So basically, continuous monitoring tools resolve any sort of system errors before they have any negative impact on your business. It can be low memory, unreachable server, etc., etc. Apart from that, they can also monitor the business processes and the application as well as your server, which we have just discussed, right? So continuous monitoring is basically an effective system where the entire IT infrastructure, starting from your application to your business process to your server, is monitored in an ongoing way and in an automated fashion, right? That's what basically is the crux of continuous monitoring. So these are the multiple phases given to us by NIST for implementing continuous monitoring. NIST is basically National Institute of Standard and Technology. So let me just take you through each of these stages. First thing is define. So you need to basically develop a monitoring strategy. Then what you're going to do, you're going to establish measures and metrics. And you're also going to establish monitoring and assessment frequencies at how frequently you're going to monitor it, right? Then you are going to implement whatever you have established, the plan that you have laid down. Then you're going to analyze data and report findings, right? So whatever issues that are there, you're going to find that. Post that, you're going to respond and mitigate that error. And finally, you're going to review and update the application or whatever you were monitoring, right? Now, let us move forward. And Patriot has also given us multiple phases involved in continuous monitoring. So let us have a look at those also one by one. So the first thing is continuous discovery. So continuous discovery is basically discovering and maintaining near real-time inventory of all networks and information assets, including hardware and software. If I have to give an example, basically identifying and tracking confidential and critical data stored on desktops, laptops, and servers, right? Next comes continuous assessment. It basically means automatically scanning and comparing information assets against industry and data repositories to determine vulnerabilities. That's the entire point of continuous assessment, right? So one way to do that is prioritizing findings and providing detailed reports, right, by department, platform, network, asset, and vulnerability type. Next comes continuous audit. So continuously evaluating your client, server, and network device configurations and comparing them with standard policies is basically what continuous audit is, right? So basically what you're going to do here is gain insights into problematic controls using patterns and access permission of sensitive data, right? Then comes continuous patching. It means automatically deploying and updating software to eliminate vulnerabilities and maintain compliance, right? So if I have to give you an example, maybe correcting configuration settings, including network access and provision software according to end users' role and policies, all those things. Next comes continuous reporting. So aggregating the scanning results from different departments, scan types, and organizations into one central repository is basically what continuous reporting is, right? For automatically analyzing and correlating unusual activities in compliance with regulations. So I think it's pretty easy to understand. If I have to repeat it once more, I would say continuous discovery is basically discovering and maintaining an inventory, a near real-time inventory of all the network and information assets, whether it's your hardware or software. Then continuous assessment means automatically scanning and comparing the information assets from continuous discovery that we have seen against industry and data repositories to determine vulnerabilities. Continuous audit is basically continuously evaluating your client, server, and network device with configurations and comparing them with standards and policies. Continuous patching is automatically deploying and updating software to eliminate vulnerabilities and maintain compliance. Right? Patching is basically your remedy kind of a thing where you actually respond to the threats that you see or vulnerabilities that you see in your application. Continuous reporting is basically aggregating scanning results from different departments, scan types, and organizations into one central repository. So these are nothing but the various phases involved in continuous monitoring. Let us have a look at various continuous monitoring tools available in the market. So these are pretty famous tools. I think a lot of you might have heard about these tools. One is Amazon CloudWatch, which is nothing but a service provided to us by AWS. Splunk is also very famous, and we have ELK and NagOS, right? So ELK is basically Elastic Logstash and Kibana. In this session, we are going to focus on NagOS because it's a pretty mature tool. A lot of companies have used this tool and it has a major market share as well. And it's basically well suited for your entire IT infrastructure, whether it's your application or server or even it's your business process. Now let us have a look at what exactly is NagOS and how it works. So NagOS is basically a tool used for continuous monitoring of systems, your application, your services, and business processes, etc. in a DevOps culture, right? Now, in the event of failure, Nagios can alert technical staff of the problem, allowing them to begin remediation processes before outages affect business processes, end users, or customers. So I hope you're getting my point. It can alert the technical staff of the problem and they can begin remediation processes before outages affect their business process or end users or customers, right? With Nagios, you don't have to explain why an unseen infrastructure outage affect your organization's bottom line, right? So let us focus on the diagram that is there in front of your screen. So Nagios basically runs on a server, usually as a daemon or a service, and it periodically runs plugins residing in the same server. What they do, they basically contact hosts on servers or on your network or on the internet. Now, one can view the status information using the web interface, and you can also receive email or SMS notification if something goes wrong, right? So basically, Nagios daemon behaves like a scheduler that runs certain scripts at certain moments. It stores the results of those scripts and will run other scripts if these results change. I hope you're getting my point here, right? Now, if you're wondering what are plugins, so these are nothing but compiled executables or scripts. It can be Perl script, shell script, etc. that can run from a command line to check the status of a host or a service. Now, Nagios uses the results from the plugins to determine the current status of the host and services on your network. Now, let us see various features of Nagios. Let me just take you through all these features one by one. It's pretty scalable and secure and manageable as well. It has a good log and database system. It automatically sends alerts, which we just saw. It detects network errors and server crashes. It has easy writing plugins. You can write your own plugins, right, based on your requirement, your business need. Then you can monitor your business process and IT infrastructure with a single pass, guys. Issues can be fixed automatically. If you have configured it in such a way, then definitely you can fix those issues automatically. And it also has support for implementing redundant monitoring hosts. So I hope you have understood these features. There are many more, but these are the pretty attractive features, and why Nagios is so popular is because of these features. Let us now discuss the architecture of Nagios in detail. So basically, Nagios has a server agent architecture, right? Now, usually on a network, a Nagios server is running on a host, which we just saw in the previous diagram, right? So consider this as my host. So Nagios server is running on a host and plugins interact with local and remote hosts. So here we have plugins. So these will interact with the local resources or services, and these will also interact with the remote resources or services or hosts, right? Now these plugins will send the information to the scheduler, which will display that in the GUI, right? Now let me repeat it again. Nagios is built on a server agent architecture, right? And usually Nagios server is running on a host, and these plugins will interact with the local host or services or even the remote host or services, right? And these plugins will send the information to the scheduler, Nagios process scheduler, which will then display it on the web interface. And if something goes wrong, the concerned teams will be notified via SMS or through email, right? So I think we have covered quite a lot of theory. So let me just go ahead and open my CentOS virtual machine where I've already installed NagiOS. So let me just open my CentOS virtual machine first. So this is my CentOS virtual machine, guys, and this is how the NagiOS dashboard looks like. I'm running it at port 8000. You can run it wherever you want. I've explained that in the installation video how you can install it. Now, if you notice, there are a lot of options on the left hand side. You can go ahead and play around with it. You'll get a better idea. But let me just focus on few important ones. So here we have a map option here, right? If you click on that, then you can see that you have a local host and you have a remote host as well, right? So my Nagios process is monitoring both the local host and the remote host. So the remote host is currently down. That's why you see it like this. When I'll be running it, I'll be showing you how it basically looks like. Now, if I go ahead and click on host, you will see all the hosts that I'm currently monitoring. So I'm monitoring Edureka and local host. Edureka is basically my remote server, and local host is currently on which my Nagios server is running, right? So obviously it is up and the other server is down. If I click on services, you can see that these are the services that I'm monitoring. For my remote host, I'm monitoring CPU, load, ping, and SSH. And for my local host, I'm monitoring current load, current users, HTTP, ping, root partition, SSH, swap usage, and total processes. You can add as many services as you want. All you have to do is change the host.cfg file, which I'm going to show you later. But for now, let us go back to our slides. We'll continue from there. So let me just give you a small recap of what all things we have discussed. So we first saw why we need continuous monitoring. We saw various reasons why industries need continuous monitoring and how it is different from the traditional monitoring systems. Then we saw what is exactly continuous monitoring and what are the various phases involved in implementing a continuous monitoring strategy. Then we saw what are the various continuous monitoring tools available in the market, and we focused on NagiOS. We saw what is NagiOS, how it works, what is its architecture, right? Now we're going to talk about something called as NRPE, Nagios Remote Plugin Executor, which is basically used for monitoring remote Linux or Unix machines. So it'll allow you to execute Nagios plugins on those remote machines. Now, the main reason for doing this is to allow Nagios to monitor local resources, like CPU load, memory usage, etc. on remote machines. Now, since these public resources are not usually exposed to external machines, an agent like NRP must be installed on the remote Linux or Unix machines. So even I have installed that in my CentOS box. That's why I was able to monitor the remote Linux host that I'm talking about. Also, if you check out my Nagios installation video, I've also explained how you can install NRP. Now, if you notice the diagram here, so what we have is basically the check underscore NRP plugin residing on the local monitoring machine. This is your local monitoring machine, which we just saw, right? So this is where my Nagios server is. Now, the check underscore NRP plugin resides on a local monitoring machine where your Nagios server is, right? So the one which we saw is basically my local machine, or you can say where my Nagios server is, right? So this check underscore NRP plugin resides on that particular machine. Now this NRP daemon, which you can see in the diagram, runs on remote machines, the remote Linux or Unix machine, which in my case was Edureka, if you remember. And since I didn't start that machine, so it was down, right? So that NRP daemon will run on that particular machine. Now there is a secure socket layer SSL connection between monitoring host and the remote host. You can see it in the diagram as well, the SSL connection, right? So what it is doing, it is checking the disk space, load, HTTP, FTP, remote services on the other host, right? And these are local resources and services. So basically this is how NRP works, guys. You have an check underscore NRP plugin residing in the host machine. You have NRP daemon running on the remote machine. There's an SSL connection, right? Yeah, you have SSL connection, and this NRP plugin basically helps us to monitor that remote machine. That's how it works. Let's look at one very interesting case study. This is from Bitnetics. And I found it on the Nagios website itself. So if you want to check out, go ahead and check out their website as well. They have pretty cool case studies. Apart from Bitnetics, also there are a lot of other case studies on their website. So Bitnetics provides basically outsourced IT management and consulting to non-profit or small to medium businesses, right? Now, Bitnetics got a project where they were supposed to monitor an online store for an e-commerce retailer with $1 billion annual revenue. It's huge, guys. Now, it was not only supposed to, monitor the store, but it also needed to ensure that the cart and the checkout functionality is working fine. And it was also supposed to check for website defamation and notify the necessary staff if anything went wrong, right? Seems like an easy task, but let us see what are the problems that Bitnetics face. Now, Bitnetics hit a roadblock upon realizing that the client's data center was located in New Jersey, more than 500 miles away from their staff in New York, right? So there was a distance of 500 miles between where their staff is located and the data center. Now, let us see what are the problems they face because of this. Now, the two areas needed a unique but at the same time a comprehensive monitoring for their dev, test, and prod environment of the same platform, right? And the next challenge was monitoring would be hampered by the firewall restrictions between different application sites, functions, etc. So I think a lot of you know about this. Firewalls is basically sometimes can be a nightmare, right? Apart from that, most of the notifications that were sent to the client were ignored because mostly those were false positives, right? So the client didn't bother to even check those notifications. Now, what was the solution? So the first solution they thought is adding SSH firewall rules for network operation center, personnel, and equipment. Second is analyzing web pages to see if there's any problem or defamation occurrences. The third and the very important point was converting notification to NAGOS alerts. And the problem that we saw of false positive was completely removed with this escalation logic, where converting notifications to NAGOS alerts and escalations with specific time periods for different groups. Right? I hope you're getting my point here. Now, configuring event handlers to restart services before notification, which was basically a fix for 90% of the issues, and using Nagios core on multiple servers at the NOC facility. And each Nagios worker was deployed at the application level with direct access to the host. So whatever Nagios worker or agent or remote machine we have was deployed at the application level and had the direct access to the host or to the master, whatever you want to call it. And they have implemented the same architecture for production, quality assurance, staging, and development environments. Now let's see what was the result. Now, because of this, there was a dramatic reduction in notifications thanks to the event handler's new configuration. Then there was an increase in uptime from 85% annually to 98% annually, which is significant, guys, right? Then they saw a dramatic reduction in false positive because of the escalations logic that I was just talking about. Then fourth point is estimating the need to log into multiple boxes and change configuration files. Thanks to Nagios configuration maintained in a central repository and pushed automatically to appropriate servers. Fourth point is estimating the need to log into multiple boxes and change the configuration files. And that happens because the Nagios configuration maintained in a central repository or a central master and can be pushed automatically to all the slaves, to all the servers or slaves or agents, whatever you want to call it. So this was the result of using Nagios, right? Now is the time to check out a demo where what I'll be doing is I'll be monitoring a couple of services, actually more than a couple of services of a remote Linux machine through my Nagios host, which I just showed you, right? So from there, I'll be monitoring a remote Linux host called EduReka, and I'll be monitoring like 3, 4 services. You can add whatever you want. And let me just show you what's the process. Once you've installed Nagios, what you need to do in order to make sure that you have remote host or a remote machine being monitored by your Nagios host. Now, in order to execute this demo, which I'm going to show you, you must have LAMP stack on your system, right? Linux, Apache, MySQL, and PHP. And I'm going to use CentOS 7 here. So let me just quickly open my CentOS virtual machine and we'll proceed from there. So guys, this is my CentOS VirtualBox where I've already installed Nagios, as I've told you earlier as well. And this is where my Nagios host is running, or you can say the Nagios server is running. And you can see the dashboard in front of your screen as well, right? So let me just quickly open the terminal first. Let me clear the screen. So let me just show you where I've installed Nagios. So this is the path, right? If you notice in front of your screen, it's in user local Nagios. What I can do is I'll just clear the screen and I'll show you what all directories are inside this. So we can go inside this etc directory, and inside this, I'm going to go inside the objects directory, right? So why I'm doing this is basically if I want to add any command, for example, I want to add the check_nrp command. That's how I'm going to monitor my remote Linux host, if you remember in the diagram, right? So that's what I'm going to do. I'm going to add that particular command. I've already done that. So let me just show you how it looks. So I'll just type gedit, or you can choose whatever editor that you like. and go inside the commands.cfg file, and let me just open it. So these are the various commands that I was talking about. Now you can just have a look at all of these commands. So this is to basically notify host by email if anything goes down, anything goes wrong in the host. This is for service. Basically, it'll notify if there's any problem with the service through email. This is to check if my host machine is alive. I mean, is it up and running? Now, this command is basically to check the disk space, like the local disk, then the load, right? You can see all of these things here, swap, FTP. So I've added these commands, and you can have a look at all of these commands which I've mentioned here. And the last command you see is I've added manually, because all of these commands, once you install, you get it by default. But the NRP check underscore NRP, which I'm highlighting right now with my cursor, is something which I have added in order to make sure that I will monitor the remote Linux host. Now let me just go ahead and save this, right? Let me clear my screen again, and I'll go back to my Nagios directory. Let me clear my screen again. Now, basically what this will do is this will allow you to use the check underscore NRP command in your Nagios service definitions, right? Now, what we need to do is update the NRP configuration file. So use your favorite editor and open nrp.cfg, which you will find in this particular directory itself. So all I have to do is first I'll hit ls, and then I can just check out this etc directory. Now, if you notice, there is an nrp.cfg file, right? I've already added it, so I'll just go ahead and show you with the help of gedit, or you can use whatever editor that you prefer. Now over here, you need to find this allowed host directive and add the private IP address of your Nagios server to the comma delimited list. If you scroll down, you will find something called allowed host, right? So just add a comma and start with the IP address of the machine that you want to monitor. So currently, let me just open it once more. So I'm going to use sudo because I don't have the privileges. Now in this allowed host directory, all I have to do is comma and the IP address of the host that I want to monitor. So it is 192.168.1.21. Just go ahead, save it, come back, clear the terminal. Now save and exit. Now this configures NRP to accept requests from your Nagios server via its private IP address, right? And then just go ahead and restart NRP to put the changes into effect. Now on your Nagios server, you need to create a configuration file for each of the remote hosts that you monitor, as I was mentioning before as well. Now, where you're going to find it in etc servers directory, and let me just go ahead and open that for you. Let me go to the servers directory. Now, if you notice here, there is edureka.cfg file. This is basically the host that I'll be monitoring, right? Now, if I go ahead and show you what I have written here, is basically first what I've done is I've defined the host. It's basically a Linux server, and the name of that server is edureka, alias whatever you want to give. This is the IP address. Maximum check attempts, the periods, I want to check it 24/7. Notification interval is what I've mentioned here, and notification period. So this is basically about all my hosts. Now in that host, what all services I want to monitor? I want to monitor generic services like ping, then I want to monitor SSH, then I'm going to monitor CPU load as well. These are the three services that I'll be monitoring, and you can find that in your etc servers directory. Over there, you have to create a proper configuration file for all of the hosts that you want to monitor. Let me clear my terminal again. Just to show you my remote machine as well, let me just open that. So this is my remote machine, guys. Over here, I've already installed NRP. So over here, I'm just going to show you how you can restart NRP systemctl restart nrpe.service. And here we go. It's asking for a password. I've given that. So my NRP service has started. Actually, I've restarted again. I've already started it before as well. Let me just show you how my Nagios dashboard looks like in my server. Now this is my dashboard again. If I go to my host tab, you can see that we are monitoring two hosts, edureka and localhost. Edureka is the one which I just showed you, which is up and running, right? I can go ahead and check out this map, legacy map view as well, which basically tells me that my edureka is a remote host. Then also I have various services that I'm monitoring. So if you remember, I was monitoring CPU load, ping, and SSH, which you can see it over here as well, right? So this is all it for today's session. I hope you guys have enjoyed listening to this video. If you have any questions, you can go ahead and mention that in the comment section. And if you're looking to gain hands-on experience in DevOps, you can go ahead and check out our website www.edureka.co/DevOps. You can view upcoming batches and enroll for the course that will set you on the path of becoming a successful DevOps engineer. And if you're still curious to know more about the DevOps roles and responsibilities, you can check out the videos mentioned in the description. Thank you and happy learning.